Hey there, friends. My name is Jeff Fritz, and welcome to .NET Conf Focus on AI. We've got a full day of content available here for you, all about the great things that you can do with artificial intelligence technologies and .NET. Now, whether it's programming with C#, whether it's building web applications, we've got all kinds of sessions today that are going to help you to dial in some of those artificial intelligence features that you've been thinking about and wanting to get working with your applications. We've got sessions today talking about RAG. We've got sessions talking about large language modules. We're even going to talk about building your own Copilot. We've got a great keynote to start things off with our friends Scott Hanselman and Maria Naggaga. And I want to make sure that you tune in and check out all the content we have throughout the day. Of course, this event is being presented live on YouTube and Twitch, and the recording is being made available on YouTube. Now, we've got a ton of links available for you that you can check out. We've got QR codes for you that are going to help you find some of this content and follow up and take some home so you can share with your friends. So, let me show you a couple of the links that we have available for you on our slides right here. So, the .NET Conf Focus on AI, check out the collection at aks.netfocusai/learn, or take a picture of the QR code there. We've got lots of QR codes for you throughout the slides that I have here, all right? Now, we also have a survey. Let us know what you think of how we're doing, not just with this event, but how we can do more with AI, give you more capabilities in your .NET tool set. All right, aka.ms/.netfocusai/evaluation, or you can take a picture of that QR code once again to get to that evaluation and give us a little bit of feedback. We have a challenge for you, an AI challenge, and some additional live streams through the month of September. Go to aka.ms/.netfocusai/credential challenge live. August 20th to September 20th. You can take a picture of the QR code to get there. And we're going to have all kinds of live streams scheduled throughout the month, focusing on more of those AI capabilities that we're going to discuss throughout the day today. A bunch of different hosts talking about the various technologies that are added into .NET to help make you and your application successful, along with a little challenge to scratch that itch, that part of your brain that's going to make this a little bit more interesting and fun to do more with AI in your .NET applications. We've got all of the links for this event. We have it in a collection along with the Learn modules that teach more of the capabilities that we're going to be talking about today at aka.ms/.netfocusai/collection. Once again, that QR code will take you to that same location so you can get all of the links, all of the things that we're talking about today in one place. Now, this is .NET Conf Focus on AI. We got to make sure that we call out that, of course, .NET Conf 2024, featuring the .NET 9 launch, is coming up in November. So we've got 3 full days for you coming up in November. You can learn more at .NETconf.net. We've got a call for content there. If you're a prospective speaker, there's more than 30 sessions available for community speakers to participate and give their content as part of this event. Now, that happens during day 3. This is a 3-day event. Day 1 and day 2, we've got a little bit during the day where we're going to have folks from Microsoft presenting and talking about the .NET 9 launch, the next version of .NET. But that 3rd day, we go 24 hours around the clock. Everybody from every time zone is going to be able to find content at your time that's being presented and talking about cool technologies and techniques for you to learn about with .NET. So make sure you join us November 12th through the 14th, .NETconf.net. There's a save the date button there you can click. We've even got a link for prospective speakers to participate. And finally, of course, we wouldn't be able to present this event, we wouldn't be able to work through this without help from some of our sponsors. Make sure you check out these folks. They've been promoting the event. They've even put together a little bit of a swag bag for you that you can enter and potentially win prizes from all of these organizations: Growth Acceleration Partners, Meshius, Progress Telleric, ABP, Avalara, Iron Software, Code Magazine, Octopus Deploy, Syncfusion, and Nostis. Make sure you check out. They have a swag bag that's worth more than $5,000. 15 folks are going to get these. Fill out your evaluation at aka.ms/.NETFocusAI/evaluation. All right. There's gift cards, there's software licenses. Fill out the evaluation. There's a link in there for you to click that'll take you into filling out and participating in the swag bag raffle. All right. Let's get started. It's time to get into our content and learn more about .NET and AI. We're going to hand it off to our friends, Scott and Maria.
Hey, friends, I'm Scott Hanselman.
Hi, and I'm Maria Naggaga.
And we are going to talk to you about AI today. We're going to talk about .NET and how AI and .NET are the match made in heaven. We're going to do some really cool stuff. We're going to augment applications, take them from modern apps to intelligent apps, right, Maria?
Yes, and most importantly, we're going to make sure that you feel like you can do it too.
I love that. I want to feel powerful. I want to be able to make my applications even cooler. So what we're going to do is I'm going to take a moment. I'm going to give you a little bit of context about how we're thinking about AI. And then when I'm done with that, we'll bring Maria back and we'll get into some real demos.
Can't wait.
All right, let's go. I'm going to bring up my screen over here. And I want to call out that in GitHub here, there's lots of ways to interact with Copilot. I'm using Visual Studio Code. I could be using Visual Studio for Windows. I could be using GitHub on the web. It's all that same Copilot on the back end. Now, we see lots and lots of demos where someone will go and type something and generate a bunch of code. And that's a perfectly fine demo, and that's a great, powerful feature in GitHub Copilot. But one of the things that I think isn't talked about enough is using it as a pair programmer, kind of as a rubber duck. A rubber duck programming model is the kind where you put a rubber duck. This is my Borg Microsoft rubber duck. And I just put him on my monitor here. And if I have questions, I'll just talk to the duck and I'll say, hey, I'm stuck on this programming problem. Now, the issue is that the duck doesn't talk back, but GitHub Copilot can. It is an infinitely patient, friendly pair programmer, unlike my duck, which is very quiet, that will brainstorm with me. So I can go in here and I could click Start Voice Chat down in the corner, because I've got some mobility challenges right now in my hands. So accessibility is baked in as well. I'm going to say voice chat. I could also type. What do you think about this code? Are there any opportunities to make it more secure? And this is really great here. I want to pause and back up for a second and call out used one reference. It's actually indicating that it knows which part of the code we're talking about. It's not looking at the entire code base. It's referencing a section of that code base. I can select that code and say, hey, Copilot, explain this, fix this, review it. Perhaps you want to generate docs, generate tests, but I want to understand from my pair programmer here what it thinks I could do to make some improvements. So I'm going to say, what do you think about this code? And it says, yeah, there's a couple opportunities here. You can parameterize the URL because I'm not building that URL in a thoughtful way. I am not, in fact, catching all of my exception handlings. And I could be checking out things like SSL. And then it offers some revisions, some actual thoughtful revisions about how I could change that code. And if I didn't want this information, if I wanted to have a different information, I could be more specific. I could say, select this and say, explain this chunk of code, for example. I'm providing less context and it's getting deeper. I'm only giving it lines 60 through 66. And then, this is cool, it can actually offer a follow-up question, which was something I was actually going to ask it anyway. What does the await keyword do? I can just click on that and GitHub Copilot's going to give me a follow-up. So I'll have big, long conversations, brainstorming with my GitHub Copilot. And I think about it as this kind of friendly junior engineer that can just sit there and help me better understand my code. And it's patient. It's infinitely patient. It'll sit there and talk to me as long as possible. Now, my application is modern, but it is not intelligent. So I want to bring Maria in from the .NET AI team to share what the .NET team has been doing in this space. And maybe I can make my application and other applications a lot more intelligent.
Yeah, thank you, Scott. So I'm going to share my screen for a bit. I wanted to start with what we are committed to in the .NET team when moving from one tech wave to another. .NET has been there through every single major shift that we have had in the past 20 years. We were there with you for mobile. We were there for you for cloud native. We were there for you cross-platform. And now we are here for you in AI. And our goal here is to make it as easy and as simple as possible for you to leverage AI into your application. Now, we understand the AI ecosystem is incredibly vast. Like, you've probably seen how vast it is, Scott.
Absolutely. There's a ton of players, a ton of code words and three-letter acronyms that I'm still learning to this day.
And I'm hoping during this keynote, we can guide people through this journey on how we are making AI more approachable for you. So when we thought about our investments in AI, we wanted to make sure that it resonated with where developers were going to learn, how they were building their application, as well as making sure that when we were going into the AI ecosystem, we were showing up in places where .NET developers were learning about AI. We wanted to ensure that you were able to deploy these applications easily. And most importantly, you want to be able to monitor them in production to make sure that your customers and your developer experiences and your engineers know what's happening to their application. On the learn side, we set out to build a bunch of samples. This was a great experience for us as a team because it put us in our developers' shoes. We were learning as they were learning. So as we were building these samples, it allowed us to start identifying core building blocks that we needed to enable in .NET so that you could compose these AI components, whether they were first party or third party. In the .NET side, we made investments in core AI building blocks such as tokenizers and tensors so that we would enable to build things like vector stores with other teams. We work very closely with the Semantic kernel team that sits right here in the Octo at Microsoft. The Semantic kernel enables developers to easily attach to the AI ecosystem. In the AI ecosystem, we wanted to make sure that we were working with places like OpenAI, and at Build, we announced the C# OpenAI client. We also worked with vector stores such as Quadrant and Milvus to build a first-class C# experience. And currently, we're working with Pinecone to build a C# experience as well. We also enable in the deploy scenario to meet developers in exciting new places like .NET Aspire, for developers to be able to easily integrate with Azure AI, as well as easily deploy with AZD. And finally, because of Aspire and Azure Monitor, you can now monitor your applications in production. So, before I go into demo, I'd like to bring Scott back. So Scott, do you know what RAG is?
I hear the term RAG a lot. I know the R is retrieval, but I'm still learning my TLAs, my three-letter acronyms.
Okay, so RAG is a technique which stands for retrieval, augmentation, and generation. So before I show you the chatbot, let's go through a tiny scenario. So you know me, I like my comics, I like to draw. So I came up with a comic book story. So Scott, imagine you were a customer agent and you were presented with a ticket of a customer complaint. How would you go about figuring that out?
It all comes down to context. I want to understand the problem. I want to find them a solution, but I want to understand, have they talked to us before? Do I know anything about them? I would want to explore this problem space.
And this is where something like RAG will happen. So I'm going to explain RAG in 3 steps. Let's start with retrieval. So if I was a customer support agent, as you mentioned, you'd like to know context of where this was happening before. If you were working in an office today, you'd probably have to look over to your boss or look over to somebody else and ask them for advice. or you'd have to read through a bunch of documentation. Now, in this scenario, the customer, who in this case is a customer support agent, could ask a bot a question. This question is then passed on to a smart retriever, and this is called the retrieval section. In the retrieval section, we take that question and then we look up based on domain knowledge. In this case, that would be the customer support tickets. Now, based on things like semantic relevance and cosine similarity, what the AI will do is retrieve relevant documents. Now, that's phase one. Are you with me so far?
Yeah, I think the part that really clicked for me just a second there is that we're not trying to think that a very large language model knows everything. It doesn't know everything about all knowledge in the world. It's a text-based generator. It knows a lot about some stuff, but it doesn't know about my domain, about my customers, about the issues. So it's that domain knowledge that clicked for me. You're augmenting the large language model with specific domain knowledge. And I assume that comes from anywhere. You decide. You, the developer, gets to decide where that domain knowledge comes from.
Yes, and in AI, you'll hear about things like grounding. This allows us to ground the data specific to our scenario. Now, you jumped ahead. Like, this just shows how far you are in this journey, Scott. You jumped to augmentation.
Ah, okay. So, I didn't realize.
Which is good, which means everybody else as a .NET developer will begin to connect the dots too.
Excellent.
So the next thing with augmentation is we have the data. So it knows maybe you've asked about a water bottle, right? So it's looking for everything relevant to a water bottle. Now it's going to pair the water bottle with your original question, and it's going to use the LLM to further analyze this data. This makes sure that it probably does additional relevancy checks, because some of the data that might have been pulled could have been every single water bottle, not the H2O water bottle. So the LLM comes into place yet again with a model in order to do that for you.
Okay, so this is that grounding. I don't want it to talk about other things the customer may have bought. I don't want to talk about the entire product catalog. We're slowly narrowing the problem space down, given context, given domain knowledge.
Yeah, exactly. That's reducing things like hallucinations.
Right. I don't like to use that term hallucinations, and I love that you said grounded, because you're kind of showing you can fabricate, you can generate, you can see these models kind of float away like a balloon. But I love that you said you want to ground it in the domain knowledge, and that way it stays on task.
Yes. So you want truth versus hopeful truths.
That's I love that analogy. Thank you for that.
So the next one is like, okay, we have our question, we have our response, we have to generate a response. And the response has to come back in a format that makes sense to the customer support agent. And this is when natural language comes to play. And then it is sent right back.
I dig it. I'm picking up what you're putting down.
Okay. So I'm going to switch screens and I'm going to show you RAG in code.
Ooh, demos, live demos.
Oh yeah, I haven't demoed in a while, so please show me some patience.
No, absolutely, I'm excited.
Okay, so we are in VS Code, and I am going to show you the RAG loop, simply in code. Like, we're not going to get into details on ingesting and chunking and storing the data. There's so many presentations throughout the day that will show you how to do that, but I would like to show you the RAG loop. The RAG loop, the first one is retrieval, where you are doing a search for the results against a set of documents. We're going to look at the ticket, the product ID, the value, as well as the query. The query in this case is the question, but this could also mean something as simple as summarization as well. We're then going to pair the query in the augmentation section, where we're going to start using the LLM to start even narrowing down our context. And finally, we are then going to generate the responses and give them back to the user. So let's run this application. So Scott, I'm going to show you this with AI and without AI, so you begin to notice the value of adding AI into your application. You ready?
Ready, because we're going to see a modern application become an intelligent application. I like it.
So I don't want to be too fussy. I'm going to keep it simple. We're going to stick to the console first. Okay. So first thing I'm going to do is I'm going to run this app. So I already ingested the data before because the ingestion section process can take a while. And we want to make sure that people don't get hung up on that. So I've already ingested the data. I am inspecting the ticket. And I'm just going to pick on one of them. Let's look at the filter cartridge. Now, if you look at this, it's a customer agent interaction. This means this is a pretty good system, but that means I have to read through this. And if you're dyslexic like me, it can take a while.
To be clear, though, I want to make sure I understand. So what we're looking at is an actual transcript of real humans talking to each other.
Exactly.
This is not AI. These are a transcript of a chat between a customer and an agent with a question. And to your point, to absorb this for anyone is a lot. There's a lot here, dyslexic or not. I'm still kind of, my eyes are blurred as I'm ready to it's like when you get on hold and they say, hang on, and they go and they have to read and catch up. That's going to take a long time.
It's going to take a long time. So how do we help people through that process? Let's summarize the information so people have context, which will enable greater customer satisfaction. So I'm going to go back to my code. I'm going to do a little bitty trick. As you can see, I'm a first-class typist, commenting and uncommenting lines. And we're going to restart this application. And right here, I have added AI to do the summary. So what we should see is a summarization of this conversation. We'll do $1 again.
Okay. And you're doing this as a developer, so you're seeing the compilation and the running and the starting up process takes a little bit of a time here because you've changed code, recompiled it, and are running it again.
Exactly. And if you are doing this in a real app, have you ever used AI where you see the dots happening?
Yeah.
That's the kind of UI elements that we can give to customers so they know that something's happening in the background.
Absolutely.
So we're going to hit inspect. We're going to pick the exact same entry. And right now, we have a summary right on top.
See, that's a delighter. I think of that as a customer delighter. I'm thinking of our friends at the Storygraph that have a book reading reviewer site, and it's like there's 1,000 reviews of a book. Give me a little thing at the top that says, "Hey, what's a summary?" So you've made it so I can read a sentence and choose if I want to read the entire multiple paragraphs. That's going to make scanning that a lot more easy.
A lot easier. Here we have only a few thousand entries, but you can imagine if people had millions over years, over different data stores. How effective would that make them?
Yeah, and you could say from a user interface perspective, you might say AI generated summary. And that gets to that responsible AI perspective where a customer service agent who is in their application experiencing this for the first time would say, oh, okay, I see that part in the yellow at the top is an AI generated summary. And I see that the bottom was real humans talking. And that makes it really clear what's going on here, which is super cool.
Yeah, our whole thing is not to remove the personal touch that people get when interacting with a real human.
Yeah, that makes a lot of sense. I like it. All right.
So how can we do an AI demo without chat?
I appreciate that because chatbots are kind of the easy thing to do. And it's nice and refreshing to see just little delightful moments of AI that are taking my application +1, ++, as opposed to the chatbot, all the things.
No, chatbot only when needed is my problem. But I'm going to show you a chatbot anyway.
That's okay, because the important thing there is to show the ability to do anything in .NET, whether it be a chatbot or a delightful improvement in an application here.
All right, so the last secret sauce. We are going to enable chat. And there we have it. .NET run one more time. We inspect it, we enter. Now we have a summary plus the conversation. Yeah. I want to begin a chat, and we're like, okay, so this is about a filtration system. So I could ask a question: how many times should I distinguish the filter? And it gives me a summary that I can go read and I can personalize on my own to help the customer through their issue.
Oh, interesting. So the chatbot in this context, and maybe I'm understanding this correctly, is the agent is getting a way to search using RAG through all of the different facts and documentation so that they could still make a recommendation to the user. So you could make this chatbot for the back end, for the support person, or for the front end for the customer. It's up to you.
It's up to you. And in this case, what I also wanted, like you caught onto something. Think about domain knowledge. It's not enough just to know about what the format issues were. You also need to know where the manuals to the products that you are referencing, because the two of them provide you with a customer solution. And the beauty of AI, and especially when it comes to data ingestion, is the format of the data shouldn't matter. We should be able, whether it's a text or whether it is a PDF or whether it is an image or whether it is anything, as long as these all come together to form context, we should provide a meaningful experience for our users. So you caught something on it's like, okay, I was looking at this data, we were looking at the agent interaction, but then you just asked about something specific to the product. And how did you get them both to work together? And that's what data ingestion does.
I see. So that ingestion thing is important. That data might be the product catalog, it might be JSON files, it might be PDFs, it might be Markdown, it might be all of the above, and that's that important step.
Exactly. And going back to grounded versus ungrounded results.
Okay. Very cool. I dig it. And will this code be available? Like, this seems like something I'm going to want to put on my site.
Oh, it will be available. So if you go to .NET AI samples, we'll have links at the end of our keynote. This will be available. So you can use it as soon as you watch this video.
Okay, so maybe I'm putting you on the spot here. I love a good console app, and I want to give you credit for having a colorful console app because you had Interact, you're using Spectre console. It's beautiful. It's multiple colors and stuff like that. Do you have anything that shows me RAG maybe a little more towards a web application, like my web application?
Oh, Scott, let me just show you something I read earlier, like we do in all cooking shows. We've done the technical challenge. Now we're doing the showstopper.
I love it. I love it.
So you are familiar with eShop, correct?
Yes. eShop is one of our big samples. Sample applications historically have been kind of simplistic, like the Northwind sample is like products. eShop is a fully formed, very fleshed out, sophisticated sample that shows you how to do container orchestration, microservices, really big, sophisticated application. It's quite a extensive sample.
It is, but I have a new version of eShop. Can you guess what it is?
I suspect that you've added AI and RAG to make it even more fabulous.
I have, but I also wanted to focus on core scenarios. Going back to the chatbot conversation, like everything in November, we showed eShop with a chatbot where you could ask what products were available. That's great. But when we did research, we found that customers, developers, everyone in the industry really wanted AI to help them with the mundane, tedious tasks, such as summarization, translation, sentiment analysis, right? They want you to guess how your consumers were feeling about the experience. So I am going to show you the beautiful version of the console application.
I love it. The Maria-ified version.
Exactly. Very demure.
Right. Let's see it.
We're going to start from a customer scenario. So let's say I'm a customer, right? And I am opening up a new support ticket. So I'm going to start a new request. Is it about a specific product? Yes, it is. Now, How many times have you tried to fill in like a customer support request, and you have to either go back to your email or go back to like your outbox and figure out your inbox of Amazon or another product and try to figure out what the name of the product was?
Yeah, I mean, they're not very sophisticated, right? Oftentimes the support ticket page is just a bunch of text boxes that are not clever text boxes, and I just end up typing into them, and I presume that it generates some email on the back end. It's not a smart box.
No, it isn't. So I'm going to show you something. I'm just going to start typing, okay? What do you see?
So it's auto-completed, but you typed in bottle and it found bottles. Cool.
It found bottles. Now, it only found bottles that AdventureWorks sells. And we did this with something called Smart Components. So Smart Components is like a UI AI element that we experimented with on the .NET team. So Steve Sanderson built this together and said, how would developers, how would consumers actually benefit from AI inside of their UI? So this is an experience of it. Customer didn't have to go back and forth. They didn't have to copy and paste. They're like, oh, I remember buying an Aquaflow 750 million liter water bottle. Mm-hmm. So you can do that.
Right. And if I understand correctly, you could be even more vague. That's not just a search autocomplete box. You could say H2O. You could misspell bottle. You could say, the liquid holder thing, and it would figure out that it was one of those water bottles.
It would. Now, that's the beauty of like adding smartness to your application, intelligence to it. So I'm going to just write something pretty vague, which is like, my bottle is leaking, ! I am unhappy, right? And I can submit it. And there we go. As you can see, I'm a frequent complainer.
Yeah, apparently this is a real problem that you need tech support for a bottle, but
So let's go and look at what the customer support agent would see.
Gotcha.
We're going to look at this. Now, let me zoom in a little because I want you to feel the magic of this. Okay, so we have Alice. So Alice is a frequent complainer. That is me. But what you will notice is it gives it a sentiment analysis.
Oh, see, I love a good emoji. I appreciate that.
Me too, right? It gives it a sentiment analysis of like, hey, Alice has been here before, and this time she is not happy. And it also gives a satisfaction rate, which means I could either have not answered it. So even from a person who's using this app for the first time, they know which ones to address first and what are the most important cases, simply by a glance.
This is great. I love that I picked on you a little bit when you showed me the chat bot, but what I'm seeing are delightful little improvements that are making apps more pleasant, more helpful, more accessible, easier to explore, easier to absorb. It's the toil. We've talked about this. Like, oh, you're a tech support person. They've come with a complaint. Here, read 2 pages of text. Or you're a tech support person. You've got a crushing list of 349 open tickets. Find the ones that are the most mad.
Yeah.
You've solved those problems with code with .NET.
Backing. And this is all .NET. This is Blazor. This is full stack. There is no magic here. It is just .NET. And this code will be available as well for everyone to use. And Steve Sanderson will go into more details on how he built this. Like, I think you can sense this is a Steve Sanderson application.
Yeah, the team is doing a great job. Steve is a great communicator. We're seeing a lot of really, really cool sample code being created that's very actionable. I could imagine going and putting RAG on my podcast site, which is written in .NET, having people ask questions about the last 400 hours of content. Hey, I was looking for that episode where Maria was on the show talking about AI. She said something, something, something. Can you find that? That would be a cool feature I could add to my podcast.
I would install the Hanselman AI podcast. Like, we should build that for .NET 9.
We should do that. Let's get on that.
Okay, so I am not willing to deal with Alice right now. So let's see if Sarah's a little bit happier. So I'm going to click on that. Now, back to this. What you note, let me zoom out. This is a bit too big because you're not seeing the magic. Remember the summary? We see the summary up here as well.
Nice.
We also have a real life conversation history between Sarah and the previous agent. So if I am the new agent who's on shift right now, I have access to this information and I have a summary of what happened before me. So
that is cool. That is really cool.
Pretty cool. So I can ask questions like, Sarah's had an issue. She wants a refund, right? Because there's been a lot of our replacement. So why don't I ask AI if we can issue a refund? And we issue Sarah.
All right, so I think we can zoom in a little bit on that again, go back to the larger fonts. And so the assistant has gone and searched for refund policy, probably through a bunch of manuals and a bunch of knowledge bases, and it's providing back-end help for an assistant, which would allow that person to be up to speed faster. It would make it more fun to do their job, and it would make it less stressful.
Exactly. But this is what I think is also really important. Talking about grounding, we also want to be being ethical. We want to also show you where that information is from. So you can see a little reference here. You probably also noticed it when you use Bing, for example.
Yeah, that's a great point. If I'm focused on asking it a question about specific things, I don't want to go and suddenly start talking to my customer support chatbot about, Elden Ring or whatever. And it would say, oh, I'm not a video game chatbot. I'm a customer support chatbot. I want to ground it in the situation, which is this knowledge base article and those things that are important to my job. I don't want to chat about random stuff. So I need to keep it on topic.
Exactly. And what I love about this is that, look, it highlights exactly where it's from. So you don't even need to read the 10 pages.
Oh, wow. Okay, hang on. That's great. So it's referenced it just like we saw in GitHub Copilot, where it said, here's the lines of code that I'm looking at. This is the section that is my context, and it highlighted it. This is telling you not just the doc that it found it at, but it highlighted the line that it's referencing. That is grounded. I dig it.
That is very grounded. So you could use this for a couple of things. You could, one, ask AI to respond. But as a person, you probably want to add your own flavor. So I've always advised people, yes, you can ask the assistant to make sure that you're responding with the right information, but you could also just respond yourself. And that is what I have for you today, Scott.
This is really cool. I love it. This is giving us a real sense of what can be done and how we can, take an application, spice it up a little bit, sprinkle a little AI into it. Very demure, very mindful, very thoughtful. I dig it. Thank you so much, Maria, for spending time with us today. This has been a pretty cool keynote. I feel good about this.
Me too. It's been my first time doing a talk in a while, and I'm glad I got to do it with you.
Absolutely smashed it. Shoulders back. Be proud of ourselves. We've made it. We've got a great day filled with content for you. I feel really good about this keynote, and I know that the other talks that we're going to get to learn from today are going to be even better. We're going to bring experts from all across the .NET organization to teach you how to make AI impactful, responsible, thoughtful, and make your applications not just modern, but intelligent. Thank you for spending time with us today.
Thank you.
All right. Thanks so much, Scott and Maria. That was a great keynote. I love seeing all the cool things that we can do with .NET and artificial intelligence technologies. I've got some ideas of how I can update some of my websites to do a little bit more. This is interesting. But you know what? I want to make sure that I hear from our next speaker, Stephen Toub, who's going to be talking about getting started incorporating artificial intelligence into our .NET applications. I know he's got some things there that are going to help me out with some of the web apps that I've been building. And then after that, our friend Steve Sanderson is going to be joining us with Matthew Bolanos to talk about Better Together, .NET Aspire with Semantic Kernel. I know Semantic Kernel is going to help make some of my applications better, being able to summarize things and put together some descriptions for blog posts and things a little bit better. So I'm interested to hear what they have for us. Let me make sure that I go back and call out some of our slides, some of the information that's also going on as part of .NET Conf Focus on AI. We have a collection of Learn materials that are available on our slides over here. Check it out at aka.ms/.NETFocusAI/learn. That QR code will help you get there, and you can learn more about all the resources that we have available for you online so that you can take your education a little bit further, even share with some of your colleagues who aren't watching the event right now. We have a survey available as well. Check that out, aka.ms.NETFocusAI/evaluation. Let us know what you think of the event. Let us know what you think of the artificial intelligence tools and technologies that we're adding into .NET for you. And of course, there's a link in there that you can click to join us for our sponsored swag bag giveaway. There's gift cards, there's software licenses, and so much more. 15 folks are going to win all of those items. It's a pretty good size swag bag that with gift cards and software licenses and things. Check it out. Make sure you go to the evaluation, fill out the evaluation, and click the link. You have to click the link to go over to that swag bag entrance and join that raffle. All right. Well, that's about all the time I have on this break. Let me get you all set for our friend Stephen Toub, who's going to be talking about getting started incorporating artificial intelligence into your existing .NET applications. Stephen, take it away.
Hi, my name is Stephen Toub. I'm a developer on the .NET team at Microsoft, and I'm absolutely thrilled to be chatting with all of you about getting started incorporating AI into your .NET applications. If you are anything like me, when I'm faced with a new problem about something that I don't really understand, I often have sort of a blank page fear. I'm staring at a blank page. I don't really know how to get started. So what we're going to do for the next 20 to 30 minutes is start from a blank page or almost blank page. We have console write line hello AI, and we're going to see how to start incorporating AI into your .NET applications and go from 0 to 60 in no time at all. Now we're just going to scratch the surface. We're not going to talk about all the various ins and outs. We're not going to dive deep into any one particular area. There are a lot of other opportunities to explore more deeply. What we're going to do today is ensure that by the time you're done watching this, you feel like you can get started immediately incorporating AI into your .NET applications. So with that, let's get started. So here I have Visual Studio. I have a brand new C# console application, and I'm starting with a console application not because that's the only place you can incorporate AI. Quite the opposite. You can incorporate AI into any .NET application. I'm just using a console application to show that there's nothing special here, right? We're just starting from scratch. Now, there are a variety of ways that I can use AI in a .NET application. I need some model or some service that provides that capability to me. And one of the easiest ones to get started using is OpenAI or Azure OpenAI. So I'm going to start with using the OpenAI client. Now to do that, I added a NuGet reference to the OpenAI client. Just search on NuGet for OpenAI. And now I can say using OpenAI, pretty easy. And I can say OpenAI client. So I have my client here. Then OpenAI client. And I need to provide to this an API key, which is the one thing I have to go to the service for. I go to the service and say, hey, I'm going to start using your service. Give me a unique token that you can use to identify me. And so I need to put my API key here. Now, if you look at the constructor for OpenAI client, you can see it takes an API key credential. So we're going to pass in a system client model API key credential. Now, because I don't want to leak my key to any of you, I've put it into an environment variable. I'm just going to zoom out just a little bit. API key credential. We'll bring in that namespace as well. And then I'll say environment, get environment variable. And for me, I've put this environment variable under AI, OpenAI API key. And that provides me with the ability to talk to the service. Now, I specifically want to work in terms of chat. So I'm going to say chat service, and then I'll say client.get chat client. And I need to tell it what model I want to work with. Now, if I'm working with OpenAI, there are a variety of models I can choose from. Here, I'm going to use, say, GPT-4o Mini, which is a relatively recent model that OpenAI has introduced. We can see that this is an OpenAI chat client. And now I can start using it. So I'll say console.writeLine bar results equals chat service dot, and then I'm going to call this complete chat async method to pass in some text and get back a response. So I can say, what is the color of the sky? And then I'll just print that out. Console writeLine result.value. So in 4 lines of code plus a few imports, we're now bringing some AI into our application. It's an interesting completion there. This should pop up once the build completes. There we go. And we can see we're sending off the request, we're getting back a response. And the response was a detailed discussion of the color of the sky. Now we saw that from the time the window opened to the time that something was printed out, there was a bit of a delay there. So maybe I actually want to take advantage of the fact that the way these models work is they end up generating one token. You can think of that as a word or a part of a word, one token at a time. And rather than waiting for all those tokens to arrive and then printing them all out, I could stream them to, in this case, my console. But if this was a website, I could stream them back to the client, or if this was a graphical user interface, I could stream it to my graphical UI. So to do that, I'm going to make a small change here. I'll say await for each update in, and I'm just going to do the exact same thing I was doing, but instead of complete chat async, I'll do complete chat streaming async. This is going to give me a stream of updates coming from the service. And then each of those updates can actually include multiple pieces of content. So I'll just say for each item in update dot content update, console dot write item. And that's it. Now when I run this, we can see those tokens starting to stream in as they're coming from the service. No longer am I having to wait for all the content to be here before I see anything. I get it as it arrives, and it creates this nice sort of user interactive experience. And again, very little code to achieve what's actually a few years ago would have been a mind-boggling amount of functionality. Now, here I'm talking directly to OpenAI, and that's great. And there is a wealth of functionality that I can get from this OpenAI client. I can do text to audio, or audio to text, or chat, or generating embeddings, or generating images from text, such as with DALL-E and so on. But for a variety of reasons, you might want to be able to talk to something other than OpenAI, or something other than Azure OpenAI. Maybe you want to talk to Google's Gemini or Vertex. Maybe you want to talk to Mistral AI. Maybe you want to talk to Hugging Face or AWS Bedrock. Or maybe you want to talk to a local model from Windows, or a local model hosted with Olama, or a local model hosted with Onyx Runtime, or a variety of other things. And I'd really like to avoid updating the core logic for the rest of my application, and instead speak to an abstraction that allows me to talk to any of these services without having to constantly rewrite it every time I change my client. So I'm going to make a few small tweaks here. Let me go back to what I had before, just to keep it simple. We're going to go back to our simple, non-streaming request and response. And instead of using a hard-coded to OpenAI client, I'm going to change this chat service to instead be an iChat completion service. This is an interface that comes from a set of libraries called Semantic Kernel. You can see we brought in a namespace from Semantic Kernel here. Semantic Kernel is a variety of things. It's a whole stack of functionality, but at the bottom of the stack, there's a layer of simple abstractions for talking to language models and other AI services. So instead of using the OpenAI client directly, I'm going to create an OpenAI chat completion service. As we saw before, I can pass in a model. So I'll pass in, say, a GPT-4o Mini. And then I'm going to pass in the same API key as I did here. These also layer, so if I wanted to pass that OpenAI client to this OpenAI chat completion service, I could. And now I just need to make a little change here to change to a different method name, because I'm using the abstraction rather than that OpenAI client specifically. So we've cleaned up the code a little bit. We're dealing with this interface directly. Now I can replace this interface with anything I want. So I can run this for OpenAI. And when this runs, eventually my build will complete. So here we're going to get back the answer from OpenAI. But if I wanted to, let me just replace this. I'm not going to change any of this logic in the rest of my application. I'm just going to change my startup logic here to say, actually, you know what? I want a Google Gemini chat completion service. Now, Google provides entirely different models. So the name here I want to use is Gemini Pro. And then I'll also provide an environment variable here. I've actually called mine AI Gemini API key. And without changing any of the remaining logic in my app, I'm going to run it again. And now instead of talking to OpenAI, now I'm talking to Gemini, and you can see these models are a little bit different. OpenAI gave me a very wordy response by default, and Gemini is just saying the color of the sky is blue. If I wanted to, I could substitute something else. Maybe I want to talk to Mistral AI. So I can have a Mistral AI chat completion service. Mistral calls one of their models Mistral Small, so I'll use that, get an environment variable, and I'll do the exact same thing. I believe my environment variable is called Mistral AI. Run this again. Oh, nope, not Mistral AI, just Mistral. And now we get back, eventually, a response, a much more detailed response from Mistral AI's model. So you can see I'm getting different behaviors from the different models and services that I'm talking to, but the logic of my application is able to remain the same because I'm working in terms of these abstractions. And if you want to, you can start with these abstractions, and if you need to do something specific to the underlying client, you can break glass and basically cast back to the original thing to have the full functionality. Great, so we've got a very basic functionality here, but I was just using a hard-coded question. So let me just go back to OpenAI here. And I'm gonna write a little simple chat loop. Now, even though this is called chat, that's not the only purpose. This is sort of a general purpose way of interacting with the service. One of the purposes is to have a conversation with it from, for example, a chatbot, but you can also use this for more programmatic purposes. I could ask it to compute something, send me back the results in some structured form like JSON. I can then parse it, and I can use the result as a computation in the rest of my application. So incorporating AI into your app doesn't just mean build a chatbot. It can actually mean take advantage of the power of AI to power your application, which might not have any kind of chat feature in sight. That said, I am going to build a little chatbot here. So say while true, we're going to have an infinite loop. And instead of printing out the answer to a specific question, I'm just going to type in a question at the console, and I'll print out a little prompt to say Q. Okay. And now I can run this. And I get my little Q, and I can say, hello. It's nice to meet you. My name is Stephen. Nice to meet you, Stephen. Great. What's my name? I just told you, so you should know, but you don't. And the reason for that is these services are stateless. Every time I communicate one of these, I'm talking to a model that was trained up to a certain date. It has no information beyond that. It has no information that I previously told it. All it knows is what I just sent it. It's part of the prompt that I'm sending to it. So if I don't tell it again, when I say, what's my name? If I don't tell it all the previous communication we had, it has no idea who I am. So let's fix that. To fix that, we need to store our conversation history and resend that conversation back to the service each time we communicated with it. So I'll say chat history, call this history. And then instead of just passing this console read line directly to the model, I'm going to say question, or I'll say history.add user assistant message. I'll add that read line in there. Then instead of passing console read line here, I'll pass in the whole chat history. And when I get a response back from my AI assistant, I'll not only print out that response, but I'll also add it into the history. So now every time there's additional content, I'm putting it back into the history, and every time I communicate with the service, I'm sending the whole thing back. Now we can have the exact same interaction we just had. I can say, hello, my name is Stephen. I can say, what's my name? And now it knows who I am because we've re-provided all of that context back to it. Of course, if I were to say, how old am I? It has no idea, right? It doesn't know who Stephen it is. It doesn't know who I am. I have not provided it with the information it needs to answer that question. Now, I could proactively put some additional information into the prompt. I could say add user message. Stephen is, I don't know, 29 years old. We're going to make up a number here. And now I can have the exact same conversation I just had. Hello, my name is Stephen. And I can say, how old am I? And now because I just told it that I'm 29, which I'm not, but I told it I'm 29, it says, hey, you told me you were 29, and it can use that information. But I don't want to have to put all possible into the prompt. I want to be able to allow the model, allow the service to ask me to retrieve additional information. So to do that, we're going to make a few changes here. Now, first, you notice I've got my application logic, and I've got my sort of startup logic here. Now, in a real application, you would unless you were writing a simple tool, a simple console app, you're probably not going to commingle these. You're going to have some startup logic somewhere that most likely is injecting the implementations of various abstractions that you're using into a dependency injection container, maybe as part of your ASP.NET startup. And then in the rest of your application, you're going to be taking that dependency injection container, you're going to be querying it for the various interfaces. And that's one of the most common ways that these APIs end up getting used. So let's do that here, and then we'll come back to the age thing in just a moment. Now, if I were already in an ASP.NET application, or if I were already in a MAUI application, I would already have a DI container kind of established for me by the template I was working in or by the environment. Because I don't have that in just a console application, I'm just going to set up a little one myself. So I'll say service collection, and I'm going to get out of this the same service provider that you would get and you would have handed to you in other environments. And now I can add things into my service collection. One of the things I could add would be an OpenAI chat completion. This is going to take the same arguments that I had down here. So I'm just going to copy and paste that. Get rid of this. And now in my application, when I want to use a chat service, I can just say services.getRequiredService, iChat completion service, and use this. And so now in my startup logic, I can change to use whatever service I want to use, whether it's a local model or a remote service, whatever it might be. Maybe I want to change it for testing purposes to mock something up. Maybe I want to be able to have some fallover behavior where if the service I'm talking to has an outage, I can switch to something else. Maybe I want to do A/B testing. Maybe I want to insert an additional wrapper, some additional functionality around this, like a cache, so that rather than going off to the service every time, it looks up in a cache before it sends the question and gives me back the results. I can do all that by changing my configuration logic up front and then just having injected into my application the thing that I should be working with. So that's what I'm doing here. And we see it behaves exactly the same. I can say hello, and we get back responses. Now, what we talked about wanting to do was to add additional functionality into this application. I'm going to do that using something called a kernel, which is one of the core types that comes with Semantic kernel. And all it is a little object that stores services and, in particular, plugins, additional functionality that can be made available to the model. So I'm just going to say add kernel just to make sure that I can get one of these from my DI container. And out here, I want to get a kernel from DI. Great. And now I want to be able to add some functionality into this kernel that will allow the model to know, without my telling in advance, how old I am. So I'm going to come down here and write a little class. Let's call this demographics. And I'm going to write a function. Let's call this getPersonAge. That takes a name. And we'll say name switch. If it's Stephen, we'll say, what do we say, 29? Yeah. If it's Elsa, we can say 21. If it's Anna, we can say 19. And if it's anyone else, we'll say 40. Seems reasonable. I'm also going to mark this as a function that I want to be able to import into this kernel. And now all I have to do up here is say kernel import plugin from type. And now using reflection, this is basically just, excuse me, inspected an instance of this type to find all the kernel function objects. It's imported this function. And I can add additional metadata here. I can add descriptions of the properties, the parameters, and the function. I'm just going to leave it as is for now. Now I'm going to do two more things. First, I'm going to create a settings object that I can pass along with my prompts to configure various things. You can see Copilot is suggesting here various settings that I might want to configure. But what I actually want to configure is I want to tell it that it's allowed to automatically invoke the functionality that I'm providing. Then I'm going to do come down here is I'm going to say settings and kernel. So I'm passing in these options, including the ability to automatically invoke this stuff, and I'm passing in this kernel object that just contains these plugins. Now when I run this again, and I say, hello, my name is Stephen. Oh, or let me try that again. My name is Stephen. How old am I? Now, because it had this ability to call back to me, it knows that I'm 29 years old. Or I can say, how much older is Elsa than Anna? And again, it doesn't know how old Elsa is. It doesn't know how old Anna is, but it was able to ask me to invoke a function with Elsa, and it knows that that's 21. Then it knows that it's 21. It was able to invoke it with Anna, and then it knows that she's 19. And then it was able to do the logic to know that there's a 2-year difference between them. Now, because we're taking advantage of this integration with DI and it's fully integrated with the rest of the .NET ecosystem, we can bring in other functionality here to get a much better understanding of what's actually happening under the covers. So let me add in some logging, for example. I'll say add logging, and I'm going to do console logging, and we're going to have it be the most verbose level, so say log level trace to add this logging. Now we'll run this again. Now we can see, we already see some information being output just by adding that into the DI container. Now I can see that we imported this get person age into the kernel. We have one function available. And if I say hello, we can see the message, the chat message that's being sent up. And as part of this request response, we can see that I used 42 request tokens, prompt tokens, as part of my request. And the answer that came back had 10 tokens, meaning that the total number of tokens used was 52. And that's important for 2 reasons. One, with pretty much all of these systems, you are limited by how many tokens you can use. Every model has a different context window or token count that's allowed for both the request and the response. So I might want to keep track of it for that purpose. Also, most of these services bill you based in terms of the number of tokens used. So it's important to understand from a cost perspective as well. Now, if I ask it a question like, how much older is Elsa than Anna? We see we sent another request, and this time we get a lot more interesting, many more interesting things happen. We got our initial request response, but as part of that response, the response it sent back to me had 2 tool requests. One of them was to invoke get person age with the name Elsa, excuse me, and one of them was to invoke get person age with the name Anna. And then because we told Semantic kernel it was okay to invoke these things, it proceeded to invoke get person age with Elsa. It succeeded and returned the result 21, taking this amount of time. Then it invoked again get person age, passing in Anna. It succeeded, returned the result 19. It took this amount of time. That we turned the crank again. We made another request back to the service, sending all of those results back, along with all the previous chat history, which contained our original question. And then we get back the result from the service saying Elsa is 2 years older than Anna, because now it has all that context. Now, in this particular case, I wrote my own plugin, which can be arbitrary .NET code, but you can imagine reusable libraries of this kind of functionality. In fact, Semantic kernel, as one of its libraries, includes a set of plugins, one of which is really useful for these kinds of examples because it allows me to do full web searches. So I could come in here and I could say, I want to import a plugin from a new object. And this new object is going to be a Microsoft Semantic kernel plugins web, what do we call it? Web search engine plugin. And then this takes a particular search engine to talk to. So I'm going to use the Bing connector. And I also need to give this an API key, which is also for me stored in an environment variable. So we pass in API key. And now let's try this again. So I've added in that plugin. We can see it imported an additional search API. And now I'm going to say who won Best Actress at the 2024 Academy Awards. Now, the model that I'm using has a training date before the 2024 Academy Awards appeared, so it wouldn't be able to answer this question otherwise, but because it can now search the web, oh, I can't search the web. Apparently, it's getting permission denied. It's possible my API key is out of date. We'll try one more time and we'll see if it works. Otherwise, we'll move on. Who won Best Actress at the 2024 Academy Awards? No joy. Doesn't matter. We can still see what we wanted to see, which is that as part of my request, the tool came back saying, I would like you to issue a search for 2024 Academy Awards Best Actress winner. So the model was generating this request, handing it off to the plugin, and for some reason, my API key isn't working out exactly the way I want, and Bing is saying, go away. That's fine. You get the basic idea. All right. All right, we have a couple minutes left. So you can see that you can build up these really powerful AI experiences with very little code. We've only scratched the surface. I'll show one more aspect of this. Let's say that as part of these plugins, I wanted a little bit more control over throughout my application, maybe what got invoked. I put a bunch of stuff in, but then if the model asks for something, or maybe it asks to invoke something with some arguments I don't want it to do, I want more control over exactly how that happens. So I'm going to write a little class here. Let's call this permission filter. And I'm going to implement a function invocation filter. Function invocation filter will be invoked anytime a function is to be invoked. So let me just print out to the console here what function is being invoked and ask for permission. Okay to invoke context.function name and context.function.name. And I want to do string.join with the arguments just to put a nice little list. And then I'll say if console.readline, so I'm going to just ask the user to type in yes or no, then yeah, we'll do that. Otherwise, we'll throw an exception. Let's just say error user denied request. Okay. So I've written this filter, and now anytime the system asks for one of these things to be invoked, I want this to be invoked. With dependency injection, it's no problem. I just say add singleton. I want to add a function filter in. We'll use a permission filter. And now I'll run this again. Actually, let me just turn off logging to make it a little bit easier to see what's going on, so we're not surrounded by noise. And I'll say who won the 2024 Academy Award for Best Actress. And now, rather than just invoking it, you can see it's actually asking me, so this is the function that's going to be invoked, the function that's going to be invoked with these arguments. Is this okay? And I could say, yeah, sure, go ahead. Or I could say no, and it basically gets denied. And it's trying one more time, and the model gives up. It says, you know what, I wasn't able to do what I wanted to do. I'm done. And so you can very easily plug in this functionality in one place and have it kind of apply pervasively throughout the rest of your application. So with very few lines of code, we've seen how to get started using something like the OpenAI or Azure OpenAI client directly. We've seen how to switch over to using interfaces and abstractions from Semantic Kernel to be able to talk to OpenAI or any number of other services. We've seen how to employ function calling with models and use various plugins. We've seen how to use various filters. We've seen how to do streaming. And that was starting from a blank page in only 20 to 30 minutes. Imagine what you could do with a day or more. So my hope is that all of you watching, turn off YouTube, go open Visual Studio, and add these NuGet packages and just start playing and see what the amazing things are that you can build. And with that, thank you.
Okay, welcome everybody to this session. My name is Stephen Sanderson. I'm from the .NET team, and today I'm joined by Matthew Bolanos from the Semantic Kernel team, and we're going to be talking to you about some ways that .NET Aspire and Semantic Kernel can work together to give you a really good experience as a developer, adding AI features to your application. So let's start with, what does that even mean? What kind of AI features would you want to add to an application? Is AI even useful for a typical business app? So I think the answer is yes, but let's go through an example of it. And I'm going to try to give you just about the most conventional and relatable example I can think of, which is e-commerce. So imagine there's an e-commerce site, which as well as selling products to people, also has a customer support facility where customers can come along and submit inquiries about products that they have bought or are thinking about buying. And these inquiries get sent through to the staff working there. And the staff have got some kind of web UI for working with that. And it's probably got a big grid in there in the middle. That's perhaps how their workflow works. So very typical business app. How can we even use AI in a beneficial way here? Is it useful? Well, yes. For example, we have got a search box. So we might start by thinking, can we upgrade that to be semantic search so that people can find stuff without having to know exactly how it's phrased or without worrying about spelling mistakes? We've also got these little titles here that can help staff remember what each of the different tickets is about and navigate around quickly. And so it's nice to have an AI system automatically generate those for us. We've got these different ticket types, and we can use classification to set the right type automatically based on the text, which allows you to trigger different workflows if you want to. And then we've got these satisfaction rankings, and it's very easy for a language model to give a sensible estimate of customer satisfaction. So we can do that, and that might help staff focus their attention where it's most needed. But that's not all. We could also go a bit further and say when someone opens one of these tickets and they start working on it, they're going to have various fields they can fill out. And just like before, we could use AI to automatically classify or enable semantic search. We've then got perhaps a big conversation between the staff and the customer, and that could take a lot of time to keep rereading each time you open. So to save humans the trouble of reading all that stuff, what about have AI produce some nice little summaries of that as well? And then when it's time to actually answer these questions, it's perhaps relevant to have some sort of chat assistant that does Q&A, and that can find information from your business data, in this case, product manuals. And of course, we need it to be accurate and not hallucinate, so we could force it to provide citations for any claims that it makes. And then finally, when it comes to typing a response to the customer, we could have a type ahead system that suggests phrases that fit in with what the user's typing and that matches all the information that we've already got. So overall, I think it's clear that there are lots of opportunities for making this sort of application more productive and more beneficial for your users with some AI features. And it doesn't even have to be very difficult. So let's have a look now at some ways that you can do that at the code level. Now, obviously, we can't go through every line of it because we haven't got time for that. But I'm going to show you some of the highlights of how Aspire and Semantic Kernel can work together to enable that sort of thing. Okay, so over here, I've got Visual Studio, and it's got my solution in it. And this, as you can guess, is an Aspire application. So here's the Aspire dashboard, and you can see I've got lots of different services like vector databases and other stuff in there. The ones that we're going to be focused on just now are the backend, where most of the app logic is, and a couple of different web UIs, one for the customer, one for the staff. So let's start with this staff web UI. And you can see it looks kind of like we had in those PowerPoint slides just then with all the stuff you expect. So, you know, like semantic search to find all the things related to food and so on. Let's go into this ticket here. You can see it's got quite a long conversation, very long. I definitely can't be bothered to read all that, but I don't have to because the AI has produced a nice little summary of what that's all about. So let's see in the code how that actually looks. How do we generate a summary like that? Is it difficult or not? So I'm going to go into the bit of the backend API where messages get posted. Okay, so this C# method here runs, and you can see this uses normal entity framework code to save the new message to the database. But also, each time a message is posted, we generate an updated summary. How does that work? Well, the main thing is that we're using a service called iChat Completion Service. Now, that's an interface provided by Semantic Kernel. And if you don't know it, Semantic Kernel is a set of .NET packages and libraries that give you abstractions over different AI services and implementations for them. So we can have various different language model backends for this chat completion service, and then we can call any of them without having to change the rest of our code. So in this case, we get the chat completion service, and I'll show you where that comes from in a minute. And then we build a prompt that we're going to pass into the language model. And we tell it, you know, what product this is about, the brand, we emit all of the messages in the chat history to it, and then we tell it what to do. We're going to say, okay, write 3 summaries for me. One, a 30-word summary that will use on the ticket details page, a short summary up to 8 words that we use on the ticket list, and then we'll also tell it to produce a customer score satisfaction. And it's quite easily able to do all that. We tell it to reply as a JSON object, which we can then parse and save all that stuff into our database. All right, so it's not too difficult to do this kind of thing. And just to show that that works when we do it live, let's add a new support ticket to our system. So I'll go in here, I'll say, okay, I need some food for my cats. So let's say protein energy bars, maybe those are good for cats, I don't know. Now, because I'm a customer, I'm not going to write a short, succinct, clear message. I'm going to write an absolutely massive message that's really hard to understand. It's got loads of information in it about my cats and their personality, and it's got a poem about cats and all kinds of useless stuff like that. And somewhere hidden amongst all that is my actual question. So it's going to take ages for the support assistant to even work out what I'm asking them. But actually, it doesn't take that long, because you see we get this nice little summary that's automatically generated, energy bars for cats, and specifically picks out the most pertinent question, are energy bars safe for feline consumption? Okay, so you can see how that helps. Now, in terms of where this iChat completion service comes from, what is it? Is it OpenAI? Is it something else? Well, one of the nice things about Aspire is that it can orchestrate this sort of thing for you. And in this case, I'm configuring it in my app host. So all the services in my application share the same language model service, and I can easily switch it around. In this case, I've actually set it up with a connection string that makes it use OpenAI. But if I wanted to, I could simply swap these 2 lines of code, and now it would use Ollama, which is a way of running language models locally on your development workstation. So everything happens fully offline. Now, I'm not actually doing that because it runs slower on my laptop, but you can if you want to, especially if you've got a more powerful GPU. And you don't have to make any other code changes. Okay, so that's Aspire and Semantic Kernel working together. And in fact, the integration between them goes a little more deep than that. In terms of, for example, telemetry. If I go into this tracers list here, and we have a look at the activity that's been going on, one of the things that we'll notice is that it's able to recognize when we've made calls to a chat completion service, because Semantic Kernel will log the telemetry. And it's got all sorts of useful information in there, like the number of tokens that were produced, and the prompt and the response, things like that. And if you're doing this in production, you can aggregate all these statistics and keep track of your costs and the times and that sort of thing. Okay, so that's an example of how we can do a bit of summarization with these technologies. Now, let's move on to a slightly more advanced thing now, which is going to be this Q&A chatbot thing. So let's see how that actually works, and then we'll look at a bit of code. So let's go into another support ticket now. So the first problem I notice here is that this customer is trying to talk to me in German, and I don't even speak German. So that could be tricky, but fortunately, the summary gives me a good indication of what they're asking for. They want to know the PIN for Bluetooth pairing. Now, I don't know what the PIN is, which is why it's helpful to have this sort of AI assistant that's capable of searching through business data and finding the relevant things. So let's try what does the manual say about this. And you can see it does a search for Bluetooth pairing PIN, and it works out that the default PIN is 0000. Okay. Now, do we know if that's really true? Well, we make it give a citation. And if I click this, we can see it can take us into the actual product manual and highlight the exact basis for its claim. So we know it's actually true. All right. So then I could say something like, write a reply to the customer saying that. Okay. And it'll write a reply. Great. But of course, in this case, I need it in German. And so it writes a nice little reply to the customer. And I can click this button, use as reply. Get rid of that. That's a bug I'll fix later. Hit send, and it's sent the message back to the customer in German. Cool. How did that work? Well, let's go and have a look at a bit of the code for that. Here's my Assistant API. And you can see that it's not super complicated. The main thing that it's doing is it's using another one of these iChat completion services. And just like before, it builds up a prompt saying, hey, I want you to answer customer support questions. Here's all the context with the product and so on. Here's the most recent message from the customer. I want you to give me an answer. Okay, so it will provide an answer. And then in terms of being able to search product manuals, this is something that Semantic Kernel makes fairly straightforward. It's got this API where you can attach what it calls plugins, which look a bit like this, a class that's got methods that are decorated with these special attributes, kernel function. Okay, so in this case, I'm saying there's a callback that the language model can use if it needs more information, called search manual, and we need it to supply a search phrase and a product ID, and then we can put whatever logic we want in there that goes off and gets, search results from that. And in this particular case, I'm using a vector database and semantic search, which is also provided by Semantic Kernel. But you could do anything else you want. You could use a traditional database full text search. It doesn't really matter what. You supply some results, and then the language model can use that to give an answer. Okay, so that's pretty straightforward. One thing you might notice is the way that this button, users reply, appears sometimes, but not always. Well, that takes us on to this next matter, which is classification. It's very often that you want to determine what sort of class something fits into. In this case, I want to classify messages as, are they suitable for sending to the customer or not? So I know whether to show this button. And there are a couple of ways you can do it. The first way I'll show you is just simply by using a language model and iChat completion service again. So what I'm doing here is, after we've sent the response, we send a further message to the language model saying, consider that answer you just gave and decide whether it's suitable to send to the customer or not. And give me back a JSON object with a Boolean. And then based on that, I'll decide whether or not to show that button. So that's all that's going on there. But there are other cases where you might not want to use a language model for classification, perhaps because you want to make it faster and cheaper still. So language models are brilliant. They're very powerful, but they also take a bit of time. It might take, hundreds of milliseconds or even seconds to answer your questions. And if you've got a high performance, high speed workflow system, you might want to classify things faster and cheaper than that. So I'm going to show you a way of doing that. And slightly surprisingly, I'm not even going to use .NET. I'm actually going to use Python. You might wonder why I'm doing that in a .NET event. And the reason is not because I think you must use Python. In fact, you can certainly do this with .NET. The point is to show you that Aspire is very good for orchestration, not just with .NET, not just with Docker containers, but with other technologies as well. So if you want to bring some Python or Java or JavaScript or whatever else into your Aspire application, you can do that. And I'm going to do a bit of classification with Python here. It's very straightforward. So in Visual Studio, I've added this Python project, and you can see I'm constructing a fast API server. Now, if you don't know Python, don't worry about it. This is a bit like minimal API for Python. And I've got a couple of endpoints, including this classifier. And the classifier is going to take in some text and a set of candidate labels, and it will determine which is the most relevant label for the text. Okay, and it's doing so using this local model called MiniLM2, which it gets from Hugging Face, which is a third-party system. And so that's able to do this classification very fast locally, just on my development machine or on your server. And to show you that really working clearly, I'm going to do it manually on the command line. So if I get this text, this is a Python API, and the candidate labels are animals, programming, or music, you'll see it instantly classifies it as programming. Whereas if I change the string to this is a Python, it classifies it as animals. All right. So what I want to classify in this case is the incoming tickets: question, comment, complaint, or returns, which is the most relevant label. And you can see that when I did this thing about cats, it was classified as a question because it is a question. But if I go back as a customer and I say, I need to return stuff, or something else like that, then when we look at the list, you'll see that this has now automatically been classified as returns. So we could trigger different workflows based on that. And Aspire is fully capable of starting up things like Python or Java or whatever else you want to use within your system. All right, so that's a couple of ways to do classification. The last thing that I'm going to have time to show you is evaluation. And in some ways, this is kind of the most important one, because this is what makes the difference between just kind of like hoping that things work and actually measuring that they work and being an actual professional. So I know that you're professionals. You want to be able to know that your stuff works and, in fact, how well it works. So let's look at how we can quantify the quality of this AI assistant. I want to reduce the whole thing to a single number that says how good it is right now. How can we do that? Well, the main way that people do this sort of development time evaluation is by having a set of evaluation data, a set of inputs and desired outputs, and then we can test it against the inputs and see how well it matches the desired outputs. All right, so how are we going to do that? How would we get sample data? Well, in fact, all the data that you've seen it so far, like all the product data, the product manuals, the customer support tickets, all of that stuff has been generated through AI for the purposes of test data using this data generator project. And if you get the code for this later, you can see how that works. And one of the things that it produces is a set of evaluation questions, which in this case is a list of hundreds and hundreds, maybe thousands of questions and answers. For example, for product 35, what is included? The answer is this stuff. Okay. Now we can take this as being the ground truth because this is the data that we generate first. And based on this, we build all the product data and manuals and such out of it. So for that reason, we can consider this to be the truth. So what we want to do now is ask our backend system all of these questions and test how well it answers them. So what I'm going to do now is I'm just going to start up my application in the background here. And that's running now. And I'm going to use a little console tool to run an evaluation loop. Now, you could imagine that we had a really nice UI for this, and maybe at some point in the future, someone will create one. But right now we don't. So just use your imagination, because all I've got right now is a console app. And this console app, let me just start it running. Okay, that is using some Aspire libraries to be able to discover and call into the backend service from this console application. And it's looping through all those eval questions, putting them into groups, and then it's sending them in parallel to the backend to say, you know, here's a question, here's another question, here's another question, and collecting all the answers. And then it scores the quality of the answers. And it does that by making another call to a language model to say, how accurate is this and how relevant is this based on what the truth is, and we get back a number. And we can calculate the average of that over time. So we're going through right now, and I know the text is a bit small, but at the moment it's averaging at about 0.75. Over time, I happen to know from experience that in this setup, it's going to average at about 0.8 or something like that. But the exact number doesn't really matter. What matters is that you want to find ways of making the number go up by making changes. So you could try changing the prompt or the assistant logic or the vector database or the chunking or any other thing that's going on in this system, and then run the evaluator to see whether the quality goes up or down. To give you a realistic example of that, at an early stage when we were building this, we noticed that it was hallucinating quite a lot. And we would ask it questions, and instead of looking at the product manual, it just made up an answer based on nothing, just a pure hallucination. And at that time, the score was about 0.61. So we realized that we needed to look at the manuals more. So we added to the prompt this one extra sentence. If this is a question about the product, we really want you to look at the product manual. And just by adding that one sentence, the score went up to 0.77. So clearly, it's a good improvement. But it also made the time go up from 2 seconds to 2.6 seconds, which, you know, also makes sense because it spends more time looking at manuals and doing extra calls now. But the point of this is that you, the developer, can now make trade-offs in a principled manner. You can make changes, see whether the scores go up or down, whether the times go up or down, or the costs, and decide whether these changes are good or bad. Okay, so that's all I'm going to have time to show you. I'm going to hand over to Matthew in a second, but just to summarize from me, there are many different things you can do to add AI features to your app. Chat is one of them, but I don't think I would recommend starting with that. I think that if you're starting, you should look at things like semantic search, summarization, translation, classification. All these kinds of things are much, much easier to build, and they can allow you to add some real value to your application over a fairly short period. So I'd really recommend starting with some of those things, although chat, of course, may be useful depending on your scenario. I do think it's worth a bit of investment in having an evaluation system from the start so that you can check whether what you do is improving or getting worse over time. I think as a .NET developer, you've got some great opportunities with Aspire and Semantic Kernel and the way that they work really well together, but also be open to other things. You know, it's an emerging field right now, and all the recommendations we give are going to change over time. People come up with new patterns for evaluation or testing or whatever else. So be flexible and consider using whatever is best in your scenario. Now, if you want the code that I've been using in this demo, that should hopefully be available by the time you see this at the URL that I show right there. So you can check that out and hopefully see how much of this stuff works on the inside. So that's it from me. I'm going to hand you over to Matthew now, who's going to take you to the next level with your AI understanding. You're muted.
Thank you, Steve. I love that demo because it shows how you can actually drive real productivity with your existing applications with AI. That's what it's all about, right? Not just building shiny applications. How do you actually make your own customers, your own employees, your own company more productive? Now, what I'm going to be talking about is kind of what's coming next. Steve kind of mentioned all of this stuff is still emerging. There's all these new things coming out. What should you expect in the AI space? And how are we going to help you within the Semantic Kernel team in your .NET language? So what I'm here to kind of share with all of you today is what we are working on within Semantic Kernel to wrap that chat completion service that Steve was talking about in an additional abstraction to make it easier to actually talk back and forth with the chat completion service. If you've been plugged into what's happening in the AI space, you've probably heard this word agent pop up over and over and over again. And what we've done in Semantic Kernel, just a few days ago, maybe a week ago, we released our new agent framework for Semantic Kernel. So I could talk on and on about what an agent is, how it works, but I always find it's easiest, best to dive into actual code to see what this new abstraction does. So what I have right now is a Jupyter notebook, which has some very simple semantic kernel code. Basically, I'm running a terminal application, a console application. And let's just go ahead and get started by loading up all of our different packages and importing these statements. And then we'll dive into what is an agent in semantic kernel and why it's valuable for you. So once these packages are installed, we'll go ahead and import all of our statements. And as Steve showed, you can create these, we call them plugins inside of semantic kernel that give the AI the ability to either retrieve information, to interact with the real world, or in this case, very simply, getting the current time. Now, in Steve's example, he was using the chat completion service directly and making calls to it. What we've found, though, is most kind of those back and forth chats follow a similar pattern, right? You have a chat history, you build it up, you give it to the LLM, it gives you a response back. And so what we believed and what the industry has seen is if you can wrap this in another abstraction, you make your code a little bit easier, and you get a little bit more predictable way of working with these, what we call agents. So here what I'm doing, we'll go ahead and click run, is I'm building a kernel. I'm adding in one of those chat completion services that you saw earlier. We're adding in that plugin so that the AI knows how to tell the current time. But what's new within semantic kernel is we can now create what we call a chat completion agent. We can now create a chat completion agent where we can give it a name. We can give it instructions. So you don't have to bubble, or you don't have to combine all of that inside of a single prompt. You can just tell it, and then you can start a chat history, and that instruction set will always be prepended to whatever that agent is working on. We start our chats, it's asking for our input. We can ask simply, what is the current time? And the AI assistant is able to give us an answer. Okay. Not a whole lot new over just using the chat completion interface by itself. But what we're about to see is this also gives you the ability to use services that act as agents, right? So instead of having to build everything yourself with chat completion, you can talk to something like the Azure OpenAI Assistance API, which, if you're not familiar, is a service that basically manages the thread on behalf of you so that you, as a developer, don't have to figure out where are you going to store that chat history? How am I going to save that to something like Cosmos DB? That's all managed for you using the Assistance API. So we'll go ahead and play this one as well. We're starting the same way. We're creating our kernel. This time, we're creating an OpenAI assistant. And what's new is instead of me creating a chat history object, I can ask the service to go ahead and create a chat history for me, or what they call a thread. so that when I have this back and forth conversation, I don't have to worry about saving that information. And so I can ask the same question of what is the current time, and it'll work the same way, but I'm actually not going to do that quite yet. The other thing that's really valuable about the Assistance API is it also comes with built-in tools or built-in plugins. So I can comment out this line that gives the ability to check the time, and I'll uncomment this one, enable code interpreter. What this is providing the AI is the ability to basically write Python code, basically do a bunch of operations in the side to answer any user's question. And naturally, Python has some tools, some coding that it can use to tell the current time. So when I ask, what is the current time? What it's going to do behind the scenes is instead of using my plugin, it'll actually use code interpreter to write some simple Python code. We can actually see it right now. It'll execute it and tell me what the time is. Okay, so we'll go ahead and say bye. Now, the last thing I want to show that's really demonstrates the value of this additional abstraction, the value of having agents, is with a common contract for how these agents work together, it's now possible to put them in something like a group chat or a process and have them use the same interface to talk back and forth. And we're going to see just that. This was popularized and started with a research project called Autogen. And we've basically taken those best concepts, the group chat, the agents, into Semantic Kernel and made them enterprise ready. So what we're seeing here is we're going ahead and create 2 agents instead of just one, an art director and a writer. You can see we have all these different instructions that we're providing it, what they can do, what they can't do. Don't waste time. And we ultimately want to be able to create a group chat where we include these 2 agents, the writer agent and the reviewer. But there needs to be some sort of way of controlling the chat. Who gets to speak next? When is the chat over? In this particular scenario, we're going to be having the agent reviewer basically determine when is this chat over? When is the writer done writing something that is of good enough quality, right? And once it has achieved that, this chat will be over and the user will have that final answer. So I'm going to go ahead and invoke this. And what I am asking these 2 AIs to do, these 2 agents, is to come up with some marketing copy for this concept, a way for multiple AI agents to collaborate on a single task, exactly what they're doing right now. We can see that first message, and it starts off with the copywriter. Hey, let's try this, AI conductor, orchestrating brains. The art director's like, no, I don't like this. It's interesting, but it's a bit abstract. Can we refine it, right? And so it tries again, and then it finally is able to approve this final message so that, in this case, a user can use it for their marketing. You can imagine in the example that Steve showed that maybe the summaries aren't that great, or maybe the responses back to the customer aren't high enough quality. What we found through research is having multiple agents kind of battle it out, right? Challenge each other, bring with each other different perspectives or system instructions can actually make that final result even better, right? But this isn't the end all be all. You can imagine these things going back and forth, getting in loops. Just talking is frankly not enough for these AIs to always complete work, right? And so the last thing I kind of want to leave all of you with is what is coming even further with Semantic Kernel, what else you should expect from the rest of the industry. And that's really taking what we've learned through multiple agents working together, these multi-agent patterns, and making them a little bit more predictable, more deterministic, so that you always get a result that you expect from your multiple agents. And you kind of saw this in Steve's demo when they had to do that classification logic, when he had to show that reply button. He basically wrote some code that says, hey, reply, and then check if a reply button needs to be involved. It's very simple. It's like do step 1 and then do step 2. You can imagine, though, as you build more complex business processes, these things become unwieldy. And so different frameworks, whether it's AutoGen or Crew AI, have started building easier ways of abstracting agents and allowing them to create business processes and follow them, and also include humans in the loop. So get excited for what's coming next for Semantic Kernel, .NET, Aspire. It's an exciting time to be a developer. A ton of new things are on the horizon. And with that, I'll kind of conclude my section on agents. And I'll go ahead and pass it back to Steve, and we can wrap things up.
Yeah, I think that's all from the two of us. So we hope that is of use to you and that you will give some of this a try. And quite importantly, let us know how you get on. We want to learn from you as well. So thank you very much. Enjoy the rest of this event.
Oh, man. Okay. Semantic kernel. There's a lot there that we can do with that, isn't there? Thank you so much, Steve and Matthew. Yeah, I'm going to need to spend some time with this one. That's some cool stuff. Listen, we've got a full day of events here for you as part of .NET Conf Focus on AI. These are all recorded. They're on YouTube, and we're going to have a playlist available with all the recordings broken out for you at the end of the day today. All right. So if you miss it, if you aren't able to stick around through the entire day, have no fear. We've got all the content available for you at the end of the day on a playlist. So no problems there. You can tune back in later. You can dial us up on the TV, bring it up on your phone, what have you. There's always great .NET Conf content available on YouTube for you. Let me make sure I get you linked to some of the other content that we have for you. We have some slides like this one talking about the event collection. All of the Learn modules, all of the slides, links to the videos, they're all available in this collection at aka.ms/.NETFocusAI/collection, where you can take a picture of that QR code, jump right into there, and learn more about all the things that we've built for you, that we're presenting for you as part of this event. All right? Make sure you check that out. Now, we also have coming up an AI challenge and a series of live streams for the next month. .NET Conf Focus on AI doesn't stop today. Go over to aka.ms/.NETFocusAI/credential challenge live, or once again, you can click that QR code. For the next month, ending on September 20th, there is great content for you coming up every few days. You'll be able to go out there and this AI challenge. We've got some tasks for you to take a look at, a little bit of homework that you can explore and get some feedback on from our stream hosts all throughout the month. Make sure you check out the credential challenge coming up for the next month. All right. Now, I want to make sure that you also know we have a bunch of great sponsors that have been helping out. Check out some of these folks. They've done a great job getting the word out so that other folks know about the .NET Conf Focus on AI event, and they've put together a swag bag for you. Make sure you fill out that evaluation, aka.ms/.NETFocusAI/evaluation. 15 winners are going to win about $5,000 of prizes in that swag bag, including software licenses, gift cards. You got to fill out the event survey and then click the link in the event survey so that you go through and can enter the swag bag raffle. It's a second click in the survey that you must follow. You can't just complete the evaluation, all right? We've got 2 more sessions for you. First up is Daniel Roth talking about building interactive AI-powered web applications using Blazor and .NET. That's right up my alley, all right. And after that, we've got our friend Bruno who's going to join us and talk about navigating the world of AI with .NET, building not just with large language models in the cloud, but also locally. Now we're talking. I like those smaller models working locally. But first, I want to hear about Blazor and AI. Daniel, take it away.
Hi, everyone. I'm Daniel Roth, the product manager for Blazor on the .NET team. And in this session, we're going to build interactive AI-powered web apps with Blazor and .NET. We're going to start by building a simple AI-powered Blazor web app together. We'll then look at how you can add additional AI capabilities and features using pre-built components like the .NET Smart Components. We'll then take a tour of some of the great AI features coming from the .NET ecosystem. Blazor is great for building AI-powered apps. Blazor's interactive server-side rendering makes it easy to connect rich interactive user experiences with cloud-hosted AI models. You don't need to build separate AI endpoints to expose server AI capabilities to the client. You can just do it all from the server. You can quickly add AI capabilities to your Blazor web apps using existing AI libraries like Semantic Kernel. Semantic Kernel really handles the complexity of connecting to various AI models and allows easy integration of app-specific capabilities and data. Blazor's reusable component model also simplifies building AI-powered apps. Instead of having to create each UI component from scratch, you can leverage a rich ecosystem of available components. Okay, let's just get started. Let's build our first AI-powered Blazor web app. I'm going to hop into here in Visual Studio, and let's create a new project. Let's create a Blazor web app, and we'll just use all the default settings. Just make sure you've got interactive server-side rendering enabled. We'll go ahead and create that. All right, let's go ahead and get our app running so we can see what we've got so far for our app. Blank canvas that we want to add some UI to. There it is. It popped over on my other screen. So we've got our home page here. And what I want to do is I want to add a simple, chat AI assistant user interface onto this page. Okay, so let's go back to Visual Studio and let's bring up that home component. And we're going to need like a text area and a button, and then display the response from the AI service. So let's get GitHub Copilot up. Let's get it to help us build the UI. Let's add a text area that is bound to a string message field, and a send button that has an async send event handler. Also add a bootstrap card that displays a p tag with a response, a string response field. Okay, let's go ahead and see if that works. Let's get GitHub Copilot to do all the hard work for us. Add some Razor content here. Okay, let's see. Yeah, we got a form, a field. So we got a text area there with the button. That looks good. And there's our response. And then we got a little bit of extra logic here for our send event handler. We don't need all this code. We'll just get rid of all that and have an empty send handler. Let's go ahead and accept that. Hot reload that into our Blazor web app. And yeah, that looks pretty good. We even got some nice headings in here. Let's add a little bit of margin. Here, let's get this side by side with Visual Studio. Let's add a little bit of margin on that that button. So we'll find the class for that, and we'll do margin top 2, I guess. And there, okay, perfect. All right, great. And so now, hopefully, we can start connecting this to our AI service. Now, I'm going to use Azure OpenAI for this. I've already gone into the Azure portal, and I created an Azure OpenAI resource and deployed an AI model into that resource. I'm using GPT-4o, the latest, greatest. So you're going to need to do that yourself in order to do these next few steps. In order to connect to that AI service, I'm going to use Semantic Kernel. Semantic Kernel is a really great .NET library that's going to help me connect to really any AI model I want to. It'll handle sending the prompts, getting the responses, and orchestrating any AI-related features. So let's go ahead and add Semantic Kernel here to this app. And we want this Microsoft Semantic Kernel package. And then we're also going to want to be able to authenticate to Azure if you're using Azure OpenAI. So I'm going to add this Azure Identity library, and that's going to handle all of my authentication concerns for me. So let's go ahead and install Azure.identity as well. Cool. Okay, so now let's go into Program CS. Let's give us a little more space. And here's where we're going to wire up Semantic Kernel into our Blazor web app. So we're going to do builder.services.add kernel right here. Now, the kernel is the API that you use in Semantic Kernel to send the prompts, get the responses, configure what AI service you want to connect to, and handle all the orchestration. So that's good. We also need to say, well, which AI model do we actually want to connect to? And I'm going to need to add some code here for Azure OpenAI. To save on some typing, I'm just going to copy this snippet in. It's really just 2 lines of code. It's not bad. I'm going to pull out the parameters that I need to connect to the Azure OpenAI service from config. I've got this smart components config section set up. That's just what I happen to name it. You can name it whatever you'd like. But then we're going to call add Azure OpenAI chat completion. And we're going to pass in the deployment name for your AI model and the endpoint. And then you need to give it a credential to connect to Azure OpenAI. Now, this default Azure credential call comes from that Azure Identity Library. It's a really convenient API that can authenticate in a variety of ways, whether you're in development or in production. So in development, it will actually pick up my user account in Visual Studio, which I've also already in the portal given permissions to be a contributor on my Azure OpenAI resource. So once you've done that, this will authenticate as me in Visual Studio, and it will just work. And then when you deploy to the cloud, you can set up like an app identity and make sure that has permissions for your AI service too. Okay, so that's how you set up Semantic Kernel. And now we just need to use it. Let's go to our home component. And let's first of all, let's make sure that we make our home component interactive. We want to use interactive features so we can handle our button clicks. And then we'll inject the kernel. This is that kernel API that we set up in DI. And we'll just call this property kernel. Okay, and then down here in our send method, all we got to do is say response equals await kernel.invoke prompt async. And we want it to give us back just a string. We want the response as a string. So we'll use that generic parameter for that. And then we'll pass in the message that we got from the user. Okay, that ought to do it. Let's go ahead and restart the app. We did a bunch of work in DI, so we need to rebuild the DI container. And then let's look and see if this works. So let's see. Hi. Oh, wait a minute. Hold on. Refresh. Oh, that must be, I think that's so wrong. I think it must be an older version of the app that I was running. All right, let's get the app up. There it is. And let's say, hi, how are you? And then we'll go ahead and send that. Okay, hit send. Let's make sure that the message is being sent. Yep, I can see in the logging that it's invoking the model. That's good. Oh, great. Hello, I'm here, ready to assist you. How can I help you today? Awesome. So we just connected our Blazor web app to the AI service. Perfect. Now you notice it took a little while, and in fact, all the text came in like one big block. Like it didn't stream in. I want it to stream in as it's being generated. How can we do that? Well, that's pretty easy. Instead of just calling invoke prompt async, we'll just do something slightly different. Let's clean out the response initially. And then instead of getting the response as one string, we're going to get a bunch of chunks, okay? And we'll do kernel.invoke prompt streaming async this time, because we want to do streaming. And then we'll hand in our message. Now this call is going to actually give us an iasync enumerable. And so hopefully GitHub Copilot might help us with that. And it does, nice. So we need to await for each of the chunks. And we'll just concatenate those onto the response. And then we got to tell Blazor that, hey, my state has changed. So please update the UI accordingly, re-render the component. Okay, so let's go ahead and hot reload that into the app. And so now, if I type in here, let's say, tell me something a bit longer. I want it to have a bit longer response so we can see the streaming really happening. We'll go ahead and send that to the model. And then once the response starts being generated, we should see it start to chunk in. Yeah, there it goes. Okay, yeah, and you can see it's doing a bit at a time, and it's come up with some interesting response about bioluminescence. That's great. Okay, so we got streaming working. Awesome. Now let's try something else. Let's ask it, what was the last question I asked you? Like, does it remember things? Does it know my previous questions and its previous responses? And no, it doesn't look like it does. I think that's just the current question. So right now it has no like chat history notion. Like right now, this AI model is acting in sort of a stateless way. You send it a request, it sends a response, and then it forgets everything else. So how can we give it some memory? Like how can we give it a way to remember its previous responses and my previous questions? Well, we do that by adding some chat history. So let's add a chat history object here to my component. We'll just call this chat. chat, and we'll new that up. All right, great. And now what we want to do is, like, before we send our prompt, our message to the chat service, we want to add the user message to our chat history. We're keeping track of all the user messages. And then when we're done, we're also going to add whatever the assistant sent back to our chat history. So the response is going to be added here. And then I want to send this whole chat history to the AI service in order to get the response. Now, to do that, I can't actually use this kernel API anymore. I need to kind of drop down a level to a more powerful API. So we're now going to inject the iChat completion service. We'll just call this chat service. Okay, so that's a slightly more flexible API, but still use it pretty much the same way. And we do chat service dot get streaming chat message contents async. Okay, so very similar. And then I'm just going to pass in the whole chat like that. Okay, so that's going to get all the chunks and render the response. Let's restart the app since we injected a new service. And hopefully now it'll start remembering things like what we sent it previously. Okay, so let's see. How are you? Let's ask it a first question. There it goes. I'm an AI. I don't have feelings, but thanks for asking. Okay, now what was the last question I asked you? Let's see if it remembers that now. You asked, how are you? Okay, we got some chat history now and remembers things. Cool. Now, this AI model doesn't currently have any specific purpose. It's just a general interaction with the AI service. How do I give it a purpose, like a persona? I want it to actually do something specific for my app. Well, the way you do that is by sending an initial prompt to the AI model to let it know, hey, this is what you're all about. This is your purpose in life. That's called the system prompt. And you can send the system prompt using this chat history API. So right here in the constructor, you can see here, there's this system message that you can pass in initially to the chat history. So for example, if I said, I want you to talk like a pirate, right? And then if we do that, and then if I refresh, and then I ask it, how are you? Now it's like, I be doing fine, matey. How be the wind's blowing you today? So now it actually has some persona, it has an initial context that it can use to decide how it acts. Okay. Now for this app, what I want to do, I have a system prompt here that I've already set up that I'm going to use. And let's see, I want this chat assistant to be a helpful chat assistant that demonstrates the capabilities of Azure OpenAI in a Blazor app. And then here we can also constrain what we don't want it to do. If you're asked to do something like dangerous or hostile, you should suggest playing a nice game of chess instead. Okay, so you can constrain things as well. So let's hot reload that in. And then I think I can just refresh the page, and that should work. Let's see. What kind of AI assistant are you? And let's send that. It says, I'm an AI assistant powered by Azure OpenAI, integrated into a Blazor app. Good. Okay, so now it's got a persona. And if I try to do something like you're stuck in traffic and you're just feeling irritable, fire the photon torpedoes, right? And let's see if it's going to do that. And it says, it sounds like you're ready for some intergalactic adventure. Well, I can't actually fire photon torpedoes. How about we engage in a different kind of challenge? How would you like to play a nice game of chess? So we've kind of constrained it to not do things that we don't want it to do. So that's how you can use your system prompt to give your AI assistant some purpose in life. Okay, now what I want this AI assistant to be able to do in my Blazor web app is I'd like it to be able to help me with some styling. This Blazor web app is using the same design that Blazor templates have used, I think, since we first shipped Blazor back in 2019, 5 years ago. It's got this sort of purple gradient here on the left-hand side. And while it's beautiful, maybe it's not the be-all, end-all of web app design. Maybe we can get the AI assistant to help us out with that. Okay, so let's see. Let's go back to Visual Studio. And I'm going to add another line to my system prompt to let it know that this is what I want it to do. Okay, I'll just add it right here. So when requested, you can change the theme colors of the app using CSS colors. Okay, and then now I need a way for the AI model to actually be able to change the theme colors of my app. How can I do that? Well, I'm going to do that using a plugin, a semantic kernel plugin. Plugins are super cool. They're a way that you can expose functions and methods from your application that get advertised to the AI model, and then it can decide that if it wants to call them, and it can then send a response saying, yeah, I'd like to call that function with this data. And then your app can decide whether it wants to allow it to do that, and then feed any data that comes back from that call back to the AI model and so forth. So it's a way to expose local functionality and data from your app to the AI model. Okay, so we're going to add a plugin to this Blazor web app. Let's add a class, and we'll call this the theme plugin. Okay, and I'm just going to copy in some pre-written code here just to save on time. Let's do this. Okay, so we have a theme plugin class, and it's got a single method, the set theme colors method, and it takes in 2 colors. And it's I'm using this is the C# primary constructor feature. I'm pulling in the IJS runtime service from Blazor, so I can do JavaScript interrupt calls. And I'm just making 2 calls down here to set 2 CSS variables in JavaScript to change the colors of the app. Okay, so I need to actually set up those CSS variables. Let me go up into my app CSS styling, and I'm going to just add a little bit of CSS here to create those 2 CSS variables. So a navy color and an indigo color. I'm going to try to keep it as the app is currently. And then in the layout, and here we're going to change the gradient to actually use those CSS colors. So right here is the linear gradient that's that purple gradient on the side. And I'm just changing it to now use those 2 CSS variables. Okay. All right, cool. So now we've got the theme set up. We've got a plugin that can call into JavaScript to set these CSS variables, change the theme. How do we now register our theme plugin with our application so that the AI can call it? Well, let's go into Program CS. We need to set it up with the kernel. Now, one way you can add plugins is right here off of Add Kernel. There's like a plugins collection that you can add, add from type or add from object. That works really well if your plugin is like a singleton. It's just a single instance. In my case, my plugin is actually I need it to be a scoped service because it depends on that IJS runtime service, which itself is also a scoped service. So I'm going to have to do something a little bit more complicated, but not too bad. I'm going to do add scoped down here, and then I'm going to call this kernel plugin factory helper method to create my plugin from my theme plugin type. This returns a kernel plugin instance based on the theme plugin class that I'm feeding it. And that should then get picked up by Semantic Kernel so that we can let the AI model call it. Okay, so a little bit more elaborate DI going on there, but not too bad. All right, I have to do one more thing. You actually have to tell Semantic Kernel that it's okay for it to automatically call these kernel functions. Okay, so I'm going to go into my home component, and I need to add one setting right here. This guy right here. So this OpenAI prompt execution settings object. We'll add a using statement for that. It needs to set up this tool call behavior auto invoke kernel function. So that way it will be able to call our kernel function on our theme plugin. And then we just got to hand that in. So let's hand in the settings right here. And then I think I also need to pass in the kernel itself now to my chat completion service. All right. And that ought to do it. Let's restart the app. We messed around in DI, so we got to rebuild the DI container. And then once that's up and running, hopefully now I should be able to say, please set the theme colors for my app to something hip and cool. Okay, and let's see what it comes up with. All right, so sent our prompt. Okay, how about we try a combination of modern teal and stylish coral? And it changed it. It did it. It called my my kernel function. Awesome. And we can even ask it to tweak the colors a little bit, like please improve the accessibility given that the text is white. Okay, so we can have a little conversation to adjust the styling a bit. And it should hopefully darken things a bit. Shall we proceed with this new theme? Oh, yeah, it's asking me to confirm. Yeah, go ahead. There it goes. Okay, so it's updated the colors again. Awesome. I don't know. Maybe that's what the new Blazor web app template should now look like. All right, so we were able to connect our Blazor web app to an AI service. We were able to do a chat assistant that can stream in the responses, have chat history, and then we were even able to connect it to some local app capabilities using Semantic Kernel and plugins. Pretty cool. Now this AI assistant UI is still pretty simple. If you wanted to have more elaborate features like suggestions and have it access more data and even cite that data, you can do that too. For that, I would encourage you to look at a different sample that we have, which is this eShop support sample. You can find this on GitHub. I think Steve Sanderson showed it earlier in the conference today. And if we look at this app, actually, do I have it still running? Let me pull it out over here. Get it going. I'll show you what this looks like. All right, this is a pretty elaborate app that's using .NET Aspire to coordinate a whole bunch of AI-related processes and services. But here in this staff web UI application, this is a UI that a support agent can use to handle like support tickets. Ooh, yeah, there's LastPass. All right, so here's like a grid where you can look at all the support tickets that are coming into the web app site. And if we pick one of these, you can see that it shows the chat interface with the customer. And it's got a bunch of nice AI features like this summary of the chat with the customer and so forth. But even better is it's got a full Blazor chat UI over here on the right-hand side that will display the full history. You can pick from suggestions. When it's trying to answer the customer's questions, it can see the customer chat and use like product manuals and documentation. Like here, it's even showing me how to respond to this customer based on some content from the product manual and so on. So a much more complete sample. Be sure to check that out. So if you want to figure out how to build a much more fleshed out Blazor chat user interface. Cool. Okay, so that's pretty neat. That's how we can add AI features to our Blazor web apps ourselves, like building them ourselves. And there are plenty of ways to add AI capabilities to a Blazor web app that aren't just chat. You can have features like text summarization or smart type suggestions or semantic search. Blazor's component model makes it really easy to package up chunks of AI-related web UI so that they can be reused. The .NET Smart Components are a set of simple drop-in components for Blazor, as well as MVC and Razor pages that make it easy to add AI features to your apps for useful scenarios. Now, we've made the code for the .NET Smart Components freely available as reference implementations. They're basically a bunch of samples so that they can help bootstrap an ecosystem of AI-enabled .NET components. Let me show you what the .NET Smart Components can do. You can find them at ak.ms/.net/components. All right, so let's hop back into Visual Studio. And let's go to the .NET Smart Components. There we go. All right, here we go. So I'm going to go ahead and get this running. This is the sample app from that Smart Components repo. Okay, so first thing, let's look at Smart Paste. So Smart Paste is just this Smart Paste button. And what it does is like, sometimes you have a form with form fields, but the data that you're trying to enter into those form fields is coming from free form text. Like maybe you're getting an email from someone or a text message, and you have to like copy and paste like the name out and the age and put it in each of the separate fields. Wouldn't it be nice if you could just like copy all the text and just hit Smart Paste and have the AI model figure out where the fields should go for you? So that's what Smart Paste does. You can see it put the right name in the name field and the age in the age field. Here's another example. This is like a bug submitting form. If I grab one of these like email texts with a bug report and just, oh, I don't have Smart Paste in this feature. Can I add it really quick? Let's go and find the bug report form, and let's just add a Smart Paste button right there. Yeah, now I've got my Smart Paste button, just hot reloaded in. So I quickly dropped in a Blazor component, and boom, now people can add bug reports using this form by just clicking Smart Paste. It figured out what the repro steps are, what project it should go in, and so forth. So that's Smart Paste, and it works with any form. That first form that we were looking at, this was actually built not with like generic Blazor components, but was actually built with the Radzin component library. Radzen's a great open source and free component library for Blazor, and Smart Paste works with their components as well. So there's the Radzen template form and so on. Okay, so that's Smart Paste. Smart Text Area is a text area where it will suggest completions. Like, let's imagine this is an employee query response form where you can ask questions about, like, you know, HR policies, like what's your employee vacation balance, like your employee vacation balance, and, you know, the person doing this will be like, oh, I don't remember how much it is. Oh yeah, it's currently 10 days. You can find the policy. What's the URL at? Oh, it's got nice semantic smart completions for me that you can configure. Like if we go look in the smart text area sample, here you can feed it a bunch of phrases that it can feed to the AI model to use to help provide those smart suggestions, including all the URLs that you might need to include or any contextual data that might be useful. Okay, so that's smart text area. And then lastly, smart combo is a semantic search enabled combo box. Like maybe you have a big long list of items and you don't remember exactly the right item to pick. Like for an expense category, you've got a plane ticket, but you don't remember what the category is. Semantic search will match what you typed in semantically with the list of items, so you don't have to remember exactly word for word what those items are. Another example is like maybe you have an issue, you're trying to remember the right issue label, and you know it's a mobile issue, but you don't know which label to use. Ah, okay, it identified the mobile related issue labels for Android and iOS. Excuse me. All right, so that's cool. So that's semantic search. And this is actually using a local model, calculating local embeddings using that local model, and you can just drop it into your existing apps. So those are the .NET Smart components. It's a way that you can have Blazor components that just add AI features directly to your web apps without you having to do a whole lot of work. All right. Now, the smart components are actually, they're just samples. They're like ways to get you started with building AI features. But there are also pre-built AI components available from the .NET ecosystem. So let's take a look at some of the great .NET AI components that are coming from you know, the big component vendors of the world, like Telerik, DevExpress, and Syncfusion. Now, Telerik already provides a pre-built AI prompt component to streamline integrating AI services in your Blazor and MVC apps. It's fully customizable through templates and events, and it supports globalization, localization, and right to left rendering. Telerik also has several experimental smart components that they're working on that you can try out, including smart search integration in their data grid and also in their combo box controls. And they were kind enough to give me some demos to show you. Let's look at some of the Telerik components. Okay, so let's go back here into Visual Studio, and let's bring up Telerik. Okay, so here's the Telerik sample apps. And let's first take a look at their built-in AI prompt component for Blazor. And this is already shipped, and you can use it today. So this is going to show the Telerik PDF viewer that'll display some, you know, Telerik PDF document with a whole bunch of text in it. But what's neat is it has this AI assistant button that we can just click. It's got a place to put in the prompt. It's got suggestions that it displays. It will display the output. So we can ask it something like, I don't know, how many components does Telerik have? And that should be able to look in the PDF doc and find an answer. Telerik DevCraft has over 1,250 modern feature-rich components. Is that really true? Let's see, did it hallucinate that? Yeah, down here, it features 1,250 modern rich components. So it's actually pulling from the doc. So that's a pre-built AI assistant UI that you can just use. And then for some of their Blazor experiments, they have, this is their Telerik data grid that's got semantic search integrated. So here it's displaying like a bunch of food categories in the grid, and we can search with specific foods, and it should find the appropriate food category. Like if I search for milk, we find dairy products. If I search for cake, then we find things like desserts and candies and confections. So semantic search in the data grid, that's pretty neat. And then they have their own version of a smart combo box. This is pretty cool. Like it actually has a, you know, drop down, shows you all the options that you can look through. And then if you start searching like for pasta, it'll show you all the pasta related food items in that combo box. So smart search and pre-built AI prompt component from Telerik. Pretty nice. All right, now DevExpress, they're working on a bunch of AI-powered enhancements for their upcoming release in December. So this is stuff that's in the works. They're adding integrated APIs to make it really easy to connect to Azure AI services and really any model with DevExpress UI components. They're building AI-assisted text processing in their text editing components. They're also working on a pre-built Blazor chat UI for creating your own copilots and chat assistants. And what's really neat is they actually have working on integration with Azure AI Assistants, which is a new API, a new stateful chat API with support for persistent chat threads, access to like multiple file formats that you can feed into it, and also powerful built-in tools or plugins that you can just use without having to build them yourselves. Let's take a look at some of their new stuff. They actually gave me an early preview of some of these new features that we can try out. All right, so let's go look at DevExpress. All right, so if we run this. All right, cool. So here we have the, this is the DevExpress data grid, and this is showing a whole bunch of like project information, a bunch of work items and their priorities and their state. But what's neat is over here on the right-hand side, we have the DevExpress chat UI component that's just there and ready for us to use. Let's ask it a question. Let's ask it, which specific task should the team focus on and why? We'll feed that into the model. And that has access to all the data in the data grid. So it should be looking at all this data and then trying to figure out, okay, well, let's look at priorities, let's look at the status and see if it can figure out which items are best for the team to work on. There we go. Oh, so, okay, so we got a high priority task to check the register. It's assigned to Mike Roller and status is new, so that looks good. And we got a bunch of medium tasks that we should probably do next, and then the low priority task. So that's awesome. Yeah, that looks exactly right. So that's the chat UI integrated with their data grid. Here's another example where the chat UI is integrated into their report viewer. So this report viewer is like displaying reports in a PDF format. But again, we can pop out their AI assistant, chat assistant UI. And here we can maybe ask questions about this market share data. Let's see, let's ask it, how did the market share change in India? Okay, let's see, market in India went up by 9.52% in March and then down by 20.62% in September. Is that actually correct? And yeah, that looks right. These values are in fact coming from that report. So that's cool. So that's the chat UI from DevExpress. They also have really great rich text editing components. Like this is like a word processor component that they ship. And that now they're working on AI integrated features. So you can ask it to like translate the word processor into German for you using AI, or you can ask it to like summarize some text for you. Let's summarize this big long paragraph using AI, and like, there's a much shorter version so you can get the pithy read. Okay, so those are some new features coming from DevExpress, a pre-built chat UI component integrated with AI services and integration with their rich text editing experience as well. Lastly, I want to show you some stuff from Syncfusion. Syncfusion is also building out AI features for .NET with several new features coming in their upcoming Essential Studio 2024 Volume 3 release in September. This release will include a Blazor AI Assist component for integrating AI services. Their AI Assist component can send and suggest prompts, execute commands using toolbar options, and even display responses in an easy-to-use format. It provides toolbar options for copy, edit, like and unlike, and you can, of course, add your own custom toolbar options too. So let's take a look at what they've got with their AI Assistant component. Let's hop back over here into Visual Studio and look at Syncfusion. Sure. All right, and this is, again, early bits from them, so this is all still in preview. Let's go ahead and run it. Okay, so here is Syncfusion. Here's their AI Assist component. Really nice chat UI. It's got suggestions. It's got these like toolbar options for copying and saying like and unlike. We can send a prompt into the model. shows the whole chat history there and it renders the response. So nice pre-built UI, so you don't have to do it all yourself. They're also experimenting with the .NET Smart components. Like here's a Sync Fusion version of Smart Paste that they built that is integrated with the Sync Fusion Blazor components. Like we can copy this text and again, fill out this bug report form. Again, all built with Sync Fusion components. And they also are working on their own smart text area. Again, it will do smart suggestions for us. You can see it's even typing for me. It's like guessing what the complete next sentence will be. Pretty cool using the AI model. So those will work with the Sync Fusion theming systems and so forth. So those are experimental and are working on those as part of their upcoming release. All right. Awesome. So that's what I wanted to show you today. So in summary, Blazor and .NET can make building your next AI-powered web app really easy. You can build AI features yourself using powerful .NET libraries like Semantic Kernel, or you can leverage a whole ecosystem of existing .NET AI components. Here is a summary of the samples and resources that I mentioned in this talk, so you can go and look at them and try them out yourself. Thank you very much for listening, and be sure to check out other ways that .NET can help you build your next great AI-powered app at aka.ms/.NET-Focus AI/collection.
Hello, everyone. I'm super happy to be here talking about AI. This is a full day about AI, and my name is Bruno Capuano. I always forget about this. I'm part of the Cloud Advocate team. I focus on .NET and AI, and today I want to talk about local models, how we can start using local models and how we can move later to the cloud and how we can evolve the things that we can do local in the cloud. This is going to be a fun one. So this is very quickly the overview of what we want to do. I'm going to spend a lot of time coding, you know me, but I want to set up the context first to talk a little about small language model, 5.3 and more. So small language model, this is probably new because we always talk about large language model, but the best way to introduce small language models is to think about these very amazing big models like GPT-4, but in a lower scale, in a scale small enough that you can run it in your own computer. You can run it in your own PC, your Mac, your laptop. You can even run this in a Raspberry Pi in a very small device. And there are so many advantages of using these models. The first one is that, of course, they are not as powerful as a GPT-4o model, but they are very, very good. Think about that the best 5.3 model is probably as good as a GPT 3.5 or so. So there are a couple of things that we want to think here because they are very, very good. And of course, the one that I'm going to use most of the demos today is going to be 5.3. 5.3 is one model that we released at Microsoft. The Microsoft research team did this. There are different versions, different flavors here. We have the mini with 3.8 billion parameters that we can use. We have one that also do vision, which is amazing. And then we have kind of a mini, medium, and the big one that we can use. And there are also versions available to use in Azure AI Studio, in Hugging Face, locally with Ollama. You have the Nonix runtime. Hey, we are going to see this. And the whole idea today is show how we can start here, how we can start to use this, and later maybe move to the cloud. This is what we want to do. So switch back to the code very, very fast. First of all, the first thing that I want to do, I talk about 5.3, and we have a repo, an amazing repo. If you search for this, this is the 5.3 cookbook. This is a great place with tons of samples of how you can use 5.3, how you can fine-tune 5.3, how you can use it locally, on the cloud, and more. And hey, if you even go here, you have a C#.NET lab sections that is going to guide you step by step of how you can download the model, because remember, this is local models, so you can do something as popular as, hey, I want to do a Git clone of a model from Hugging Face, and it's going to download the model. By the way, this is the one that I'm using today for doing this. And then you have some step-by-step scenarios of how you can use this with Semantic Kernel, locally, in code spaces, and more. So this is one of the most important parts. Go into Hugging Face, in example, and download the model. Again, you can use the 5.3 cookbook at the entry point of everything that we are going to see today. And how you can use this? How you can start to use this? Okay, one of the versions that we have in 5.3 to use it is an export of Onyx. If we go back here and see the version that we have, we can see that, hey, for the Mini 4K, there are kind of different versions, but the Onyx is the one that we want. And why Onyx? Onyx is a standard. About this is kind of a nice standard, and we have libraries in Windows and in .NET and in other platforms to basically access a model. Any model that is supported at Onyx, we know how we can interact with the model. So here we have a C# project that is going to, using a path of a model, we have here the path, we are going to create and use the library Microsoft ML Onyx Runtime GenAI, and we are going to load the model. We are going to create a tokenizer to basically manage the information that we want to use with the model. And then in an eternal loop, what we are going to do is we are going to build, and this is important here, we are going to build the specific string that the model requires to understand the system prompt, understand the question, and give us an answer, and we are going to generate the parameters and send this to the model. So this is kind of, this is probably 70 lines of code, part of the demo that we have here, and it works fine. If we run it here, let's do a .NET run. What this program is doing right now, as I said, is loading the model in memory, and we have a loop where we can say, hey, my name is Bruno, and now the 5 trees are going to start to answer, hey, hello, Bruno, how can I help you today? What is my name? I can ask the name, but because we didn't implement some kind of chat history or memory here, the model doesn't know what can I do. The model doesn't know who I am. But what I really like about this is that if you are a fan of semantic kernel, and if you know me, you know that I am, we have the chance to do this with semantic kernel. So what we can do here is, I created here an example where this is an extension of semantic kernel that allows us to use semantic kernel as the main connector for the models, but interact with the Onyx model. Again, this is all part of the 5.3. And what we are going to do here is we are going to go back to bases. We are going to have the location of the model, the 5.3 models, like wherever you want to do it. Then we are going to create a kernel, add this Onyx runtime chat completion service, and then build the model. And after that, we just create a chat, we create a history, and in a loop, we start to ask questions to the model. This is literally the same as the previous one, but using semantic kernel. So we will go back here. And let me remember the name of this one. This is lab3 semantic kernel 2, and we do .NET run. What we are going to see, a lot of information. This is semantic kernel in the back, loading the model. Take some time, depending on how big is your machine. And then I have here in the bottom, hi, 5.3, hello, how can I help you today? My name is Bruno. Can you help me? And here we can see, hey, of course, Bruno, I'm here to assist you. What do you need help with? And I can say, what is my name? Because by default, the chat completion service can handle history. Hey, your name is Bruno, and yada, yada, yada. So it's kind of nice how literally with a little extra lines of code using semantic kernel syntax, we are here in 60 lines, but this is an amazing sample. And hey, this is all running locally. Remember, this is important. And what we can do with this, if we run local, if we start to do some kind of more complex scenarios, think about we want to do kind of have information in the memory. I want to start to have some store information in a vector database in the memory and use local models to query the memory and do these kind of things. There are several parts we can do here, but we can run everything locally. And the whole idea of this RAG scenario is that I have a question here. And the question is, what is Bruno? Sorry about that. What is Bruno favorite the best amazing superhero for me? The model won't know this. And I am going to ask this. And I am using here Spectre console output to make it a little beautiful. But once I have the response for the model, which is usually, hey, I don't know, Bruno, I can't answer this question, give me more. What we are going to do, we are going to create a memory. This is going to be a volatile memory here. We are going to create a local embedding service to basically generate these embeddings. And then we are going to ask the same question but using this prompt. Hey, answer the question that we have here. So what is the superhero that I like more? Using the memory context. And with this, we are going to have the response. And remember, again, this is all going to run using the local model path that we have here. So let's go to the terminal again. Like make this a little bigger. And let's load the one for RAG. There it is, clear, and .NET. And I'm using this here because I added some formatting, as you can see here, so it's nice to have this. So first question, who likes Batman? Oh, who likes Batman? This is part of the response that we have here. I didn't change the question. So the first question that we want to answer is who likes Batman? And the 5.3 memory response is going to say, hey, Batman is a super popular character, appears in a lot of places, yada, yada, yada. So we are not going to have an answer. But if we take a look at the code here, if we take a look at the code that we have here, when we load the memory database, what we have here is a set of items, and these items are, okay, Gisela has the best superhero for Gisela is Batman. The last superhero movie that Gisela watched was Guardian of the Galaxy. By the way, Gisela is the friend who helped me to build this a long time ago. Then Bruno, best superhero is Invincible. The last superhero movie was Deadpool. And then I didn't like Eternals. So when I ask the question about, hey, who likes Batman? I have a very, very big response about the model that Batman is a character, yada, yada, yada. But when I ask the question again, when I ask the question using the memory, it's going to say, hey, based on the memory content provided, Gisela's favorite superhero is Batman. Therefore, Gisela likes Batman. And if we go to the facts here, yes, we have here that Gisela's favorite superhero is Batman. And we can change the questions here. We can do more. If I do the question, and because we are using this RAG locally, if I use the question instead of in English, if I do the question in Spanish, which is, what is the favorite superhero from Bruno, but in Spanish, this is ¿Cuál es el superhéroe favorito de Bruno? So if we run this again, what we are going to have is that first, the response in Spanish, como asistente virtual, I don't have information about this individual. And if I ask the question again, it's going to say, hey, Bruno, favorite superhero is Invincible, which is kind of nice. This is what we have. And by the way, you can test this in other languages like French, English, Spanish. Hey, there are so many things that you can do. And remember, this is all working locally. We have a local model here, which is giving us the chance to create these embeddings and do more. But when we started to do this, when we started to aim for this scenario, one of the ideas is, okay, and how can I use this? How can I use a WIN form, in example here, that use a local model and do more? So what I did in order to see this, I searched for a chat WIN form application. And I went to GitHub and I started to see, okay, give me some samples about chats in WIN forms. And I like the third one here, the A Green Tejada. I clone this one, I fork the repo, I clone it and start to work. I make a lot of modifications here, but I get to a point that I build this. So let's take a look at how we can do this here. So let's close this one. And what I built in order to show this is kind of a nice one. So let's go here, focus on AI, close and close. And what we have here is a chat WIN form application. You can see here, this is the desktop application. Then we have an API that is going to manage the chat, that is going to manage the calls to the models and more. And it's all going to be wrapped with Aspire. Why Aspire? Hey, because Aspire is cool. And it's also give us a lot of information in order to see how we can use this. We can trace this, we can see how it's working. So here, initially, this is the server. Let me add some code here in the server. So let's maximize this. I have some snippets here. I use this and I do this usually a mix between Visual Studio and Visual Studio Code. And what I want to do here is basically when I am builder, this is the program, the API. So I have the controllers, the endpoints, the Swagger stuff. I add configuration. I create a chat history here. And then let's do a local model here. So what it's going to do now, it's going to load the model as we've seen before, and it's going to answer the question. It's going to add this into the builder services, and then I can use it. And the way that I use it here is in the chat controller, which is going to get the question. This is a class with the question, a name, a couple of information. It's going to ask the question to the chat completion service, and it's going to give the question response later. So it's a very simple API. So let's run this using Aspire, and let's take a look how it works. And I have here somewhere, this is the window, the WinForm application. As you can see, a very simple one. And I can say, hey, my name is Bruno. So if we go to see the task here, we are in the server, we have a debug in the breakpoint here, and what is going to happen, that is going to ask the question to the chat completion service, which is basically answering, let's remove this, which is basically answering the question here. So, hey, my name is Bruno, and we are going to say here, continue, and we're going to have the answer. If we go to the traces here, we are going to see how it's calling the backend, and we have this, and the final one has the response. This is because Paul is making the retries for this. But remember that we talk about, hey, Bruno, I'm your friendly AI, what's in your mind today? But remember that we talk about, hey, there are so many different models here. I have the chance to use 5.3, small, medium, the Vision one. And hey, you can download this, you can clone this locally, but there are other options that are very good in order to use and test this model. So Onyx is amazing. Onyx is literally kind of the direct access when you have your models in the disk. You can use Onyx to load the model. But then we have other options and third-party applications like Ollama, which are very great because Ollama, in example, you can download Ollama to run in Windows, in Mac, or in Linux, and then you can say, hey, Ollama, download the model. And we have Llama models here. We can have the 5.3 models here and more. If we go to the 5.3 models, we have this version of the models, the big one, the 14 billion parameters, the 3.8 billion parameters, and more. And you can download this and have it locally. And there is also an option here in Ollama where you can run Ollama as a Docker. In Docker, in a container. Where is my Docker? Somewhere here. Oh, there it is. And when you have Ollama here working in a Docker container, hey, you can do amazing things. So let's start here. And because this is up and running already, let me open a terminal and let me show you the models that we have here. So if I run Ollama list, it's going to show me here that, okay, I have 5.3, the big one, 14 billion parameters. 5.3 by default, this is a small one, the mini, then I have Llama. And how do I run this? How do I use this if I want to use this in my code? Because we are using semantic kernel and we are using kind of the basic view of what we have when we load the model, instead of doing this, what we are going to do is we are going to call this code. And what we are going to create, a chat completion service, and we are going to create a new OpenAI chat completion service where we are going to say the name of the model, the URL, and then we need the API here because it's a default parameter. I'm sorry, it's not an optional parameter, but we need to add this. But with this, we are going to have a chat completion service that is going to help us to have this. So no changes in the code, just creating a new chat completion service. And now we can go back to our project here. Let's close all of the windows. And let's run this. And when we run this, we are going to start to see how we have the calls to Ollama. So let's run this. Okay, we have here the form. And if we go here to the logs of Ollama, we can see the logs here. And if we go back to the form, where is my form? There is my form. And I ask a question and I can say, hey, my name is Bruno. Can you solve math problems? We start to see in the back how it's loading the model. It's going to take a couple of seconds the first time because it's kind of warming up the model. We can see very, very small here that the model took 2 seconds to be loaded here. And the model name is somewhere here in the top. Where is the model name? Somewhere here we have the name of the model. Where it say Pi3, that this is the one that we are loading. And if we go back here, say, okay, here's Bruno, absolutely, I thrive on numbers like a starfish does in the sea, yada, yada, yada. So if I do, so I don't know, 2 + 2, again, we are going to see a new call here in chat completions. The third one here, and it's going to say, hey, yes, 2 + 2 is 4. And right now, what we are using is a model that is hosted in Docker with a container that we have from Ollama. If we go to the traces here, and we start to see here the calls, we can see here basically the Win form that calls the chat, that calls internally the Docker container that is running in localhost 11434. And hey, if I want to change my model from 5.3 to, can't remember the name of the other ones. Let's go back here to the console. If I do Ollama list and I copy the Llama model, what we can do now is instead of running the model 5.3, let's run the Llama 3.18b. Let's say the name also here. This is Llama 3.1. And then we are going to run this literally. And again, the first time it's going to take some time because it needs to warm up and connect to the model. But if I go here to the logs and I say, hey, we are going to see, yes, it's loading the model. There it is, the name. Oh, there it is, the name of the model. This time I find it, MetaLlama 3.18b instruct, and we have the answer here. So this is a super easy way to change model. And this is also a great way to basically run Ollama, to test your model here and there. And if we go to the traces here, we are going to start to see again that we have calls from the front end to the back end and to the Docker container with the calls. And there are so many things that we can do here. Remember, this is just a model that we use for this. If we want to do RAG, if we want to do more, we can literally switch and start to do amazing things. But how about going an extra level here? And the extra level is, hey, I already changed my model to, instead of load the model from a local file, calling a URL. In this case, the URL is a local port from a Docker container. But how about going to the cloud? What happens if I want to run a model, a 5.3 model, an example that I had hosted in Azure AI Studio that I created there? So, hey, literally, with a simple change in the line, we can do this. So let me show you here. This is Azure AI Studio. There are a lot of models here. We have Mistral models, Llama model, 5.3 model, GPT models, and more. And here in the deployments, what I have is a couple of models. I have a 5.3. Let me open this a little. I have a 5.3 mini model, and then I have a vision model here. So what I am going to do, I am going to change the code to basically use this model. So let's go here. Instead of localhost, let's put that URL. Let's copy also the API key. Now we need the API key. And let's change the name of the model, which is this one. So now we are going to call, this is a 5.3 model from Azure. I'm just changing the name. But just to recap here, what we are going to do now is call a model that is hosted on the cloud. And if you want to see how you create a model here, it's just go into the deployment, right-click, new model, select the model, choose the way that you want to use it, and that's it. So let's run this, and let's see if it works. So we have here the model, we have the chat, and say, hey, my name is Bruno. And hey, Bruno, we come here, we have a web from limbs, I don't know. It's always answered a couple of silly things. But if you go to the traces here and take a look at the trace, hey, this is kind of nice. Start on a Win form, call a backend, call the cloud. We have the same model up and running here. And what is important here, what is really, really nice is that we also have a vision model. Remember that at the beginning when we talk about 5.3 and when we were here, I show you that we have a vision model. I can deploy a new model and can deploy, let's search for phi, and we are going to find that we have fine vision. This is a specific one that can analyze images and more. This is a lot of information here. By the way, you can fine-tune the model. This is amazing. We don't have time to take a look at this, but fine-tuning models, it's great. But I already have the vision deployed. I already have the vision deployed here in the cloud. So what we can do, I already changed my applications to support this. So let's make the app use the vision model, and also let's make the app analyze a couple of images. So I'm going to change the endpoint. I'm going to get the key. And I need to change the name. The name of the model is Phi3 Vision 128K Instruct 2. So I have this. And the main difference here that I have is that when I am working in my chat controller, when I send my message, I need to double check if I have an image. So what we are going to do here is, if the question has an image, create a collection with the text and the image and send this to the model. That's the only difference that we have right now. So with this up and running, let's give it a try. And let's change the name to Phi3 Vision. I like Phi3 Vision. Okay, so we have here, let's select one image. I have a couple of images. I have this image of my cat. Please describe this image. And this is the image that we have here, which is my cat and a dog in the bag, and hey, it doesn't understand the image. Oh my God, this is what we didn't want to do. Let me create the model just in case I put some of the... Can you read? Let's give it a try. Can you read the text? Let me update this just in case and run it again. Asking to, I have a couple of licenses here with Jedi stuff. So read the text in the image. So let's give it a try to see if we can use this. So you can see here that we have Jedi I am, and it's not reading the text. Something happened with the model. Probably is going to be used for another third party, another demo somewhere else. But if we go to the traces, and this is what I want to show, hey, we have here again a call from the WinForm to the backend to the Vision service, and we can see here that, hey, this is the Vision service that we are using, and this is how it's working right now. By the way, we can even do this locally. We have here, I have here in the semantic kernel, I have a sample that is using the vision model to analyze an image. And hey, it takes some time, but it also works. So if I debug here and start, this is the image that we want to analyze. Working there. And if I go here, this is the image, which is my cat and my dog. And after literally 1 or 2 minutes, I am not running GPU, I'm working on CPU. This is that we are going to have a description of the image. So quick recap of what we see while this is working. We see how we can start working with local models. We see how we can start to working with the local model that you have on your disk. Phi3 is one of the most popular examples. Llama 3.1 is super popular. We move to use this model for a Docker container. And literally changes in the chat completion definition using semantic kernel. 2 lines, 3 lines of code, and that's it. And then we move the same lines for going to the cloud. We deploy a model to the cloud, and when we have the model in the cloud, we have the chance to literally, without changing the code, have all of those capabilities. And we can do RAG, we can do search, we can do a lot of things. And if we are using the Phi3 models, we can even fine-tune the models to be used there. So this is an amazing chance to basically use these kind of things. So this is still working, as I said. It's going to take a couple of minutes. I am going to close the demo here, invite everyone. Please enjoy the rest of the conference. It's been a pleasure. Promise to have a better video with the cats recognizes there. And thank you very much. It's been a pleasure. See you next one. Goodbye.
Oh man, local models. That's what I'm talking about. That's going to help me with my development story and be able to build things a little bit faster locally. I like that. I like that a lot. So let's talk about our next sessions that are coming up. We've got a session from Matt Sokup and Roger Pinecombe about OpenAI and Azure OpenAI, that .NET SDK and how we can use it for both services. We've then got Costa Petan and Xiaoyun Zhang talking about building agents, patterns and practices for automating business workflows. So 2 more great sessions coming up, but I want to make sure that you know some of the other things that are going on as part of .NET Conf Focus on AI. I have some slides for you. There we go. Check out all of the Learn content that's available for you. You can take a picture of that QR code, head on over to that AKA link, aka.ms/.NETFocusAI/learn. We've also got some great information for you about an AI challenge over the next month. We've got live streams coming up. We've got a little bit of homework for you to do if you'd like to try out your hands at building with AI and .NET. You can follow along at aka.ms/.NETFocusAI/credential challenge live. All month long, ending on September 20th, you can take a picture of that QR code and learn more about our upcoming AI challenge. And of course, we've got to make sure that we call out .NET Conf 2024. If you've enjoyed this event so far, make sure you join us for our 3-day event coming up. It's all online, it's all virtual, and it features the .NET 9 launch. Join us November 12th through the 14th at .NETConf.net. There's a save the date button there, so you can get a little bit of a calendar entry for your Outlook. You can also take a look there if you're a prospective speaker. We've got a call for content there that you can click through and join us, because during the 3rd day of the event, it's 24 hours long. We've got speakers from every time zone joining us and presenting and talking about their content, their cool things that they're doing with .NET as part of .NET Conf 2024. All right. It's time to get ready for our next session about AI, OpenAI, and Azure OpenAI with our friends Matt and Roger. Take it away.
Hey everybody, welcome to the OpenAI plus Azure OpenAI session. And this is a super cool session because we're not just going to be talking about OpenAI and Azure OpenAI. Rather, we have a .NET convergence story. That's right, there is a .NET SDK for OpenAI. My name is Matt Sokup, and I am joined by my good friend Roger Pinecombe. And Roger, why don't you introduce yourself real quick?
Hey there, I'm Roger Pinecombe. I'm pretty invested in this because I actually built the first OpenAI SDK for .NET way back in 2020. And I've been really excited to work with the team to help them launch this new official version.
Yeah, so let's jump right into this. And I really want to hammer home that this is the official OpenAI library for .NET. And so that comes with a ton of benefits. Like, it is official, the official library. And so what we're doing here now is that has feature parity with Python and JavaScript and so on, the library. So day one, we have support for everything. So we have the latest and greatest OpenAI features and models, including like GPT-4o and assistance support from day one. And we have a nice unified experience across OpenAI and Azure OpenAI, which we'll be demoing and showing. So we're not big fans of slides here, Roger and I, so we're going to jump right in to some demos. And so Roger, you're going to take it away from the OpenAI side because you have a ton of experience there, and like you said, you have a toolkit that you developed. And I'm going to talk about the Azure side. So let's get going with the .NET OpenAI SDK and show us how it works.
Awesome, yeah. So I want to get started here and just show you the official OpenAI documentation, just to show how nicely everything's integrated in there. So we're here on the OpenAI docs, and on the left side, you'll notice there's a libraries menu item, and there's now a new .NET library section. So you'll see right here, you can just use this example code to get started. So how about we go in Visual Studio, and I'll just paste this right in. So I'm going to actually create a new project. I'm going to show you the complete end-to-end how to build this. I'm just going to make a new console app. And it can be any version of the .NET framework, .NET Core. It's got pretty wide platform support. I'm going to make this here. And then what we're going to do is we're just going to go ahead and manage NuGet packages and add the OpenAI package. Now, what's interesting is if you just search for OpenAI, you'll see this original package. So this is the package I had built over the past few years. The new Microsoft official package is still in beta. It's a pre-release. So you have to click this include pre-release button. And then you'll see that right here. You'll see the official OpenAI logo, so you know it's the right one. And just make sure you grab the latest pre-release version. You can go ahead and install that and agree to the license terms. And now we've got it here in our project. So let's go ahead and using OpenAI. And now we'll go ahead and just paste in that code we copied from the documentation. So right there, and I'll walk you through exactly what this is doing, but basically creating a new client, calling a model of our choice. Now, there have previously been some questions about model support. The models are just a string. So you can put in any model that's supported by OpenAI here. OpenAI launches a new model tomorrow. You can just put that new string in right there. No need to wait for any updates to the SDK. So that's going to come from, if we go here on the left of the documentation, there's the models section, and you can find the model names right here. And you can select any of these models, just pass it in as a string. And then this environment variable. So as you know, OpenAI is a hosted API and it requires an API key. So for security purposes, you don't want to put that right in your source code. That can leak if you post on GitHub. It's generally not good security practices. So what we're going to do is we're going to put an environment variable instead. Now, this might be fairly simple, but just for those of you who haven't done it, especially on Windows, let me walk you through how that works. So we're going to go ahead and get our API key. So on OpenAI platform here, we're going to go to the dashboard, go to API keys, and create a new secret key. We're going to give it a name so we know what's what. You can assign it to projects and permissions, but by default, we're just going to make it with full permissions. And now we've got this key right here. And now we need to add that to our Windows environment. So the easiest way to do this is just to open your start menu and type environment, and then you'll see a link to add environment variables for your account. We're going to make a new one. We're going to call it OpenAI API key, and we're going to paste that API key right in there. And so now, if we go back to Visual Studio, so that will basically be substituted in here from the environment variable. So now we'll have a client that's attached to our account. Next thing here, we're going to get a chat completion. So very simple stuff here. We're just going to give it a user chat message that has it echo back, this is a test, and we want to get the response from that. So you'll notice it gives a chat completion object. That includes various metadata, like how many tokens you used and a few other things. To get the result out, we'll just console write line, the chat completion toString. This is a helper function that basically takes the first text completion object inside that chat completion and gives it to you as a string. So let me zoom in here as well, make it a little easier to read. Okay, so I'm going to go ahead and run this, and we should see it saying this is a test. While it's building. Awesome, and you see it echoed back, this is a test. Now, just to make sure we're actually talking to an AI here and not just echoing back text, let's have it say it in Spanish. Okay, try this one more time. Awesome, so translated to Spanish, and now we know it's actually giving us back an intelligent response. So that's a pretty cool example of just how easy it is to get started. But let's say we want to do something more complicated. So you might notice on ChatGPT's website, when you're chatting with it, the results stream in. So you're not waiting for an entire result all at once. You can see the result as it comes in. So this is called a streaming response. So let's go ahead and implement that now. So I'm going to go ahead and create a new method for chat streaming here. And just like before, we've got a chat client. This time I'm going to use the full GPT-4o rather than the mini, because we want it to take a little bit longer so we can see it streaming. And one thing we did earlier is we made it very simple to just complete chat with a single message, but you can actually send multiple messages. So for example, I might have a system message that I want to send, giving some context that you're a poet and you love technology, and then a user message. You can even add assistant messages here. You can give examples of how it should reply. Basically, your messages is just a list of messages that we're going to send in. So now that we've got our list of messages, let's get the results from that. So all we're doing is we're calling complete chat streaming async with the messages. Now it is a streaming async, so there's two different levels here. Let me show you all the different options here. If we do client.complete chat, you'll notice there's this standard synchronous complete chat, which is what we used above, that blocks until there's a response. There's complete chat async. That still waits until there's a full response. It doesn't stream it, but it doesn't block, so it uses the nice async await pattern. We've got streaming, which streams the result back, but does block until it gets a response. And then the fully asynchronous version that we're about to use, the complete chat streaming async. So that is an async await. It returns a task that we, just in terms of calling the API, and then we can use the fancy awaited for each in order to get the results. So let's see how we would actually enumerate the results here. So we're going to do await for each, and my autocomplete here is, there we go. So await for each, we're going to go through each item in the result, which is of type streaming chat completion update. So what happens is it actually, in update, 1 second. So what happens is every time the API returns additional data, it returns it as an update. Now, this is usually additional text that you can just append to the end, hence this console right here. Although sometimes there's other things in there. There could be metadata. There could be a reason why it stopped. It could ask you to, could give you an image or run a tool. And we'll get into a few more of those details later. But for right now, we're just going to assume that every update is a string that we want to write to the console. And this should be good enough to run. We're basically creating the client, giving a list of messages, asking for completion of streaming, and then for each streaming result, we're writing it to the console. So let's go up here and call this chat streaming async function. And because we're calling an async function from a non-asynchronous function, we have to call wait, and we should be good to go to run that. Give it a second here. Awesome. So you can see the results are streaming in just like they would on ChatGPT's website. It's writing the super long poem here. And we got to see it as it was being written. Now, because we're writing a long poem, we might be concerned about token usage. Remember, with OpenAI, you pay per token input and output. And especially for some of the larger models, that could add up if you use a lot more tokens than you expect. So let's see how we would determine how many tokens we've been using here. One thing that's worth noting is you can get token usage on any chat completion or any API call. But for the streaming results, they only show up on the final result. So what we're going to do here is say, if we have usage information that's been provided in the result, in this update, which will only be on the final update, then we can assume that we're done with the updates, that this is the final part. So we're going to write a line, and then we're going to write out the various tokens here, token usage. So again, we'll have the input tokens, the output tokens, and the total tokens. So let's go ahead and run this, and we'll get another poem, and then we'll get the token usage at the end. Okay, so this one's an even longer poem. It's got longer lines. Definitely curious how many tokens we're using. Okay, so you can see our input tokens was 50. That corresponds to both the system message and the user message we gave it. And the output tokens is a bit over 500. Total tokens is over 500 as well. So that's not too bad. OpenAI is not that expensive, but it is worth tracking this stuff in case you're doing something where you're using a whole lot of tokens. It's good to be able to know how many you're using. Okay, so moving on. Well, just to kind of recap what we got here, we've got chat streaming where we've sent it a couple messages and we're streaming the single results. But there's a whole lot more you can do with OpenAI. So as you may know, OpenAI released a new assistance API earlier this year. And it's really exciting that the new official Microsoft OpenAI SDK supports that, as well as all the other functionality there. So let's make a demo that will actually go through and create a assistant, upload some files to it, ask it to look through those files, and ask it to do RAG, retrieval augmented generation, based on the content in those files, and return results to us. So this is very relevant to if you wanted to understand reports you might have on there, or generate reports from raw data, or if you're doing things like analyzing and writing code, fixing bugs, all sorts of stuff where you might have various files you want it to look at, pull in the appropriate files, and then respond based on that. So let's get started here. We're going to make a new function, assistant with chunks, because we're going to be chunking things. I'll show you how to do that in a second here. Again, we're just creating the client here. We're creating a new file client because we're going to be uploading a file to the service, and then an assistant client. Now you might notice some red squigglies here. That's because the assistant client is currently in beta. So just want to make sure that you're aware that this might still change over time. It's not fully finalized, but it does work. So in order to move on here, we have to disable the warning. And this will just acknowledge that we know it's in beta and it might change, and now we no longer have any errors there. So the first step we want to do, I mentioned that we want it to be able to load files to go through. So let's go ahead and just open a file from our file system and upload it. So this just uses standard .NET file streams. We're going to file, open, read. This could be any file on our file system. It creates a stream. We're putting that file stream into the file client upload function, giving it a name. This is basically the server side name. It doesn't have to be the same as the local name. And we're telling it we want to use it for the assistance. You could also upload files for fine tuning and other purposes, but today we're going to use it for assistance. Now, even though this is really simple and should be intuitive if you're familiar with using files in .NET, in order to make this example very clear, so we're not using any extra files, I'm going to just do it all inline. So this is actually fairly useful for demoing and just to get things off the ground here. So what we're actually going to do is we're going to create binary data from string, and this just allows us to have effectively a literal JSON file right here in our source code. So you probably wouldn't do this in practice, but it does make development a lot simpler. So now we've got this document here as a stream, and we're going to go through and upload that. So again, this document is the stream we defined above. We're giving it a file name, and we're again saying that it's going to be useful for assistance. Let me go ahead and fix a few formatting things that came up here. There we go. So now we've basically uploaded this to OpenAI. So it's now there on the server side and will be indexed by their systems. But we have to explain to it how we want it to be indexed. So we actually create a vector store where the file is chunked into and indexed. So let's create that vector store. The way to do that, we're going to make a vector store client. And then we're going to create a new vector store with the options that define the files that are involved. So you'll notice for the sales file, it returned this file info object that has an ID. We're going to pass a list of file IDs into the vector store, basically telling it which files are relevant for this vector store. Now we could in the future add additional files onto that vector store, but right now we're just going to have that single file there in the vector store. Next thing we're going to do is chunking strategy. So by default, the vector store will figure out how to chunk things automatically. It's pretty intelligent. You shouldn't necessarily need to clarify. But as you may know, for retrieval augmented generation, it can be useful if you have a good understanding of what your data looks like to manually define the chunking strategy, depending on how much overlap there might be or how big sections are in your data. So what I'm going to do is I'm going to update this code to use a manually created chunking strategy. We're going to basically say here that we want only 100 tokens per chunk and we want 30 token overlap. So that's going to tell OpenAI how to chunk up this file we gave it into multiple different vectors. And the way we're going to pass that in here is just in the vector store. In addition to the file IDs, we're going to give it a chunking strategy. And that's the file or the object we defined above. Okay, so we've uploaded a file. We've created a vector store to embed the file into. Now let's go ahead and continue making the assistant. Before we make the assistant itself, though, there are a few options we need to specify for the assistant. So that's this assistant creation options here. Basically, we're going to give it a name, instructions. These are basically the system messages, and then tools that it can use. So assistants, just like in ChatGPT, can call tools. There's a few built-in ones like searching the web, doing calculations locally, and also pulling in things from the vector store. So let's go ahead and give it some tools. So here we care about the file search tool definition and the code interpreter tool definition. So basically, we're going to allow it to search the files that we've provided or will be providing, and also run code. So running code will be useful for actually calculating things we want it to calculate based on the sales data. And then we're going to finally have tool resources. So in addition to the tools, we need to provide some additional metadata to the tools to help them work best. So the file search tool needs to know what files to search. So we've created this new file search tool resources with a list of vector store IDs. And that is basically telling it which vector stores it can pull from. So we've got this vector store above. We're taking that vector store, getting its ID, and passing it in as a tool resource for the file search. So we should be good there in terms of creating the assistant options. We've given a name, instructions, tools, and additional details for its tools. So let's go ahead now and let's go ahead now and make the assistant itself. All that preamble is done. We can finally create the assistant. So what we've done here is we've created an assistant client, telling it the model to use, and we're passing in the options we defined above. Now, the way assistant works, think of an assistant as a GPT. So in ChatGPT, you have this concept of different GPTs. They might have different instructions, different tools they can call, different personalities. But every interaction with that GPT, where you send it a message and it sends you a response, and maybe you send a reply, you have this ongoing thread. So within assistants, we have threads. So here we've created the assistant, but now we need to create a thread that's attached to that assistant. So that's what we're doing here. Assistant client, that create thread. We're initializing it specifically with a message for this thread. In this case, we're asking it for a certain product that was included in this raw data above. For that product, how did it sell in February, and graph its trend over time. And that is the message we're giving the thread to run. And then let's go ahead and actually run it now. So we've created the assistant, we've created the thread, and now we need to actually run it. So you can think of this as the equivalent of the create chat completion we did above, where we are telling OpenAI, okay, given all of this stuff, given the thread we created, given the assistant we created, and given maybe some additional instructions here, for example, we want it to use puns, because of course we want it to use puns. Now we want to actually get a result. And just like before, we can have it just return the result and wait for it, or we can create a streaming result. And again, the streaming results are a lot better for usability because it helps the user understand what's going on. Sometimes these assistants can take a little bit longer to run. So streaming the results is always a good idea. So now that we've got the streaming updates collection result, let's go ahead and enumerate through it. Similar to how we did before, we're going to go through every update that it's provided and see if the update metadata says that it just started to run. We're going to print that out. We're going to see if it's a content update, and if so, we're going to write out all the text. So in theory, this should be good enough to run now. There is one thing I want to do, though. I want to clean up any usage of all these things we've created, because the assistant and the thread and the files and all those things continue to live server-side, which is probably what you want long-term. You want to call these assistants multiple times. The files will probably be up there for a long period of time. But in our example, because we're going to be wanting to make sure this runs with a blank slate every time, I'm going to go ahead and clean up all of the resources that we created server-side. And to do this, we're going to delete the thread, delete the assistant, and delete the file. So that should be good enough to run now. I'm going to go ahead and build this, make sure I don't have any silly syntax errors. And it looks like we're all good. So let's go ahead and call this assistant with chunks function and see what happens. So you'll see run started. That means we've returned a response from OpenAI saying that it's already started on the server. Now it's going through and indexing the file we gave it, chunking it, getting embeddings. It's pulling up the appropriate parts of that in order to get a result. Awesome. So here we see, let me zoom in here so you can see it a little bit better. It says that we had a significant sales increase in February, and it's got all that cool information there. It also even made a pun, I guess you could call it a pun, there at the end. So it's followed all instructions. It's intelligently pulled the data we asked it to pull, and it's given us this cool result. But wouldn't it be great if it could make graphs and other images for us? So let's go through here and see how to do that. So we might notice here that we've already asked it to graph over time. So it actually is already graphing for us. We're just not doing anything with it because we're only pulling the text from the updates. So let's pull the images from the updates as well. So let's check first if we have any images to pull. So basically, we're checking if there's an image file associated with the content update. If there is, we want to get that file because all it's done is give us a reference to it. What we need to do is actually retrieve the file from the server. We're going to get the bytes of that file. We're just storing it in binary data. And then let's write that to our local file system. Now, you don't have to write this to your file system. You could do other interesting things with it. You could send it to some other service, run OCR in it, whatever you want to do. But right now, we're just going to save it to our local file system. And then we're going to create a new process and launch that file, just basically to pull it up and see what it looks like. And that should be enough to get it going. Let me go ahead and build, and all good. So let's run this. So same as before, we're giving it the same data, chunking it the same way, asking it for the same output. But now if we receive an image, so let's visualize the trend. So it's now receiving the image, and it should pop up with an image for us in addition to the text we see. So the way it's generating those images is actually running, I believe, matplotlib in Python on the server side. And it's generating this image and sending it back to us. So that's pretty cool right there. So you can see right here, this is the sales trend it automatically generated for us automatically based on the data that we had uploaded and the command we gave it. Now, the data we uploaded is relatively simple, so it didn't really need to try that hard to find the right data. But you can imagine if we gave it a ton of different documents, a ton of different data, being able to go through and find the right subset of that to plot it is pretty powerful. And everything we've done here basically allows it to do that. So I'm going to real quick just run through one last time all the different sets of functionality here. And then hopefully you can use this to build your own assistants from. So again, we're creating the new client here. We're creating a file client because we're going to be uploading files, and an assistant client because we're going to be dealing with assistants. So each of these different parts of the OpenAI API functionality are kind of wrapped in their own client. You can think that these basically, if you go to the docs here, these more or less map to the different endpoints we have here. So going back here, we've got the document, the document that we want to upload. We're uploading it as a monthly sales file. We're then storing it in a vector store with a manual chunking strategy. We're creating an assistant. And again, this is kind of the equivalent of a GPT. So this is a definition of how a GPT chat might work. We're giving the assistant a name, system instructions, different tools it has access to, and additional information for those tools. In this case, references to the file, the vector store that the file search is allowed to use. We're then creating the assistant itself. We're creating a thread in the assistant, which for each user in the future, we'd probably make a new thread, but not a new assistant. We're giving a message for that thread. And this is probably equates to what a user might ask rather than something hard-coded. And then we're getting the results as a streaming result. We're iterating through each result. And if it's text, we're outputting it to the console. And if it's an image, we're saving it to the disk and showing it. And then at the very end here, we're cleaning up everything we've done by deleting the thread, the assistant, and the file. Although in practice, you probably would only delete the thread rather than deleting the assistant because you probably have multiple users creating new threads on top of that same assistant. But I hope this has been a pretty exciting overview of all the cool things you can do with this new official OpenAI SDK. And now I'll hand it back where we'll go over how this all fits together with Azure.
All right, thank you, Roger. That was great. And a couple of things I wanted to hammer home is that this is OpenAI's SDK for .NET, which is awesome. And we're showing off, or you showed off like the Assistance SDK, and that's some of the stuff that we've heard from the community before. It's like, I want to have access to the latest and greatest from OpenAI, and now we do. We have that, and that's mind-blowing. It's all .NET. .NET's everywhere. You started off by showing us .NET documentation on the OpenAI site. Amazing. So we are there. But everybody's wondering, Matt, you're here, you're going to talk Azure. And I'm going to tell you, you're right, I'm talking Azure. Of course, but just a little bit. And so the Azure OpenAI library for .NET uses the OpenAI library for .NET underneath the covers. So of course we have Azure, up in the Azure cloud, we have OpenAI models that you can totally consume and use. So we went ahead and we built off of the OpenAI library for .NET, the Azure OpenAI library for .NET. So what does that do? That gives you a whole bunch of like Azure goodness along with your OpenAI models that you can use. And so I'll show you like just one that's really, really cool once we get into the code of what that gives you. So how do you use it? There's super, super, super minimal code changes that you need to do. You're just swapping out the Azure OpenAI client or the OpenAI client for the Azure OpenAI client. Most of the code that Roger just showed you stays exactly the same. Really, it's super easy. So let's see it in a demo. All right, so I have everything up here. Roger and I said, all right, Roger, you're going to take the dark theme. Matt, you take the light theme. That way everybody knows what you're doing. And so what I did is I'm pretty much starting with the exact same app that Roger did, but I am going to swap in Azure OpenAI. And so the very first thing that we want to do in order to do that is that there are a couple NuGet packages that we want to put in. And real simple, it's Azure AI.OpenAI and Azure Identity. So Azure Identity is super cool, and I'll show you why we want to do that. But one thing to note is Azure AI.OpenAI, along with the OpenAI by OpenAI package, they're still marked beta, and we're scheduled to release those this Northern Hemisphere fall, Southern Hemisphere spring to wider GA usage. So they're coming, but you can still start building apps off of them, and as Roger showed you, they work pretty great. Okay, so here we are. The application looks very, very similar. We have chat streaming with tokens, assistant with chunks, but let's Azurize them. So the first thing, other than adding the NuGet packages to it, I'm going to just do using Azure.ai.OpenAI, and then I'm also going to do an Azure.ai. I'm going to do an Azure.ai. I'm going to try to spell right Azure.ai. How about just an Azure Identity? There we go. So I just did some using statements to get things in. Next up is for my chat streaming with tokens. All I need to do really is to swap out my clients. So before, we had the just using the chat client. And all we're doing is grabbing over the OpenAPI key that Roger showed us on how we would put that into the environment variables. But with over on Azure, what we want to do is using the Azure OpenAI client, new Azure OpenAI client. So we're using an Azure OpenAI client rather than just the OpenAI client. And I'm passing in a model endpoint here for the where it should go to call up in Azure to get where I deployed my model. So one thing that I do is I have deployed models in different regions and so on. So I'm just saying, hey, Azure or SDK, this is where you should go look. And here, this next part, this default Azure credential, I now no longer have to pass in an API key. I'm saying because Visual Studio's logged into me, or I'm logged into Visual Studio, and I've given myself access to the deployment of where I did my model, I'm good to go. So essentially, I'm using Entra ID, or the old Active Directory, to handle permissions. Super cool. And so that's part of the Azureizing of the Open API. And so then for my chat client equals, how about we call this Azure Client. Azure Client equals Azure Client dot get chat client. And we're going to use the GPT-4. That's it. Everything else stays the same. So it's really just the ceremony of like the initialization of where we want to call it. So let's see it run. We'll cross our fingers that things work. Chat streaming with tokens from our admin. Up, 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 make it bigger. And it's just saying, hello, how can I assist you today? So we'll just say hello, and tell us the state flower of Washington. Run it again, and it should tell us that's the coastal rhododendron. I should have been a botanist. And it's saying it's the coast rhododendron. Cool, we are up and running. So the next thing that we want to do, again, reiterate, just changed two things on the initialization, is over in the assistance with chunking, I'll comment that out, or comment that in, save things, go into here. Now, I am going to, again, comment out where it would throw an error if I don't have the Open API key in my environment variables. And see, we are newing in a Open API client. Of course, what I want is the Azure Open API client here. So Azure Open API client. And I'll call it Open AI client, just so I can not have to do a bunch of stuff. And IntelliSense, or probably GitHub Copilot helps me out. Model endpoint, new URI, default Azure credential. Cool, on my way. Everything else is the same. File client, assistant client, building up that in-memory JSON string. One thing though I want to change and is the vector store client. What I have to do here is actually use actually, it's the vector store, so let's just go back to new. So there's a minor change. Actually, this should work, I believe. Or hold on. Open AI client. Open. This one, yes, get vector store. So it's a little bit different. I just can't do a new. I want to actually do this to get it back. And so that's it. That's all I should do. And everything else is still exactly the same as we did it before. Calling in the model when we create the assistant, telling it what it should do, grab its trend, and ideally, it all works. Takes a little bit of time to warm things up because I am using a different model here than what I was using before. I was using GPT-4. Here I'm using GPT-4o. But it should start to say, are running, and then generate things for me. Run started. Then it's going to tell me and analyze everything and tell me essentially doing RAG over my data. First, it said image saved to. Roger displayed it automatically, but I wanted to save it just to probably send it to my manager to show that I actually did something. And the pun was, it appears that February was very good for sales. I never would have come up with that. So let's see where our image went to. Let's open this up. Open containing folder. We'll go to bin. We'll go to debug. We'll go to net80. Here's our file. And there we go. Looks very similar to what Roger got. Cool. All right, that's it. We have gone through now and taken all of Roger's code for the Open AI client for .NET, moved it over to Azure, and we showed that one thing, and I want to hammer that home again, is that we just used the default Azure credential. And what's cool about that is I was logged into Visual Studio, and I granted myself access to the deployment of that Open API model. And so I was able to get access to it. Now, if I would deploy something to Azure, all I would have to do is give that service that same access, and it would also be able to access it too. We wouldn't have to change the code at all. We don't care about API keys anymore, and so it makes it a little bit more secure. And that's one of the things that you get with the Azure-ness out of it. Roger, how do we do? We covered it. We covered all the greatness of the official Open AI SDK for .NET. There's so many letters, and we Azure-ize it.
Yeah, and just to kind of ram home that point again, it is really easy to go from the new OpenAI SDK to the Azure OpenAI SDK because the Azure one is built on top of the OpenAI SDK. So it's really just that authentication change, which if you're already running stuff in Azure, you should be fairly familiar with. API keys for OpenAI or Azure credentials from Azure, and the rest is basically the same. So it's pretty exciting how this is all coming together.
Yeah, super, super exciting, and it'll all be GA'd in a couple fall 2024. Northern Hemisphere, spring 2024, Southern Hemisphere. So we are very close to having it all GA'd. All right, well, thank you very much, Roger. I had a blast learning all about the OpenAI SDK for .NET, and I hope you all had fun learning about it too.
Yeah, I'd love to point out there is a migration guide online. Again, we'll share the link to that. But yeah, this is the migration guide, basically explaining what's different from the old OpenAI community library I had published in the past and the new official library. There are some changes. The new official library maps a lot more closely to the actual API, but some of the common scenarios people might have used in the past and how to update it is covered pretty well in here. So I showed you originally where there's links to the libraries, but for each of the sections where it tells you how to do different things in it, you'll notice up here there should be .NET and C# examples in there very shortly as well.
Great. Yep, everything is coming, and we will definitely put a link to an overall collection that people can check out and get links for everything that we just talked about and more. All right, thank you, Roger. I really appreciate it.
Well, thank you all.
Hi all, welcome to our session, Patterns and Practices for Automating Business Workloads. My name is Costa, working as a global black belt in Microsoft. I'm a developer at heart and helping customers with cloud-native and AI apps, but lately a lot of agentic apps. Over to Xiaoyun.
Hi, I'm Xiaoyun. So I'm a software engineer in Microsoft, and I'm currently working on the agentic application and machine learning in .NET.
Okay, let's look into our agenda for today's session. We're going to show you a few patterns and primitives that you can use to build AI applications and more specifically agentic workloads. We'll start with a quick primer on agents and intelligent systems. Then we'll go over a few scenarios we see are a good fit for agentic workloads. And lastly, we're going to describe a few patterns and practices and show you how you can add them to your existing apps. Before we dive into the specifics, let's start with a quick primer of agents and agentic systems. Let's do a little recap of where we are today when it comes to adding intelligence into our apps. You've probably heard a thing or two about the new AI models, specifically the large language models. When they came out, our first applications were mostly chatbots. They use the LLM's ability to answer questions, a very sophisticated ones, but still limited to its training data. Then we wanted to use the LLMs to ask questions on our own data, which gave birth to a pattern called RAG, or Retrieval Augmented Generation. And up to this point, we are using the LLMs to create applications that you can say are more about asking the model. And the next idea and realization we had is that we can actually use the models to ask them to do stuff for us. With the addition of function calling to the models, that became largely possible, and we were able to build copilots that help us accomplish pretty sophisticated tasks. As the copilots grew larger and more complex, we figured out we can split them into smaller agents and smaller domains and have multiple of them collaborate to achieve a task. That gave us the possibility to have more intelligent coordination, resulting in more autonomous agents. Those agents can plan, coordinate, and decide with minimal human intervention. But what do we mean when we say agents? There are a lot of definitions out there on what constitutes an agent. And in our context, we're going to say that agents are programming primitives and patterns that has their own behavior, knowledge, and context, as well as different levels of autonomy. Let's dive a bit into what that means. So behavior maps to the prompts and functions or tools that the agents can use. Knowledge maps to the specific data the agent has access to, like a dev agent knowing about the well-architected framework, or a call center agent knowing about the device manuals of a set of products. Context maps to a memory of the agent or the state of the current task of the group of agents collaborating. Different levels of autonomy means we have agents with various degree of autonomy. On one side, we have the explicit agents, where all of their decisions, plans, and orchestration is mostly done through code explicitly. And on the other end of the spectrum, we have agents that are fully autonomous and can react on changes in their environment. So they can plan, take actions, and make decisions on their own, of course, using the LLM. Truth to be told, most agents fall somewhere in the middle, where we have some aspects are explicit and some are a bit more dynamic, so they have a bit more freedom. One thing we want to point out is that agents and agentic applications are not tied to a specific framework or a library. They're more of a pattern, much like microservices. A specific case of agentic applications are so-called multi-agent workflows, where we have multiple agents collaborating on accomplishing a task. Main benefit is that we can split the responsibilities into smaller chunks and use the right tools and data for the job. While not a rule by any means, we found that mapping agents to entities from the domain-driven design world is very useful in helping modeling those agentic and existing workflows. Now that we have a better understanding of what agents are, let's look at some high-level scenarios where agent applications can be particularly applicable. So first, a scenario that comes to mind often to us as developers is creating dev agents that can help with our day-to-day tasks. Those agents can collaborate to write and test code, run it in a sandbox, produce documentation, and all that by integrating with our existing source control, CI/CD pipelines, etc. We have full control on the data we want to expose to the agents, for example, internal coding guidelines, styles, libraries, and so on. Also, we have the freedom to choose the AI models that are going to back the agents, as well as where they run, which is really important. A more conceptually interesting scenario is using agents for fulfilling high-level asks, taking the cognitive burden from the end user. Let's look at the first example. I have a party, the user asks, I have a party for 20 people tonight, both adults and kids. fill my cart with drinks and snacks. Using today's applications, the user needs to decide what and how much exactly they need by manually browsing and searching the products in the catalog, in the e-commerce site, and picking the ones they like. If we reimagine this flow to be a bit more intelligent and agentic, we can have the user still describe the high-level ask, what they want and what the requirements are, and a team of specialized agents, for example, type of drinks agent or another type of snacks agent, can collaborate to combine the user's past preferences and the current ask into a few more suggestions that the user just selects. And of course, the user can have interactions with the agents and can modify the suggestions, but the cognitive load is significantly lower. Same pattern applies for the second example, where the user wants to decorate or fill an empty living room with a tight budget. So instead of the user doing the cognitive work to try and fit different combinations of layouts and furniture, instead we can have the agents take the high-level ask and combine it with the user's preferences to offer a few suggestions. Another very useful category of scenarios is to use agents to make existing content production teams more productive. We have a couple of examples here. Let's imagine we have, the first one is we have a team of agents that are expert in different parts of the law, for example. They can help a legal team audit a case faster and with a higher quality. So they can start giving feedback based on their different specialization back to the team of legal experts, and that can significantly decrease the time it takes for the audit of the case. Another example is a team of creative agents that can help a marketing team create a campaign. So let's imagine once the member of the marketing team describes the shape and the asks of the campaign, a content writer agent can produce the copyright for the campaign, a graphical designer agent can produce the graphical content, and an auditor can flag and give feedback to the agents if the content is violating any legal or brand guidelines. So now Xiaoyun will walk you through the sample app we're going to use to demonstrate these patterns.
Here is a real-world agentic application, the eShop support. We are going to use this application as a demo to illustrate different agentic patterns in action. Let's start with an overview of this application. The system uses large model agents to assist staff employees in managing customer tickets, such as product inquiry or refund request. Now, let's look at the user interface. On the left side of the screen, you will see a customer window. This is where staff interact with customer tickets. And in the top left corner, you will notice metadata about each ticket, such as ticket name, number, and category, customer information, etc. Below that is a window showing both the summary and the conversation with customers. And moving to the right side of the screen, we have another conversation window. This is where staff can chat with our agents. In this demo, we have 3 types of agents that can respond to user requests. First, we have the manual search agent. This is a rag-based agent that can search product information from a provided document DB. And second, we have a customer support agent. This assistant helps write replies and responds to customers. And finally, there's a task planner agent. This is a React-like single-step planner that can break down complex tasks into a manageable single steps and assign the steps to another agent to execute. This agent works as an orchestrator to help other agents to coordinate and collaborate with task resolving. One of the main use cases for this eShop support is helping staff draft and resolve customer tickets with the assistance of this agent. The agent works together to search product information, reply to questions, etc., which can significantly reduce workload for staff employees, allowing them to focus more on complex, high-value tasks. In the remainder of this session, we will introduce several commonly agentic patterns and workflows using this demo as an example. This will give you a practical understanding of how this assistant agent can streamline customer support operation using different patterns. Back to you, Costa.
Thank you. So the first pattern we're going to describe and show is the RAG-based agent. This type of agent is specialized in answering questions on a particular topic or data source. The data doesn't have to be text, it can be multimodal, so audio, video, images, and so on. Where this pattern is useful is where we need different prompts to answer questions that belong to different domains, and they require retrieval of different sets of data. As an example, imagine we have a team of call center agents, each having specialized knowledge around a particular topic. One agent is able to retrieve the right data to answer questions related to products and user manuals, while another one might be able to retrieve customer invoicing data and answer questions related to that. Let's see this pattern in action.
Before diving into the demo, let's briefly overview the RAG workflow that the manual search agent will take. The workflow will begin with the user submitting a task to the manual search agent, and the manual search agent will utilize a language model to generate a query based on the given task. This query is then used to search a document DB, which houses the content of the manual. The document DB will return the most relevant chunks, which are provided to both the manual search agent and the user as the final answer. And now let's jump into demo. Can you switch the screen? Thank you. And thanks. And in this demo, we'll be using the ticket 404 as an example. And in this ticket, the user asks a question about a Luminex Latin system. And to find the answer, we can instruct the manual search agent to search for the product information directly from manual by clicking on this shortcut command, which will send a short request to the manual search agent. And the agent will first generate a query based on the provided summary, and then search a manuals using this query. The search result, which consists of raw text chunks from the menu, will be returned as a final answer. It's important to note that in this demo, the raw text chunks are returned directly without further processing by the manual search agent. Back to you, Costa.
Thank you. So the second pattern we want to show today and describe is the author-critic pattern. The basic idea is that when the author generates content, we'll have another agent give feedback on that content. So if needed, the author agent can improve it. We usually do that in a loop until the critic doesn't have any more feedback for the author, but for a limited number of iterations. We can have variations of this pattern. We can add more agents to validate different aspects of the content and improve it even, but the idea stays the same. We apply different perspectives and iterate on the content before sending it forward. If we go back to the marketing thing example we mentioned before, a content writer agent is tasked with producing the copy for the campaign, and the auditor agent can check if everything is in line from a legal and brand guidelines perspective. And if it has feedback, that will go back to the content writer, and that loop continues until either the critic is satisfied or we are running out of iterations. So let's see this pattern in action.
Here is how the author-critic pattern is applied to the eShop support demo in the customer help agent. And in this case, the critic will serve as a safeguard, ensuring that the responses generated by the customer helper agent are appropriate and are suitable for the workplace. This additional review step is important to prevent the delivery of incorrect, inappropriate, or potentially offensive replies, which could harm customer relationships or the company's reputation. And in the workflow, when the user creates a task to draft the reply, the customer helper will generate a response. And in this time, instead of sending this response directly back to the user as the answer, the drafted reply will first forward it to the critic, which is another assistant language model agent, and for review. The critic will check the content for any issues, such as inappropriate language or misleading information. And if any problems are detected, the customer helper will be invoked next to revise the answer until the response passes the critic's review and sent back to the user as a final response. Now let's jump to the demo. And we'll still use the ticket 404 as the example here. And after the manual search agent retrieve the product information, we can then invoke the author creative workflow by asking the customer reply agent to draft the response based on what manual search agent found. And we'll type in reply and hit enter. And in this workflow, we have to wait for the workflow to finish. And now it's completed. And we can see that the customer reply agent firstly generate a draft, and then the critic agent is then invoked next automatically to review the answer. And in this case, we can see that the draft response from the customer reply agent is polite, appropriate, and concise. So the critic agent approves the reply as a final answer and successfully completing the workflow. And in the next step, the staff employee will be able to click on the Use as the Reply button here to copy and paste the draft response to the customer window and use this as the final reply to your customer. Back to you, Costa.
Thank you. And the last pattern we're going to show today should be a familiar one. Just like we are assembling existing workflows in our apps today, we can define agents to react to events, invoke actions as a result, and produce their own events. We can combine them into groups and use them to assemble complex and sophisticated workflows, which integrate with existing systems and APIs. As an example, let's imagine we have a team of dev agents that can react to GitHub issues and implement a new application or change an existing one. So we start by the user describing a high-level application in a GitHub issue. Then we have a dev lead agent that will break down the implementation to subtasks, and each of those subtasks will have its own team of agents to work on it. The team could be a developer agent tasked to produce the code and an architect agent giving feedback, so we have that loop of critiquing to the developer, and then the tester agent can write tests and execute them in the container sandbox. Once the human in the loop reviews and approves the proposed code from the team, the generated code is being pushed to a PR that can be worked on and merged into a repo. Now we're going to go back to Xiaoyun to show the pattern in our sample app.
Thanks, Costa. In the previous two demos, we introduced two distinct agentic patterns, the RAG and author critic. However, in some cases, resolving a task might require combining multiple workflows into one. And in order to assemble this workflow into a cohesive process, we can use a React-like task planner to break down the task into individual steps. These steps are created one at each time, and each step will be created dynamically based on previous context. After a step is generated, it will be assigned to the appropriate agent to complete the workflow. It's very similar to how the React pattern works, where the task planner also operated in two stages for each iteration. And in the first stage, it will first observe the current context and create a single step, which includes a brief description of the current step's objective and assign it. And it will be assigned to a group of candidate agents. And in the second stage, while the task planner waits for the agent to complete the current step, and once the step is completed, the task planner will gather the result and determine if the overall task has been completed. If additional steps are needed, the task planner will generate the next step, and if the task is completed, the task planner will conclude the workflow and returns the final result to the user. Using the task planner, we can seamlessly integrate the previously demonstrated React-based and also grid patterns into a unified workflow, as shown in the PowerPoint. In this final assembled workflow, the task planner acts as an orchestrator, breaking down tasks into manageable steps and assigning them to the appropriate agents. And in this case, is the manual search agent or the customer reply agents. This workflow allowing each agent to complete its step using its respective workflow. Now let's jump into demo. So in this time, we will still use the ticket void for as an example. And this time, we're going to use Task Planner as orchestrator to complete both RAG retrieval and also critic reply in our request. To do this, we will first can send a search manual and a draft reply message to the agent window. And the Task Planner will be invoked first, creating the first step, which is to instruct the manual search agent to search for the product information. And this follows the RAG pattern. And after the manual search agent retrieves the relevant product information, it returns what it finds to the task planner and marks the first step as completed. And the task planner then analyzes the output and determine the next step. And in this case, the task planner create a next step as draft the detailed response to answer customer's question and assign the customer reply as the next agent to run this step. And here, the also critic pattern comes into play. And after the customer reply agent drafts the response, the critic agent is invoked to review the reply. And since the response this time is still polite and concise, the critic approves it and marking the also critic workflow as completed. The task planner then determines that the task has been successfully completed and marks the entire task as done. Back to you.
Thank you. So at the end, we would like to leave you with a few takeaways. So the first one is, as we've seen with the sample app, we don't really need to start from scratch. We can equip our existing apps with agents where it makes sense. Second point we would like to you to take away is agents and agentic workflows map really well to existing business workflows, and they can increase the productivity of teams. The third one is, even though the idea of more autonomy for agents seems really promising, we don't need to start there. We can start with explicit agents, and once we feel more comfortable, we can increase the level of autonomy. And lastly, we developers have a lot of experience in building event-driven systems, so that experience translates into building event-driven agents and workflows as well. Now we are going to leave you with a couple of resources that you can go to read more and explore, dive a bit deeper into how to build agents. There are example scenarios and a couple of libraries that you can use to get started with building agentic applications. And finally, we would like to thank you for your attention, and we hope you learned something interesting today. Thank you.
All right. Agents. Yeah, that makes sense. And how I can dial in a little bit more information into my prospective models that we're going to use for artificial intelligence. Listen, if you want to learn more about agents and OpenAI, Blazor, Semantic Kernel, all the topics that we've had throughout the day today, make sure you check out the collection at aka.ms/.NET/FocusAI/collection. You can take a picture of that QR code. This session, all of the other content is recorded. It's going to be available on YouTube. Make sure you check out the playlist. Our folks are working behind the scenes, putting together a YouTube playlist. It'll be available at the conclusion of the event so that you can go back, rewind, and learn more. But you know what? I think it's time for us to stretch. Get up, take a few minutes, take a break, go for a walk, go get something to eat. Nature might be calling. Make sure you take a break for yourself, and I'll see you back here in a few minutes as we get ready for our next sessions. Did you refresh your beverage? Do you have a nice cup of water there ready to go? Because we've got tons more content for you here as part of .NET Conf Focus on AI. Now, we wouldn't be here if it wasn't for some of our great sponsors that have been helping get the word out. Make sure you check out some of these folks who have been helping present this event. They do a phenomenal job for us, and we want to thank them by checking out their websites, letting them know that we appreciate the work that they've done in helping out with .NET Conf Focus on AI. All right, coming up next, we've got Davide joining us to talk about RAG with your data in .NET and Azure SQL Server. Maybe you don't like relational data and you want to go with something just a little bit different. That's fine. We've got James joining us from Cosmos DB to talk about building generative AI apps with Cosmos DB. Davide, the stage is yours.
Hey, hi everyone. I'm Davide Mauri, a Principal Product Manager of Azure SQL. And today, actually right now, I'm going to talk to you about how to do RAG, Retrieval Augmented Generation, on your data using .NET, AI, and Azure SQL. So let's get into it right away. So first of all, for those who doesn't know about Azure SQL yet, probably just a few, but just for those few, let's recap what Azure SQL is. Azure SQL is the enterprise AI database. It is a modern relational database with full true multi-model support, means that you can store JSON, graph data, even XML if you start using it, geospatial, column store, and query all these things together. It's scalable up to 100 terabytes. You can have up to 80 vCore, 30 replicas, so it can really sustain any kind of workload you can throw at it. And of course, we are working on adding vector support. Vector support is in early adopter preview. You can see the link on the slide where you can just go and submit your request to enter the private preview. And the private preview is exactly what I'm going to use today to build the RAG solution. Not because you can't without it, but with the new vector support that we are adding, you will have just a much easier way to build a complex solution that today are kind of common in our complex world. There are other cool stuff that Azure SQL offer to developers, not to mention, of course, enterprise-grade solution, so you don't have to worry about security. We take care of it. Everything is encrypted. You can encrypt column. You can even encrypt the data flowing between the SQL Server or Azure SQL and your application, such in a way that no one except the receiver can decrypt the data. And of course, as a developer, you probably want to connect with Azure services like Azure Function that we will be using today, static web apps that we will be using today, or any other services, Stream Analytics, Fabric, Power BI, and of course that is absolutely easy with Azure SQL. And as a developer, again, you probably want to use the common libraries that everyone uses today, from .NET EF Core to Semantic Kernel to LangChain or any other libraries that you want to use. And again, Azure SQL is integrated with those libraries, so you can just have a great experience no matter what you want to use. Now, the other thing that I want to discuss before moving into the demo is what are the use cases for having AI into Azure SQL, right? So why you want to move AI to your data instead the other way around? Well, the first and most common use case that even today I'm attending and actually speaking at another conference at the same time we are recording this session. Again, all customers come to me and ask, I have this very common situation. I have my data in Azure SQL or SQL Server, and I would like to add the vector search because I would like to be able to filter by, let's say you are insurance company and you have all your data already in SQL, so you want to find all the contracts that are related to a specific person or created by a specific employee, and within those contracts you want to chat with your data, ask a question in natural language, like for example, find all the documents from Acme customer written by John Doe that are related to the new security policies they need to apply. You can do that in SQL because you will have the author of the document, the tag that you use to tag the document, and all other information already stored in your database in some column or some document in JSON format that you stored in SQL. So adding vector capabilities and then AI support into the database is the natural choice for us and then for you to use, because that will just make your life easier, because you will add vector support and semantic search to the queries that you already need to run in order to filter out the data that are specific to a customer or something else. That's the most common use case, what we call a hybrid search, where you mix vector or semantic search with full text, maybe you're already using, and then with the regular filters. Then, of course, the other use case is to store chatbot memories. For example, we have released an integration with Semantic Kernel that allows you to build a chatbot and store the memories in Azure SQL, so that you can then analyze them, find what is the most common question, for example, a problem that is arising from your customers chatting with your chatbot. And of course, the other very common kind of use case is RAG, Retrieval Augmented Generation, which is exactly what I'm going to show you right now. This is actually also the most complex pattern, so that's why I prepared a little bit of a high-level architecture and a high-level design. So retrieval augmented generation is a sequence of steps, actually two, that you have to do so that you can take the data that is stored in your database, filter it using semantic search and thus vector search. So let's say, for example, I have a database that contains all the sessions of a conference. And let's say that I want to filter all these sessions based on some topic or some day that I want to go and attend to the conference. But then I also want to ask to an AI model, out of the sessions that are available today, what are the sessions that are about SQL and AI? And I want to do it in a natural language. And I want to get the answer in a natural language. So the first part is where I do the hybrid filtering and the vector search. So I limit out of the hundreds of thousands of sessions that I have available in my database, I only limit the scope to the ones that are related to the question I'm doing, like today. The session must be today. And then once I filter that, and I also make sure that I filtered only the sessions that are somehow related to the topic I express the interest into, like, for example, SQL and AI or security or anything, then I take those sessions and I send them to the AI model, like a ChatGPT model, a GPT model, and then ask it to evaluate the question in the natural language and return to me the answer in natural language. So the first step is similarity search. That's why we need the vector search. And the second step is sending to the AI model the result of the first step and explaining the AI model using prompt engineering what it needs to do with the data I'm providing him so that he can provide me the answer I need. So that's what we need to build. And that's what we are doing, and we are doing it with the aid of some Azure services. For example, we are using Azure Function because the moment someone writes a new or updates a new abstract or a title of a session in my SQL database, I need to immediately be able to be notified about the fact that the session has been added or updated, so that I can calculate the embeddings, get the vectors that are representing my my topic or my session, and store them back into SQL, because all the AI model, all the AI world works on vectors and embeddings. So we need to convert our text into those vectors and embeddings. And again, here I'm using an Azure function that will be automatically triggered by Azure SQL as soon as a new title or a title has been updated or the abstract has been updated. Then we will be using, of course, Azure OpenAI, because my function will take the text that has been updated in my database and send it to OpenAI so that it can be converted into a vector and then stored back in SQL. And then in SQL, I have a storage procedure in this case that I want to use to search for all the sessions that are in a specific day or related to a specific topic. And once I have that function, that storage procedure ready, I want to expose it so that it can be used by my front end. And since I'm building a full stack application, and specifically a Jamstack application, my front end is only able to communicate with my back end using JSON and REST API. And unfortunately, my storage procedure is just in SQL. The problem I have to solve right now is that how do I expose that storage procedure, but it could be a table or a view, as a REST endpoint, or maybe even a GraphQL endpoint, where typically I would have to create the service and code everything by myself. But luckily today we have something called Data API Builder that allows my database to be exposed as a REST endpoint or a GraphQL endpoint just in a second using a configuration file, and that's it. And the beauty of Data API Builder is not only that it's open source and available for free, both on premises and in Azure, but in Azure is also integrated with static web apps. So if I'm creating a static web apps, I don't even have to worry about deploying Data API Builder and configuring it to connect my database. It will just happen automatically as part of my static web app solution. And that's exactly what we are going to use. And then, of course, my front end in this case is just a React front end. Will just communicate with my backend, my static web apps backend. Using REST queries, REST calls, and JSON. So that's the application we are going to build. All this solution is something you can actually use right now and deploy right now in Azure because it's fully available on GitHub. It supports AZD, so you can just easily do AZD app and everything deployed for you. So you can try it out on yourself. You don't need to use Azure if you don't have a subscription because everything also works locally, and that's exactly what I will be doing today. So you can even try it without having to use Azure if you don't have it. The only exception would be for Azure SQL because the private preview we are running, where you can use vectors as types and vector function in SQL, is only available in Azure SQL at the moment. So you need to use Azure SQL, but luckily for you, there is a free tier for Azure SQL. It's completely free, forever free, that you can use, so you can really try out the example without having to worry about costs or money. Now, before going to the demo, let me show you how it works, and you can actually try it on yourself right away, because this website that I built for another conference where I was invited to talk, I was allowed to also to keep it running, so I can use it as a kind of a reference architecture. And here, let's say I want to learn about a session on security. And what I want to do, I already loaded my database with a session of that conference. Maybe I want to ask, is there any session on security? And even if I misspell it, thanks to the fact that the data is being converted into an embedding and a vector, and then semantic search is done in Azure SQL using vector search, and then everything is sent to the AI model, the AI model is still able to understand my query, or in this case, my question, even if I didn't spell everything right. And yes, there is a session on security. The session is titled How to Build Secure and blah, blah, blah. You can read it for yourself, and you can see we have all the data here. Now imagine doing that on your own data. So the example I'm going to show you right now is, of course, we don't have the full day here, so I'm going to show you the important part of the architecture, so you can take the architecture and change it to run on your own data. So let's dive into the example, starting from the GitHub repository that you can reach out from the little GitHub icon here. So that's the repository, and that you can clone, and that's of course what I already done on my machine. And this is the full structure of my example. Let's start from, well, the database. You have all the script here. I already deployed. The interesting part I want to show you is that tables are super simple. We have the session table, and we are going to store the embeddings and thus the vectors directly into SQL for now as a binary object. And then we have the speaker table. And of course, here also we have the embedding and the vector associated to the speakers. And then we have a very simple relationship table that connects the session to the speaker who are delivering the session. It's a many-to-many relationship, so we need this associative table. That's it. Just 3 tables, nothing complex. The only additional stuff is the ability to store embeddings right into Azure SQL. And once I will have at some point the embedding in my table, and I show you how, then I want to find a session, right? I want to find a session that is about SQL and security. So I have a T-store procedure that will take my text, will call OpenAI using this get embedding store procedure that again you have available. You can see how it is done, but it's very, very easy. It's just calling OpenAI through SP invoke external REST endpoint, which is a store procedure that allows you to call an external REST endpoint, for example, OpenAI. And then it will convert this text into an embedding, which is needed to do vector search. Then we'll take our vector that is stored in a binary format, and then we can calculate the distance between our vector that represents the topic I'm interested in, and I can compare its distance to the old embeddings already stored in my database that represents the session that I have in my conference. I will take the session that are closer the topic I'm interested in, and then I will return the result to my query, to my user. And this is a store procedure, so that's it. That's the only thing I need to do. since I have data API builder that will help me to make this story procedure a REST endpoint without writing code, but just by configuring it. And before going to how to expose this REST endpoint, let's play with this data a little bit. Right now, my database is completely empty, right? So the first thing I want to do is to add some data and make sure that my data will be automatically converted into an embedding, because you will see that here I have some sample data here. You will see that here I'm just adding my text. I'm not really worrying about adding a vector. A vector is a very long sequence of numbers that I will not be able to type in here. I need an AI model to generate it for me. So I need an AI model to take this content and turn it into a vector. So in order to do that, I have a function here. This function is using something called a SQL trigger. That means that as soon as there is a change in the web sessions table, this function will be fired, and we will get information on which row were changed or inserted or deleted. And then we can basically take this I read-only list of rows, and in this case, I'm writing a LINQ query so that I can take the title of the changed or updated row or inserted row, the abstract, create one payload, and then ask it to be processed for changes, which means in this case, I am just calling get embedding async on my OpenAI client. So I'm using the OpenAI SDK to call OpenAI and get the embeddings of my text. And then I'm saving back the embeddings that I get into my database. Let me show you how the function works behind the scene, and I just need to start static web apps because I'm using static web apps. So I have the front end and the function already. So let's just do start. This will start the function, will start the API builder for me. And as soon as the function is started, it will be monitoring my database for changes. And so I will be adding some sample data, and it will, as soon as I will add the session, it will be sent to OpenAI and converted to an embedding. So it just will take a few seconds to start, and then as soon as, here we go, we have the trigger ready. So what I can do right now is, let's just make sure that everything is ready here. It should be. So let me just go on and add the speaker, the session, and the connection between speaker and session. And that's it. And now here you will see that, yep, the processing is starting. So the function detected there is something to be changed, there's something to be processed, is connecting to OpenAI, getting the embedding. And then this means that I can, as soon as this is done, I can go back to my table, and I will see that even if I didn't add any embedding here, when I query my session or speakers table, yeah, you see, I have an embedding. Now I have the vector, and of course, vector is saved in a binary format, so I can do vector search using the function vector distance that we just added to Azure SQL in private preview to find the closest session to some topic. So let me add another session. And so also this will go through the entire process of getting the embeddings, and you will see here that again there is something new detected. So it's connecting to OpenAI, getting the embedding, and in just a few seconds my session is converted to a vector. Now that my session is converted to a vector, I can go to the local website that has been created for me, localhost 4280, and this is the application I am running locally. So my cool conference RAG sample. If I click on about, it automatically recognizes there are two sessions indexed. Why it automatically recognizes there are two sessions indexed? Because if I open Data API Builder behind the scene, that is again running automatically because it's integrated with the static web apps, you see, for example, that I have my database is exposed, and I decided to expose the session table, for example, as a GraphQL and REST endpoint. So it's very easy for my front-end application to query the table or to query my database just using regular REST and GraphQL actions. For example, I can have a GraphQL query, or I can just execute the story procedure using the find endpoint. Okay, so this is all free for me because I have static web apps with Data API Builder integration, which means I can just focus on my front end, my website. I don't need this, so I can just go back to. And now, for example, I can ask some question like, is there any session to learn how to use AI on my own data? So what is happening here is that my this is interesting. So this is hallucinating a little bit this time, but basically it will be using all the data that I have in my database and basically running the query and returning to me the answer based on the data that I have in my database. And how this is happening is because this ask button here is actually going to this specific function. Here we go, chat handler, where I am doing a couple of interesting things. And here you can see the RAG pattern at work. Here I am, first of all, retrieving the similar session. So I'm executing, in this case, directly the web find session. So it's easier for this demo to show what's happening. And I'm getting the result of find session based on the topic I'm searching for, like security. And then I'm getting the result of the query. And I'm sending it to my AI model, basically concatenating the result by taking the title, the abstract, the speaker, and separating them by a pipe. Why am I doing this? Because I'm doing some prompt engineering, and I'm saying to my AI model, hey, look, you are a system assistant who helps user to find the right session to watch from the conference. And how do you know which sessions are available in the conference? Well, because I'm providing them to you in this format. So I'm providing the instruction on how the model should behave. I'm providing a list of the session to the AI model using this format. And then, of course, I'm also providing the query that the user typed. So the model has the information on how it should behave, the context, and the question from the user, and it can actually answer us by telling us what are the sessions that are about some interesting stuff. So let's go to the demo. AI. Here we go. So here I can say, for example, another question could be: is there any session by Davide, for example? And it will be able to scan the session, doing vector search using this query, this text, and then here we go. Then it will get the session after we scan the database for similarity search, and then the AI model will actually understand the question and answer us in natural language. This is all coming from the AI model. So with these steps, you can really easily have a static web app function. Here is the client. I'm not going into the client because it's just a regular React client and not super interesting. I would say the most interesting part is that, for example, thanks to the fact the database is exposed as a REST endpoint, as I showed before, calling the storage procedure from the front end is as easy as doing a simple actually post using the fetch command in JavaScript. So that is what makes Data API Builder super nice, because it takes your database and exposes it as a REST endpoint. So it means I can easily use it from JavaScript or TypeScript without having to worry about drivers and anything. And how do I expose the storage procedure? That's the last thing I want to show you. It's using this SWA DB connection folder. When you configure static web apps to use Data API Builder, you need to have this configuration file that will be created for you. And here you just specify that you want your storage procedure, not this one, but this one, your storage procedure to be exposed at the /find subpath. So anything that will be routed to Data API Builder, and this is something that automatically happens in static web apps. And that's why here you see, if I go back to the client, you see that I'm in the /Data API Builder, because that that data API, because that is how Static Apps knows that it has to route this question to the data API builder. And then REST and find, because we are using the REST endpoint, and find because that is where my stored procedure has been published. So this is super easy. I can have my stored procedure published as an endpoint, and then I can just focus on the front end. So front end, as I was saying, is in the client folder, is all React. Then the database in the database folder, the function that takes care of getting the title and the abstract and monitoring the table and turning them into embeddings is in the session processor. The chat handler is where you actually are doing the RAG pattern. So you basically, first of all, retrieve the similar session here, explain how the model should behave with this system message, and then get the result after adding the user prompt so that you can actually basically send the data to the AI model and get the result and send it back as a JSON payload that can be consumed by the front end. And then the last part is SWA-DB connection, where you actually configure the database to be a REST and GraphQL endpoint. That's it. That's how you build Static Web Apps, RAG solution with Static Web Apps and SQL. And if you are interested in using vector search in Azure SQL right away, there is in here, this is the this is the website you have to go in order to be able to request to be part of the early adopter preview. And as you saw, we are adding the ability to store vector in binary format, but most importantly, you have the option to calculate the distance between vector, which is the clue of doing similarity search, using this new feature called vector distance that allows you to calculate distance between two vectors using cosine, Euclidean, or dot product, which are the most common way to calculate distance between vectors. With that said, my recommendation is to go to the website, to the GitHub repository, download it, run on your machine, understand how the architecture is done. Everything is well explained here, again, with all the details that you need to do, and then start to run it on your machine, and then add your data and see where you can go from there. You will see a lot of interesting options and a lot of fun. Thanks a lot for listening. See you next time.
Hey everyone, today we're going to talk about building generative AI apps with your own data stored in Azure Cosmos DB. I'm James Cadella. I'm a product manager in Azure Cosmos DB, working on all of our AI features. So let's get into it. So we all know that Azure Cosmos DB is the world's most scalable AI database, right? We have a serverless model that allows you to start really cost effectively, but we also have a provisioned throughput model that allows you to take advantage of things like our auto scale capability. Cosmos DB features automatic sharding and partitioning of your data, so you don't have to worry about if your data scales to very large sizes. We take care of that sharding for you automatically. Cosmos DB also features high elasticity with instant auto scale. So Cosmos DB scales out as your demand increases, and then scales back in as your demand decreases. It features low latency with real-time data transactions, under 10 millisecond latency for point reads and writes. We have high availability where you can maintain reliability of 5 nines, which is really world-leading, world-class. It also offers 5 levels of multi-tenancy built into the database, everything from logical separation of your tenants or users at a logical partition level, all the way up to separate containers and databases and resources as well. More recently, we've developed built-in vector indexing and search capabilities in Azure Cosmos DB, which we'll talk about more in depth and see a demo today. And this features Disk-ANN, which is a new state-of-the-art suite of algorithms developed by Microsoft Research and implemented for the first time in a Microsoft product that you can use yourself. So before we get into the demos, let's talk a little bit about common AI scenarios with Azure Cosmos DB for NoSQL. First is chat history, right? So if you're building a chatbot or using a large language model to build an intelligent agent, you might want to keep track of the chat history between your users and your AI models. You can do this for multiple reasons, and we'll get into that in a little bit, but we have thousands of customers doing this today with Azure Cosmos DB. Next is RAG, or Retrieval Augmented Generation. So this is all about taking the most relevant data from your database and using it to ground or personalize a large language model or a small language model in order for it to really become contextually aware to your scenario and to your data. Next, we have thousands of customers building multi-tenant apps in Cosmos DB. I talked about how multi-tenancy is built into Azure Cosmos DB, and so a lot of customers take advantage of that today in a AI-based scenario. We also have customers building real-time recommendation systems, anomaly detection systems, and multi-agent AI systems as well. These are really exciting things that our customers are developing and continuing to push to production. And of course, we have multiple customers building all these sort of AI applications on Cosmos DB. Maybe most prominently is OpenAI that uses Azure Cosmos DB as the chat history store for ChatGPT. So your conversations that you have with ChatGPT are actually stored in Azure Cosmos DB because of its really low latency for its point reads and for its queries, as well as its scalability. So lots of excitement around Azure Cosmos DB for AI apps and a lot of use cases as well. We'll dig into a couple of the top 3 ones here: chat history, RAG, and multi-tenant apps. So with that in mind, let's talk about some of the use cases for Azure Cosmos DB in Gen AI scenarios. First is we have the idea of a vector and operational database, right? So I mentioned that we recently have vector indexing and search in Azure Cosmos DB. So this is really exciting, right? It gives you the opportunity to store your operational data and your vector data together in one data store in one data item, right? This is really exciting. So it removes the need to ETL your vector data from a database to a dedicated vector database, right? You can store your vectors and your data together in one data source in one data item. This allows you to have highly consistent data and reduces the complexity and costs of your AI application infrastructure. Built on top of this vector and operational data store, we can do things like retrieval augmented generation, right? So bringing the most relevant data from your database to ground your large language or small language models. This allows you to personalize your models on your data. It's cheaper than fine tuning and allows you to quickly iterate on new scenarios, right? And you can do this today in Azure Cosmos DB thanks to our new vector search capabilities, which we'll talk about in a little bit. Additionally, chat history, right? So I mentioned that thousands of customers are doing this today in Cosmos DB, and they're doing this for multiple reasons, right? One is to maintain conversational context. So you want your chatbot or your intelligent agent to remember what was talked about in a previous session or previous day or even last week. But you can also do some mining on the chat history data to identify, where does your large language model perform well, and maybe where does it need a little bit of help? Maybe need some fine tuning, maybe need some prompt engineering or some other improvements as well. Also, chat history is used quite often for auditing, right? If you ever call the customer support line, you may hear this call is recorded for quality purposes. We do this for human-to-human interactions, so it only makes sense that we might want to do this for human and AI interactions as well, right? And then there's this notion of something called semantic caching, right? So the idea of semantic caching is I'm already storing chat history in Cosmos DB. So maybe I can actually take advantage of that in my chat scenario, right? So imagine that I have my chat history consists of a user question and then a response from my large language model. So if I've seen a question, if I see a question multiple times, maybe I can leverage a historical response from my large language model that I'm storing in my database and use that instead of making a call to my large language model API, right? So the idea is I will take the user question and vectorize it, create a vector embedding of it. And then when I see a user question, a new user question, I could run a vector similarity search in my database on all my historical data. And if I've seen a very similar question before, I can actually take the historical example historical response that I've saved in my database from a large language model previously and surface that to the user instead, right? So the idea is that this could save you cost because oftentimes calling a large language model, like a GPT-4 model, can be very expensive. And also it has high latency, right? It takes sometimes multiple seconds to get a response from a large language model, whereas executing a vector search in Cosmos DB, can take tens or hundreds of milliseconds. So really, really fast, and really, really nice feature here. So here's some of the common use cases for generative AI apps using Azure Cosmos DB. So I mentioned that we launched a couple new vector indexing and search capabilities in Cosmos DB for NoSQL. Primarily, we have these three areas, right? So native vector indexing and search in public preview. So what I mean by native vector indexing and search is that this is actually part of the core database engine itself. It's not a separate service that sits outside the database. It's not as another thing that you need to provision, right? It's just part of the Cosmos DB engine and database that you get, and you can store along. You can store your vectors alongside your original data. Next, we announced a DiskANN-based vector index. So DiskANN is an advanced vector index that allows you to do highly scalable, efficient, and cost-effective vector search at any scale. And we have this in gated preview today. Next, we launched some AI framework integrations with Semantic Kernel and 9chain, and there's more integrations to come. Let's talk a little bit real quickly about Cosmos DB for NoSQL with this DiskANN-based index. So the idea behind DiskANN is actually relatively simple. So you start with your vector embeddings, and you insert them into your Cosmos DB database. What we do on the back end is we take your vectors and we put it through a compression method called quantization. The compression method then scopes down the size of these vectors to be more efficient to store in RAM. The full uncompressed vectors, along with the graph data structure of DiskANN, is then stored to high-speed SSDs that make up the backbone of Azure Cosmos DB. This interaction between the during search between the compressed vectors that are stored in RAM and the uncompressed vectors that are stored on SSD allow the DiskANN index to scale to huge sizes very efficiently, right? So we use very little computational resources and RAM, because RAM is actually quite a lot more expensive than SSDs. And then we leverage the scale out architecture of Cosmos DB and the high-speed SSDs to store the full vectors and graph there. And DiskANN, as I mentioned, is a state-of-the-art suite of vector indexing algorithms developed at Microsoft Research, and we're bringing it to you for the first time in a Microsoft product. And you can take advantage of everything that Cosmos DB is built on, right? The unlimited scale, low latency, and DiskANN itself is robust to data changes, and it works with both our serverless model and our provision throughput model. So we're really excited about the potential for high scale, high efficiency, high accuracy search with Azure Cosmos DB and DiskANN. All right, so I talked a lot already. Let's get into some demos, right? So what we're going to do today is I'm going to walk through some code on building an assistant powered by your data in Azure Cosmos DB. So we're going to build a highly scalable, multi-tenant generative AI chat app using Azure Cosmos DB for NoSQL. We'll implement a RAG pattern using vector search in Azure Cosmos DB for NoSQL on your data. And we're going to be using Azure Cosmos DB for primarily three things. One is to manage chat history. Two is to store and retrieve data for RAG with vector search. And three is the semantic cache that we had talked about as well. And so we're going to do this. There's a great GitHub repository I'll show you in a minute that has a great template that you can use. So we'll store things in Azure Cosmos DB here. We'll leverage Azure App Service to deploy our application. And then we'll also leverage the Azure OpenAI service. And we'll do this for creating our vector embeddings and for generating our completions or our responses from large language models. All right, cool. So let me switch over here. So this is the GitHub repository that we have. I have some links at the end of this presentation, so you can feel free to hold off, or you can just go and check it out right now. So this is the demo that we're going to walk through, right? So we're going to be building this essentially like a co-pilot-like service here with Azure Cosmos DB. We're going to walk through everything that we had talked about, right? How to build a highly scalable, multi-tenant, and multi-user generative AI application using Azure Cosmos DB for NoSQL. Works basically with these main components that we talked about. And then it also has a really nice user experience. So it's built in using Blazor. So we're going to deploy this Blazor app so you can just access it through the web. And you'll be able to ask some questions about this imaginary bike store, the CosmicWorks bike store. In this example here, it's asking some general trivia questions, but we'll be able to ask other questions that are specific to data that we're storing in Cosmos DB. So let's take a look. All right, So when I deploy this Azure, and actually let me go back a minute here. This is actually really easy to get started, right? It walks you through the prerequisites of what you need, how to sign up for the vector search preview, how to configure your Azure OpenAI resource, etc. And then there's instructions how to get started really easily, right? You can use AZD to initialize and download the code from GitHub. You can log into AZD and then do AZD up and deploy the resources, and they'll be all connected for you in Azure. So really, really easy way to get started with this demo quickly. And once you do that, it will deploy a resource group for you. So here's my sample resource group here. And then I can see all my resources that are deployed here, right? So I'm using Azure Cosmos DB here. I have my Azure OpenAI resource here. I have my app service plan here. I have my managed identity here. So I have I'm maintaining my keys here. So this is really secure. And this is a great example of how to build a secure application. And then I'm using Azure App Service to actually orchestrate my application and actually run my Blazor app. Right, and this looks like this. Here's my app. Here's my web app here, and I can actually go ahead and browse this web app. Right, so let me click on this, and here I see this web interface. Right, so let me actually zoom in here a little bit so it's a little bit more legible. There we go. So I don't have any chats in here. Right, so we'll create a new chat session here. Let's go ahead and do that. Create new chat session. Cool. So maybe we'll say something like, "Hello, my name is James. Can you tell me about bikes that you have?" So I just submitted my prompt to Azure OpenAI, and it orchestrated everything, right? So I submitted my prompt, it looked at some chat history. I have no chat history, so I wasn't able to pull anything, but it sent it to Azure OpenAI to generate a completion based on the parameters that we set for our chatbot. So this says, "Hello, James, I don't sell bikes, but I can provide more information about different types of bikes." And it's giving me some information about different types of bikes. So then maybe I can say, "I live in New York City. Can you recommend some bikes that might be good for my commute?" And let's see what it comes up with. Cool. And it says, certainly, for commuting in New York City, you want a bike that's durable, right? And so it recommends some bikes. And it's able to understand that, I live in a city and I want to commute because it's, creating vector embeddings from my prompts, from my message to the large language model. And then, it executes a vector search in Azure Cosmos DB to find the bikes and to find the products that are most relevant to my question. So this is, really cool, really powerful stuff. And I can see that I've created a multi-tenant app here because I can actually create a new chat session. And in this chat session, it's completely brand new. It has no idea what my name is, right? So I could say, "Hello, what's my name?" And it doesn't know my name. It doesn't have access to my personal information, right? So this session information that I just started in this new chat is completely separate, completely isolated from this bike recommendation session here. And I can continue going on here, tell me more about electric bikes. Oops, electric bikes. There we go. And now it gives me a summary of electric bikes and why I might want to use these, right? So some of the information is from the vector search that was returned by Azure Cosmos DB, and some of it is returned just from the knowledge in the large language model itself. Now watch this. If I copy and paste a prompt that I've already entered, right? So let me enter this in again. I live in New York City. Can you recommend some bikes for my commute? Cool. So did you see how fast that was? That was near instant, right? So what we can see here is when I asked this question originally, I live in New York City. Can you recommend some bikes that might be good for my commute? We stored this in Azure Cosmos DB. We stored my question and the vectorization of the vector embeddings that represent my question. And we stored the response from the large language model in Azure Cosmos DB. So when I asked another question, we first ran a vector search on the data in Azure Cosmos DB, on the chat history, and try to see, was this question asked previously? And since we already logged it in Cosmos DB, we were able to find this question again and surface the information that the chatbot already gave me earlier, right? We're able to leverage this historical information. And we can see in our token counter up here that returning this returning this piece of information from the database actually cost 0 tokens, right? We didn't actually have to call our large language model at all. All we did was execute a vector search and return the last or the most relevant response from the large language model that we've captured historically. So this is an example of a semantic cache, right? It saves me money because I didn't have to call the large language model, and executing a vector search is very cheap. It also saves me latency. As we could see, the response from the assistant was near instant. So really powerful stuff. Go ahead and take a look at the GitHub repository and play around with this. But let's go ahead and look at the code real quickly, and we can see what's going on behind the scenes. Cool. Okay, so let's get started here. So I have my Visual Studio set up here. And here's basically what the Solution Explorer looks like for all these services, right? I have a bunch of different folders, a bunch of different files. We'll go through a couple of the main files here, right? So in the main sort of root directory, I have this azure.yaml file. And this basically just contains all the connection info for my Azure resources, right? My OpenAI endpoints. I'm using Semantic Kernel here to orchestrate the calls to my embedding model in Azure OpenAI and my completion model or my GPT model. And then I have my Cosmos DB endpoint information and some of my chat parameters. So these are all going to be environment variables, right, that I can set in my web app. So it makes it really easy to customize and personalize these things once it gets deployed. In the main program itself, this is basically going to build the program for me and build all the services for me. So we're going to make sure that we build my resources. We're going to make sure that we register my Azure Cosmos DB service, that we create the database and the containers for managing my chat history and my semantic cache and all my product data as well. And also all my orchestration, even my orchestration of creating a new semantic kernel service is going to be stored here in the program.cs file. Next, we have an OpenAI services CS file. And this is going to walk through all the connections and interactions with my Azure OpenAI services. So you can see that actually I'm defining some strings here for my completion or my GPT model and my embedding model. But I'm also going to define things like my system prompts, right? So my instructions that I give to the large language model such that it knows how to behave and knows how to respond to my scenario. Right, so this is sort of a general system prompt here. You know, you're an AI assistant. Please provide polite answers. But then we can see that I also have this system prompt retail assistant here. You know, you're an intelligent assistant for the Cosmic Works Bike Company, and this is the one that I just used. Right, I want to make this retail assistant personalized to my specific retail shop, so I can give that information here as well. So this OpenAI services contains all the information and all the endpoint information, and even things like my parameters for my large language models here. And you can go and take a look. This is really a great example of how you might want to configure these resources in your own application. And then, of course, we have a helper function here for getting the vector embeddings, right? So if I ask a question and I want to do a vector similarity search and find the products in my database that are most similar to my question, I have to create a vector embedding of my question. I can do that using the Azure OpenAI service. And this code shows you a nice helper function of how to do that. Next, we have a Cosmos DB services.cs file. And so this is really great because this sort of orchestrates all of the operations that I would want to perform in Azure Cosmos DB. Right, everything from getting the database and chat container and cache container and product containers, my product information. So this basically orchestrates connections to all the containers or collections in Cosmos DB. This also orchestrates loading of the product. So in this GitHub repository, we have some sample data that you can automatically load into Cosmos DB. It actually does that for you. That contains product information and vector embeddings. So this function, load product data async, will do that for you. There's also other information as well, like defining a partition key. So we're going to use a partition key builder class here in order to build a partition key that's based on tenant ID, user ID, and session ID. So if you recall, back here in our chatbot, right, in our chat application, we have these different sessions here. So I can maintain session isolation. So what I'm talking about in one chat session doesn't influence the other chat session. But I also have like these different users as well that I can focus on, right? So I have some examples here that are all all PMs on the Cosmos DB team, Mark, James, me, our friends Sandeep and Saji. So you can experiment with just not only different chat sessions, but even like, look at this, different users, right? I just switched users here. So this is James. I was in a Mark user before. And now I see there's no chats available because I didn't start a chat as James, right? But if I go back to Mark, I can see the sessions that it created under the Mark user. So this is really cool, really powerful, right? I'm using Azure Cosmos DB's partition key to have logical separation between my, not just my, my sessions, but my users as well. So really cool stuff, and there's some examples here of how to get started. Now we can also see some other helper functions too that help me get some partition key information or get session information. There's an example query here for how to get the most recent messages from a session. And then we can even see an example if we scroll down far enough. Here's an example of a vector search in Cosmos DB, right? So this is just a query. It's actually a query with a subquery. And I'm just selecting, my top results, and I'm projecting a couple different pieces of information about my data, maybe a category name and SKU and name and description of products. And then I'm executing a vector search, right? So I'm using this vector distance system function, and I'm basically doing a vector similarity search between my vectors and my query vector, right? So s.vectors would be the vector representation of my products. And this at vectors is just a parameterization of my query vector, right? So if I say, hey, tell me about bikes that are useful for me, I live in New York City, we're going to vectorize that and pass it through here as that parameter. That's what that at vectors is. So you can see a nice example here of executing a vector search in Azure Cosmos DB NoSQL, which is really, really easy and straightforward. Next, we have a chat services.cs file. And again, this just orchestrates the different interactions between the database and Semantic Kernel and your Azure OpenAI service, right? So your orchestration of, hey, I want to make sure I get all the chat messages from this session. And I want to make sure that I'm getting the most recent chat session information to feed it to the large language model for contextual awareness. And then this get cache async is a search to the semantic cache, right? So we can actually look at this. I go peek at definition. I can see here that this is actually running the get cache async here. And what this is doing is essentially it's running a vector similarity search on all my cached conversations. So all the questions I've asked or all the prompts I've sent to as a user to the large language model and all the responses from the large language model. So this leverages the semantic cache, and we'll see if there's any results in the semantic cache. We'll see if my question or my prompt has been asked before or given before to the model. And if it hasn't, the response is going to be empty. And so then I'll cache this response, and then I'll return the chat message. So this gives you a really nice comprehensive walkthrough of maintaining session information and user ID information between each session, leveraging the semantic cache in Azure Cosmos DB, doing a vector similarity search amongst all my product data stored in Azure Cosmos DB, and then feeding all of that to the large language model in order for it to generate a response that's personalized on my data, it's personalized to my user's question. And then, of course, I have a semantic kernel service file here that basically just orchestrates everything that we saw using semantic kernel. So basically generating the embeddings and generating the completions from Azure OpenAI. So that's about it for the code, right? There's some other files in here for configurations. You're more than welcome to go through and clone the repository and walk through it yourself. The last thing I'll show you is what this looks like in Azure Cosmos DB itself. So let me close this so I can just start from scratch here. So what I have here is I have, this is my resource, my Cosmos DB resource that got deployed from my AZD up command. So this is the one that gets provisioned and loaded with data in Azure Cosmos DB, just using that this Copilot demo code that we've provided for you. So I can see that it's instantiated as Cosmos Copilot DB database, and I can see I have multiple different collections here. If I take a look at the products catalog, I can go to items, and I can see that there's a bunch of different items from my bike store here, right? I can see an ID, a category name, a description. So this is like a seat or a saddle. I can see a price associated with it. And if I scroll down, I can see the vectors, right? So these are vector embeddings that are created using one of the Azure OpenAI embedding models. And they're just, it's just a list or an array of floating point numbers, right? So this can be stored as just another property in Azure Cosmos DB, right? And this is part of the value prop that we're talking about here. I don't need to store my vectors in a dedicated vector database somewhere else, right? I don't need to maintain another service. I can store everything in Cosmos DB, and I can have my vectors just as another property of my data items. So this is really, really powerful stuff here. And as I go through some examples, I can see other items as well. Like here's a bicycle, it's a touring bike, and I can see the vectors here as well. I can see other collections or containers that were created for me as well, right? So I can see, here's my chat container. So this is all of the chat history, right? So I can see that I've created a session using this mark character, and I can see, right? So remember at the beginning where I entered in, hello, my name is James. Can you recommend me? Can you tell me about some bikes that you have? Here's that prompt. We're storing this info in Cosmos DB. All the code to do it is in the GitHub repository. And we can see, the completion. This is what the large language model, this is what my OpenAI GPT model responded to me. And I can see some other statistics here about usage. So cool, like I can see my chat history. I can even see the semantic cache information that's stored in the cache container, right? So I can see what that looks like. So I can see that for this ID that's associated with, that chat history item, I can see the vector embeddings that describe it. So this is basically for the, for the chat history that I have. I can see the relevant information and the vectors that represent that, right? So I can see, so here's an example of the vectors. This is the item. When I said I live in New York City, can you recommend some bikes that are good for my commute? And this is what the large language model responded. I'm storing this in Cosmos DB. So if I see this question again in my chat app, I can just do a vector search on this vector and the user's prompt, find this information because I've already asked the question before, and then just leverage this, right? If we go back to the chat app, we can see, certainly for community in New York City, this is exactly what was responded here, right? So we're just pulling that from Cosmos DB and leveraging what we've already seen. So we've walked through a couple of great things here today. We talked a little bit about Azure Cosmos DB. We talked a little bit about some of our vector search scenarios and capabilities in Azure Cosmos DB. And then finally, we walked through a GitHub repository that has information and some code to get you started with this example. So before we leave today, I'll offer you a couple of resources, the next step links that you can get started with. The first is to learn more about Azure Cosmos DB for NoSQL vector search with this overview page and our documentation. The next is if you want to use our DiskANN advanced, highly scalable, highly efficient vector index, you can go ahead and sign up for the gated preview following this link. Next, we have our announcement blog post where you can get even more information about Azure Cosmos DB and DiskANN. Finally, you can check out this link for our Cosmos AI samples repository. This contains a link to all of the Azure Cosmos DB AI samples that our product team has created, and it can get you started in .NET. We even have some Python examples for those of you who might be inclined to take a look at that. And then finally, if you want to take a look at today's demo, you can follow this final link down here, aka.ms/cosmosdb-nosql-copilot, and you can get started really easily. So that's it for today. Thanks for joining me to learn more about Azure Cosmos DB and our AI capabilities.
All right. I feel like I got my database filled there between SQL Server and Cosmos DB. Really cool stuff. Thank you so much, Davide and James. Now, I've got some more content coming up for you. I've got 2 more sessions, but I want to make sure that you know about our event survey so that you can let us know what you think of today's event. Head on over to aka.ms/.NETFocusAI/evaluation. Not just about the event, but what you think about using AI with your .NET apps. Click through that link, take a picture of that QR code, and it'll get you on board so that you can join us talking about what we can do to improve our next event and what we can do with AI in .NET. Now, There's a whole lot of things going on there. I want to make sure that you have opportunities to learn more. So we have an AI challenge and some live streams coming up over the next month. We've got a bunch of hosts set up, aka.ms/.NET/Focus AI/credential challenge live. Right on through September 20th, there's content available. There's some challenges. There's some tasks for you to check out. And we've got live stream hosts throughout the month that are going to be talking about all the great things that you can do with artificial intelligence and .NET. Okay? And of course, today's event is being recorded. It's on YouTube. We've got some folks behind the scenes. Our editing team are at it. They're putting together a playlist for you that'll be released at the end of the day today so that you can go back and review and share some of the great things that you've learned, some of the things that you've enjoyed with your colleagues, with your friends, so that you can all do so much more with .NET and artificial intelligence. Now, coming up, I've got 2 more sessions for you. Our first session is going to be from Tim Span, who's going to talk about integrating semantic search capabilities with .NET and Azure using Milvus. That's a vector database that you can use to work with your artificial intelligence data. After that, we've got a session coming in from somebody who's actually building and using some of these technologies. They've deployed and they've got an application running out there in the public. This is going to be Vin Kamet joining us from H&R Block, talking about some lessons learned building and deploying generative AI tech using .NET and Azure. All right, Tim, the stage is yours.
Hi, Timothy Span here. Today I'm going to be talking about the Milvus vector database, integrating semantic search capabilities with .NET and Azure. I'm Tim Span. I'm the principal developer advocate at Zillows. We are the people behind the open source Milvus database. Today, we're going to talk pretty quickly about a couple of things related to vector databases and how you can use them with .NET and Azure, and a little background around that and some insights around this. First off, let's get introduced to, why would you use a vector database? Obviously, there's a ton of different places to store your data, ton of different databases. What's special about vector databases? Why would I want to use one? Well, in today's world, obviously there's a ton of data. There's also even more of that is unstructured data. And unstructured data is the new type of data that you see a lot in AI, images, video, text, audio, data that's not created by a computer. It's usually created by people, and it's just data that's a little different from the traditional data sources. And there's obviously a lot of them. Now, vector databases were created to work with this type of data. So they really work well with that. They're not designed for traditional relational data or other data that you're used to, and that's why they came about. What made it possible, though? Well, the reason why we could do vector databases now and not, say, 20 years ago is a number of innovations that have come about very recently. Some of them are the massive storage of documents, images, all the things we have on the internet, video, ton of these different data sources. And then the thing that really drove it that we can make these vector databases is the ability to create vectors. And that requires deep learning models. And a lot of these are very recent in the last couple of years that let us be able to create large vectors of data. Now, this is just really a big array of data, like massive arrays of numbers. And it's the type of data that you don't want to look at as a person, but AI models love this type of data. And it also works out to be a really good storage format for all of these unstructured data types, images, video, text, what have you. Fortunately, there are modern vector databases that run in Azure and in your other environments, and that's Milvus. Milvus is an open source project that's been around for a number of years. Some of the benefits of it are it's really easy to set up. Code is nice because I can write it once, and wherever you need to run it, you can run it. Integrated with all the different tools, systems, platforms, other databases, data stores, all the different projects that you might want to use, things like LangChain, Llama Index, all those are supported. All the features you need, dense embedding, sparse, filtering, re-ranking, all the things that you may be reading about for vector search, for vector databases, that's all in there. There's a lot of users of it. It's been around for a while. It has a large number of people working on the source code in the open source, and it's part of the Linux Foundation for AI and Data, which means that there's a community of people working on it, and we're all working on this together. Now, what might you want to use Milvus for? Now, it's been designed to store, index, query, all these vector data, for any kind of unstructured data at an enormous scale. And it has features like advanced filtering, hybrid search, so you could search on a vector plus something else, maybe search on an image plus a description of it, or some other fields you might have related to date or time, whatever other kind of more structured fields that you might add to your vector there. It is very durable. It has backups, all the features you expect to have in an enterprise database, replication, high availability, the ability for data to be sharded among different servers, being able to aggregate data, full life cycle management, the standard create, replace, update, delete, all that is supported. Support for multi-tenancy, so you can run in Azure in a cloud environment with a lot of users, a lot of different people querying, adding data, being able to do massive amounts of queries. Because if you're going to hook this up to, say, a system for AI chat, there could be a ton of users out there. Being able to insert and delete massive amounts of data, getting the full precision and recall that you need, and support for all the advanced hardware that we see out there, things that accelerate it, like different GPUs, like from NVIDIA, FPGAs, custom hardware that may be in your Azure environment, and being able to scale up to billions for as much as you need to store, which is important as you start looking at the number of images, video, text data, whether it's little chat or documents. Quickly, those go into the millions and more. So it'd be nice if we just had that. Milvus would be great. But as we've come through the years, a lot of people have enhanced the open source to add things that make it more robust, flexible, to fit almost all the use cases and all the different types of data. Because there isn't one size fits all. There's a lot of different indexes out there for vector search, and we support a lot of them. Right now, it's over 15, and this is things that if you're looking up about vector databases, you'll see them, things like binary, sparse, disk-based ones, GPU-based indexes, ones that run in RAM, ones that run on different type of analytics of the data. Lots of options there. This lets you optimize how you want to search and balance things off, like cost versus performance, being able to tune how accurate the thing with unstructured data when you're searching it. You could set a percentage of accuracy that you want for your matching. And then how you're going to search. There's a lot of different ways to search vector data, and we support the majority of them, whether you're doing the top K number of returns, a range, you want sparse or dense, or you want to search across multiple vectors at once, you want to group data together, do you want to use the metadata and extra fields that are in the collection to filter them down? You might have two of the exact image, but they have different metadata, so you want to be able to return just those. Being able to have, like we mentioned before, multi-tenancy, so multiple users, multiple applications, maybe multiple companies, being able to go through the same collections at the same time, but with things partitioned for security, for efficiency, just for keeping your data separate if you're different groups. And with all the different hardware out there, as we've seen in Azure, you got a lot of choices when you're picking what you're putting out for your platform. We support almost all the ones that will improve the speed and the power of the vector search, whether it's quantization, cache-aware optimization, GPUs, which we know they're great for a lot of things. This speeds up your queries, speeds up the inserts, reduce your costs, makes things more scalable, and all that flexibility is there. And again, this is all open source. So there's always the ability for more things to be added by different groups out there. Now, we could search across a lot of different unstructured data, and this leads to a lot of cool different use cases. The most common one, and this one pops up a lot, especially you're working with the different LLMs out there, is having retrieval augmented generation, so you can get the exact data you need to be able to optimize your prompts, get back what you want, tell the model exactly what it should be searching for by looking at, say, a list of documents relevant to your question. What's nice is Milvus is extremely fast, so I do my search for wherever I need to find, semantically get those results back, and then very quickly be able to get that to the language model. That is a really important use case. Doing recommender systems, these are very common. You don't need to have AI for this. Just being able to match things semantically against your different data sources is pretty cool. Just searching text, you might just you have a huge amount of documents stored and you just want to find things and find the right context and the right meaning of things. Is apple a fruit? Is it software? What is it? That's important, and that's part of what Milvus has. Being able to find images that are similar. For me, I'm always searching for cats that look like my cats. You could do the same with video, do the same with audio. I'm trying to find someone that has a voice that sounds like me. I'm probably going to find a lot of people from New Jersey. That's pretty cool. I've seen this one recently, a lot of research in finding different types of molecules by able to spin a molecule, get it to the way you want, and use that to search. Pretty helpful when you're doing research on new medications. Pretty powerful stuff there. Being able to find anomalies. If things are supposed to be similar and they're not, you can find things that are wrong. And this can be lots of different data points, whether it's logs, images, lots of ways to find out if there's faults in equipment or in different systems out there. This one is pretty cool, being able to search multiple types of data at the same time. So I can have an image, a video, audio, text, search it one way and get results back. What's cool with vector is I could take however you want to search. I could use a keyword. I could use text string. I could send in an image. I could upload a video and say, hey, find stuff that matches this video, or speak and have it match that, or put a combination, multimodal. I could have an image of something and a little description like, here's a cat, and go, give me cats like this, but they're wearing a hat. Pretty cool stuff like that. Obviously, more enterprise things you could do as well, but lots of fun stuff. So Milvus is cool. The great thing is you could use it in the environment you want and use it with the tools that you already know. So fortunately, with the help of Microsoft engineers, we've built out a powerful .NET SDK in C#, and it's about as easy as you could possibly be for you to use it. You just use the standard .NET, add the package, and you're ready to go. There'll be a new version of this in a few weeks, but this one will work with all the modern Milvus versions out there. Make sure you're using at least Milvus version 2 and greater. We always like to use the latest one, as there's always new features, patches, enhancements, speed improvements, And you could click and get that library right away and start using it for your applications. There's also a semantic kernel connector. I know a lot of people are using this pretty awesome framework for a lot of AI applications. And fortunately, there's a connector there as well. Again, new versions of that coming soon. You could quickly use those as well. Pick whichever one you want to work with. They both have advantages. Try them both, see which one fits your .NET application better. We have an example, and I'll show you a little demo once we get through the slides, keep all that together. And the code is pretty simple. You know, you connect your client to your host. Now, this can be running local. This can be running in a cluster. This can be running through Zilla's, which has a marketplace in Azure, and I'll show you that. And you'll have, the ability to turn on SSL. We also have a token you could pass in, again, multi-levels of security. Now, we check to make sure that we're able to connect. Then you could easily do a search. Pretty standard, depending on what types of data you want to get back and what data you're going to pass in. Pretty easy to set this stuff. And this is all well documented with online documentation that we'll share with you. So once you've built your app, well, you probably should have Milvus close to where your app is running. If you're running your .NET app on Azure, then you probably should be running Milvus there as well. Now, Milvus has a couple different ways to run on Azure, as you might expect. One, if you're, run your own environments, you really like to do Kubernetes, Milvus has great support for Kubernetes. You could use AKS out there, just using the standard tools you might expect. We've got all the Helm charts and all the things there. And there's good documentation on using the Kubernetes service to host and run Milvus. Milvus is a full enterprise architected application. It has multiple layers that can be expanded out to make sure that you index, search, query your data at scale. So if you need to scale up individual portions to meet needs, like if you have more data storage, or if you have more indexing, or you have more clients that are running queries, you can enhance all those different layers depending on your need for whatever use cases you have, which can vary and can vary at different times. Maybe at busy times when you have a lot of images coming in, you might have to increase the number of indexing, or you might have to increase storage. All that can be done very easily on Azure on Kubernetes. All right, now it makes sense to deploy Milvus on Azure. And if you are someone who runs an enterprise environment, you're probably running Kubernetes already, and AKS is probably the best way to do that. So fortunately, Milvus uses all the standard stuff to run on Kubernetes. You just use the standard tools that you expect, the Azure CLI, Kube Control, and Helm. All the Helm charts and Kubernetes materials are available in the open source, so it's pretty easy to run this, and it's fully documented. And there's also documentation on the Azure site. So pretty easy for you to run an environment this way. This makes it really good for being able to spin up things quickly, being able to expand. This is important with Milvus, as it is a distributed application with a full enterprise architecture. So it has things like proxies, it has different indexing elements. It is separated compute and storage. So there's a lot of different things that you could expand based on what needs it. Like, do you have more storage? Are you running more indexing? Do you have a lot of people querying? And you can expand those sections or bring them down to save costs as needed as different parts of the environment. Now, if you're not into doing that, you don't want to run this yourself, fortunately, Milvus is on the Azure Marketplace. You just go there, pick Zilla's Cloud, get it now, a couple of clicks, you get a full cloud environment, fully managed. You don't have to do a hell of a lot of work. This is a great way to do this. Very simple, very easy to subscribe to the Azure Marketplace and have a full managed environment in a very cost-effective manner. Now we have a short video example of that. No audio on that, so I'll show you that while it's running. And then we'll do some demos later, but pretty straightforward. So what you have here is when you've gone to the marketplace, you're going to pick how you want to deploy this, and we dedicated this on Azure. And by default, we do Virginia is the most common. And as you can see, pretty inexpensive, depending on how many cloud units you have. You'll have your environment, cluster will be created, pretty straightforward. You know, you get your credentials and then anyone could log in. What's nice is it's really simple. It puts you right into the IDE to start working. And we will show this demo next up, and you'll be able to see a little bit more about that. So again, there's different ways you can run this. Now, if you're a developer or someone learning, you could just run this on your laptop within Docker or local Kubernetes, pretty straightforward. There's also a small standalone version that doesn't require much environment at all. So it's very simple to just start figuring out how to build your collections, what the fields are, how to do searches. Great way to learn things and try things out. Now, as an infrastructure out there, there's a ton of things with large language models. It's more than just, I need, a vector database. I need all the different frameworks out there, which could be Semantic Kernel or LangChain or Llama Index. I need different embedding models. PyTorch has some, Hugging Face, Cohere, OpenAI, ton of different options there. And you can work with all the major LLMs. There's just a couple examples, but there's connectivity to almost all of them, whether it's OpenAI or any of these other ones, run on Intel and NVIDIA hardware, and obviously install on Azure without too much difficulty. Some of the main things to see here is the open source for the community for Milvus is very important. We've got a lot of people come together to make sure this works well, is well documented. You can learn it pretty easy, and it's not the heavy lift there. Lots of different use cases, and none of them require the same things. They're not all exactly the same. You're going to require different indexes, different types of searches. What's cool is you can run your Milvus cluster right on Azure. And if you don't want to do it yourself, you could just use the marketplace. It's a pretty good idea to keep your vector database close to where you're going to run your Gen AI and LLMs, which makes sense. You do it all on Azure. And scalability is going to be important for these apps because once people use them, once people like them, it is going to expand greatly. Before you know it, almost instantly, you're going to have a couple of users and there's more. Then all of a sudden you're like, oh, I need to be able to scale out to, terabytes of data, hundreds of users. That's a good problem to have, but you need something that'll handle that. And it's pretty awesome. What's nice is if you don't want to run anything yet, but you still want to give it a try, click this URL, just go to Milvus Demos, and you can run a demo on top of Milvus. And this one's pretty cool is you upload your own image, and as soon as it uploads, it does a search on that and gives you a bunch of results back. So you get to run your own demo without having to set up Milvus, and it's linked to the source code. So when you're ready to try this on your own, you can just download it and get it started. So that's a really cool one. I like that one. The GitHub is there if you want to look at the source code. If you need help, we have a pretty cool Discord channel where we answer questions. We also have an AI bot in there that'll try to answer your questions, but it's not as good as the engineers and the users that we have in there, but gives you a couple of options if you're asking something that's very common or maybe a little different. Thanks for coming to the .NET conference on AI, but let's get into some demos. First off, I want to show you that source code we did. Now I'm in just visual code here, and it's as simple as we showed you. We connect to our client. Here is where it's going to be different. You're probably going to have a much longer link here to get to the host, different port. You're going to have SSL on. You're probably going to have a token for your security. I'm running in a local Docker environment on one of my machines off to the left here, just as that's a good way for demos, so the demo gods don't come after us and take away our cloud, or someone forgets to put their credit card in. It kind of happens in demos. So we do our connection, which very easy to swap that out for different environments, different security methods. Then for this one, we're taking a look if there's a collection. If we have it, we're going to drop it. We want to rebuild it, do this one fresh. So you get a fresh demo here. So we just load the data that we have. We create our collection. What's nice with .NET, we do that asynchronously. Then we'll just iterate through it and print a couple things out. Pretty simple. Now, if we want to build and run it, again, super fast here. It is already built. Not much going on there, and we already ran it. Now we could see the results of this. I have what's called Attu, which is an open source tool to look at the data. You want to be able to see it once it's been loaded. And that was that collection you saw there, the books. And, it's pretty, we got to load it first. Let's make sure we have it loaded. Once you have it loaded, you can look at the data, get it going, and do a search, browse the data, whichever makes sense for you. What's nice is you could also filter it based on different fields. Like if you have caption here, which is text, you could just filter on a part of it. Again, you could look under the covers, see how many partitions there are, look at segments. If that's of interest to you, probably not. You're more interested in what's your real data there, just to give you an idea. Now, if we're running this environment in Azure through the marketplace, we're using the Zilla's Cloud to do that. And very easy to get to your different environments and see all the different collections created. Like here, I have one for travel advisories, and we could see different fields here. This one is a more balanced one. We also have ones where there's image data. So we could look at, just do a little quick preview of that. And you could see all the fields here. Obviously, looking at the vectors, it's a bunch of floats, not too interesting. But for searching, really important that you could do that quickly. Now, if we needed to create a more advanced environment, I could create a new one on Azure, optimize it for capacity, make sure I have backups, figure out my backups, make sure I'm paying people, and then create my cluster. And then I'll have one running on Azure at scale like I have here in the small. What's nice is it's very easy to use this and do whatever you need to do here. Also, if I needed to add new data, it gives me APIs to do that, and also this handy UI. So pretty straightforward to run these things. It is not a difficult or heavy lift here. Hi, and if you like what you see with Milvus and you want to learn more, we have a unstructured data meetup that runs in different locations around the world. And also we stream it to YouTube and to other places later. So you can watch it at your leisure if you can't be in person, but you could still ask questions. We make sure everyone who speaks provides slides and their source code, whether it's a notebook or code, makes it very easy. And you could just click and get right there. I run the one in New York City. We've got another great one in Berlin and another one in San Francisco. And again, recorded for you later, available for everyone. And we talk about things in unstructured data, vector databases, Milvus, LLMs. We get a ton of people from different startups and from different companies come out. It is a great time. On the East Coast, we usually run at Microsoft Reactor, and on the West Coast, we're usually at GitHub. Definitely come out. It's a fun time. We get some pizza, and we go over some really cool technology. Fun time. And then finally, give you an opportunity to either run it on your desktop in like a Docker or standalone, or when you're ready to be in an enterprise environment, run Zilla's cloud, just grab it from the Azure Marketplace, or just spin it up yourself with AKS. Very easy to get started with vector databases. It's been a great time speaking with you. I'm Timothy Span, Principal Developer Advocate at Zilla's, covering the Milvus open source database. Thanks for attending my talk.
Hey everyone, my name is Vin Kamath. I'm a principal architect working for H&R Block. And today we're going to talk about lessons learned from applying generative AI apps with .NET and Azure. Here is the agenda. We're going to talk about tech stack and architecture first, show you a little bit of demo with AI taxes that we built and launched this past season, benefits and shortcomings, RAG challenges, evaluations, AI agent. So there is another demo that I'm going to do, a simple AI agentic chat demo using Semantic Kernel and .NET. Model deployment options, some really key insights and takeaways during our journey for generative AI so far. And then I have some questions that I'll share with you that we usually ask to do some use case discovery process. All right, I do want to start with a key message that I want to share is that this is a great opportunity for .NET developers. And here are the reasons. Generative AI models have made AI accessible to app dev engineers. In the past, it was very hard to have an app dev engineer think about and learn machine learning and all of that stuff. Now that it's just an HTTP call, it's become a lot easier to play around with this, and especially things like Semantic Kernel SDKs and Azure OpenAI SDKs. All these make our job as developers and engineers make it more productive. We all have learned over the years to build, deploy, launch, and scale apps. And this is no different. Building an AI-enabled app is no different than any other app. There are a few things that you have to pick up as part of the skills, such as prompt engineering and orchestration. But end of the day, you're still building an app. You still have to scale it and serve your customers. One thing unique about this is this AI wave is faster and it's accelerating. As we see every day, it's hard to catch up, but it's also more accessible. If you compare it with like mobile, cloud, DevOps, and platform engineering waves, this one is very different and also is very impactful for enterprises and businesses. I would still say, though, based on experience, that 80% is still app and data engineering work compared to what the AI model is doing. Of course, it's going to bring huge gains to your users and customers, but think of it like one more tool in your stack. So I'll quickly talk about what we did this past year. So we delivered two sets of capabilities, one for our customers, the AI tax assist, which I'll demo here in a bit. And then on the other side, we also built some things for internal associates and employees. We were one of the first ones, as far as I'm aware, that we built a ChatGPT app for associates, and we built it on using Blazor, .NET Stack, and Azure OpenAI. And this was a huge opportunity for the employees to kind of, understand how generative AI works, learn a little bit of prompting, use it in their day-to-day lives before Copilot became available to all of us. We also did a whole bunch of experiments with RAG and agentic apps, and we are still continuing to do that. We went with a simple approach. We took an experience that was lookup-based to a AI-infused human-like experience where the assistant can answer your questions. And this is a common pattern for any AI assistant or Copilot, but I did want to demo it. I'm going to start this video here. All right, let's see a quick demo of H&R Block Online's AI Tax Assist. So we used to have this help, and you can ask questions like, what is EV credit limits? And you get a bunch of responses, and you have to go through, figure out which one. In this case, it might be this one. Instead, with AI, you can get human-like responses to your questions, augmented by H&R Block's expert knowledge base that is developed to specifically answer some of these questions. You can see there are some ready-made prompts here to get you started. I'll go ahead and ask my first prompt. What is the income limit for EV tax credit? It talks about the limits that we have for 2023. I can also ask something like, my AGI is $60,000. Does EV credit apply to me? So now you can see, based on your AGI of 60,000, you may be eligible for EV tax credit with the same additional information. So this is a good example of how you can augment your existing help with a human-like AI assistant experience. There are other capabilities, like you can go back to history and download the chat, or go back to a question that you had asked last week, or you can start a new chat. I do want to talk about the technology stack that we used. It's no different than standard stack that you would use. We use .NET Web APIs, Azure Functions, SignalR, like I said, Semantic Kernel and the OpenAI SDK, Cosmos DB, Azure Storage. We also used Blazor app and .NET to build a test harness that we can run evaluations on the AI responses. We also used Presidio SDK, which is a Python library to do PII anonymization. From the infrastructure side, nothing new there. If you are on Azure, you kind of know these stacks, but we used Azure OpenAI Service, App Gateway, App Service Environment, Cosmos DB, so on and so forth. The architecture looks pretty simple. Not a whole lot going on. On the right side of the dotted line, you've got the build time or design time ingestion process. You have multiple content data sources. You ingest them and do pre-processing, put them in blob storage, then have the Azure AI Search create a vector index on that content, and then ready to go when runtime request comes in production. Over here on the core application UI side, as the user query comes in, goes through App Gateway, and then we have a web API where we have semantic kernel, on-demand, in-memory records, query and retrieval, persistence, and telemetry. We use App Insight, Cosmos DB, and SignalR here. Like I said, we use the Presidio for the PII anonymization. And this is where we have the HTTP calls happening to OpenAI GPT models and ADA models to embed the user query. So if we first embed the user query, then we do the retrieval, then we do the generation. So fairly simple architecture here, not a whole lot going on. But as we discover and evolve this pattern, we are thinking that there's going to be more and more components that you're going to add to this blue box right here. Now, I'll talk about some benefits and shortcomings of simple RAG implementation. It's very easy to get started, right? It's fast, easy. Prototypes can be built in a matter of hours or days. The big benefit here is that you can augment the LLM with your domain-specific knowledge base, which is huge because otherwise you'll have to spend a whole bunch of time and money on fine-tuning or other types of capabilities with AI engineering. But here you just don't have to do that. If you have a knowledge base, you can turn them into embeddings, put them in Azure AI Search, run those vector embeddings. All of that is a huge benefit to get something going quickly, fast. However, there's a whole bunch of shortcomings that we are still working on and discovering. And nothing is perfect by any means. Like you use any RAG-based application, there are always shortcomings. So guardrails and accuracy and high quality of response is a very important thing to focus on early on. So your journey to V1 is kind of long drawn out. If you don't have the background or experience, it becomes hard to deliver something within your timeline, at the same time learn and evolve and improve. So you have to kind of plan for it. And then you may also find that in your first attempt, you may find that users are not really that happy with some of the quality of the responses. So you have to put in a lot of work in evaluation, and you only increase complexity and make the quality better only when you're ready for it, and if you have gone through all that process. I do want to share some RAG challenges and strategies. These are fairly common. First one is, you have a search, it retrieves the content from your vector index, but it's not relevant to the query. This could happen. And here are some solution strategies that we have come up with. And it depends on what kind of knowledge base you have. So it's not always necessary that the solution that I'm sharing here will apply to your knowledge base. So it depends on a lot of things like chunking strategy and quality of your content and data. I'm just sharing what worked for us, right? So search is not retrieving content we know to be relevant to user query. So this is another critical one. So we are running the retrieval, but we are not getting content that has to be there, but we are not getting it, right? So now, you can ask a whole bunch of questions. Do we have the content? Is it relevant? We have to add it. Are there any metadata filters or fields that are missing that are important for the vector index to be added? Maybe you should try larger chunk sizes. So there are these strategies that you have to try and evaluate. And each time you try them, you have to run them through the evaluation pipeline. And I'll talk about some of the evaluation metrics that we used. Another very curious problem is jumbled up and mishmash of response. You send multiple passages, like let's say top 5 results from the retrieval, and you may find that sometimes the LLM is returning a mishmash of responses from something from the first passage, something from the third passage. So you feel like it's not giving you the high quality response. So this is where prompt engineering comes in. You have to prompt the LLM to only use the relevant passages. Maybe it can use its foundational knowledge and the context to determine maybe, the third passage is more relevant than the 5th passage. Things like that. You may want to add additional metadata to your vector index. So there is a lot of things that you can do. And this is just the highlights. There's a whole bunch of new novel RAG strategies that are out there that, may improve your quality. The last one is kind of obvious, and it is like anytime there is a follow-up query, like you don't want to run the retrieval, right, every time. So there are strategies like doing intent detection first before you trigger the final LLM call, or you can reform the query itself to produce better retrieval results. Talking about evaluations, there is something very important you have to consider, and that is, what is the mix of using LLMs and other models to evaluate your AI responses or humans? Like you have to kind of figure out the balance between them. What worked for us is we obviously use automated evaluation pipelines that use LLMs to kind of score based on all these metrics. But we also do human eval using sampling techniques. And those sampling techniques can vary depending on which area of your knowledge corpus where you have to put more effort on, which category. Maybe it's product specific questions that you want to put more effort on, or there may be areas of, in our case, domain specific tax knowledge, right? So you have to find a balance and kind of, have to figure out a way to do both. Doing only one cannot scale, obviously. So automating the LLM evaluation pipeline is a huge task that you have to start thinking about early on. And there are 2 options here. One is to use the Azure AI Studio. There is prompt flow and evaluation flows which are available, great capabilities that you can use. And I see that as time passes, more and more varieties of metrics are being added. Like recently, I believe F1 scores are added, recall, precision, things that originally were not available. Or you can build your own. In our case, we started the journey very early last year. So we started building our own tool set. We are working on evaluating Azure AI Studio to figure out how it can augment and complement some of these evaluation runs. Groundedness is a very common when you have a RAG solution. It basically checks how grounded your AI response is based on the context you provide after the retrieval. Coherence, relevance are self-explanatory. Helpfulness is another metric that we discovered or played around with ourselves. This is basically looking at your AI response from user lens. This is not about how grounded the response is. It's more about, is it helping the user? Which means you have to provide additional context to the LLM about who the user is, what are they expecting, what are the requirements from a product standpoint, whole bunch of other instructions to the LLM that says, I'm now going to evaluate your response to make sure that it's helpful, or at least it appears to be helpful for the user. So this is a very new to me too, but it's something that we are experimenting with and find benefit from. Key point evaluation is another one that our data science and engineering team came up with, where you simply have a bullet list of items that you want to evaluate. So it's not like you have an actual English language text, but you actually extract key points from that expected response or answer, and then you evaluate against those key points. This can improve the accuracy of your evaluation method. So that's a new way to look at it. And again, this is something that we are constantly evolving and learning. I encourage you to try both Azure AI Studio and build your own, and then figure out what works best. All right, here is a quick demo of agentic group chat using Semantic Kernel. So let me switch to Visual Studio. What this app does is it accepts a receipt or a document. Right now, in this case, it's a donation, so it looks like this. So I donated to charity, $1,200. I want to be able to upload it and have the agentic group chat tell me whether I can, discard this receipt or I need to keep it based on a tax impact analysis. Again, I'll warn you that this is not real, right? I've created a sample just to explain the concepts here. I have two agents, a tax impact analyzer, so prompt looks like this, and a reviewer. So the tax impact analyzer analyzes the document first using the latest GPT-4o model. And then the reviewer looks at it and makes determination. It also asks a question, a follow-up question before it can provide a recommendation. So we start off with loading up API keys and whatnot, the kernel using the GPT-4o. So when you add Azure OpenAI chat completion, you have to provide the model name, endpoint, and API key. You set up the execution settings, load up the prompt, and there are many ways to load up the prompt. This is not the right way, but for the purposes of demo, I tried to take shortcuts. Here is a new chat completion agent capability that's currently experimental, but I expect a version of this to be made available in the final version of Semantic Kernel. But it works great. I've tested this. So here is the definition of what the agent does, and then you can provide the instructions that you grabbed from the prompt. Same thing happens with the tax impact reviewer. It's very important to give them names and descriptions here, although you might have additional information in your system prompts. And then you go ahead and start a group chat. The key thing to note here is this termination strategy. So I created a recommendation termination strategy where I decide who is the agent who needs to terminate the conversation and how many iterations or turns it needs to take. So if I look at this termination strategy, it's a simple strategy. You may have more complex strategies, but all I'm doing here is checking for the phrase I recommend. So once I see that the tax impact reviewer has reached a point where it's saying I recommend, that means the job is done. So that is what I'm looking for, that terminates this process, and I can then provide that recommendation to the user. So here is a simple while loop. I initiate a chat history and then go ahead and upload the image. So I have a console app, so I'm going to type in the path of the file. I add a message. So here is a user prompt. It's always important to add a user prompt. although it might seem that all I have to do is upload an image, it provides a little bit of additional context to the LLM. And then I go ahead and say group chat and invoke async. When I do that, I get a response, and then deciding on whether to show the response to the user is up to us. So in this case, I'm checking, and making slight modifications where I say, if it's reviewer, make it bold. If not, act like it's a log, right? So that we see. So I'm going to run this sample here, keep or discard. So my file is in data, donations, image. And here we go. So the first step is tax impact analyzer is providing the analysis. So it determined that it's 1,200 from an organization called Share and Care. All that looks good. And then the tax impact reviewer took that and decided to ask this question. Now, notice how tax impact analyzer is also providing some commentary in the background, but we've decided to kind of use it as some kind of log. So in this case, I'm going to say, yes, that is a charitable organization, 501c3. And then tax impact reviewer comes back and says, I recommend keeping this document. So this is a very simple example, but I expect in a business scenario, you can figure out how you can chain multiple processes and interactions and specializations of AI agents using Semantic Kernel and .NET, and basically build these capabilities that are high business value. All right, so let me switch back to presentation. Real quick, I do want to talk about the model deployment option. So when you deploy model in Azure OpenAI, you have two options. You start with standard. That's how we started. You take measurements. You figure out based on usage how many calls are required, TPM, things like that. You have to take a swag when you first time developing an application. Use the capacity calculator tool in Azure OpenAI Studio, or you can use Excel if you want. You can test it with like lowest PDUs possible, maybe 50 in load environment, and then gradually increase as you need it. In production, find the benchmark workload to optimize PTUs. So this is really important. So once you launch, you may discover that your PTU needs to be increased or decreased. That's something to keep a close eye watch on, and then always use a fallback standard deployment for resiliency. So if something happens to the production model, you always have another production model that's in the standard deployment mode, so that you don't have cost associated with it and you only pay as you go. I have a bunch of lessons learned here. Not going to drain the slide, but a couple of key things here. Pick a leading model and stick to it. There is a lot of news out there that there's always some new model coming out. It's very important to improve your solution as it relates to your business, rather than always worrying about which model is better. Things like continuous improvement of evaluation pipelines is also very, very important. But the first one is also a mindset that you have to start thinking about is this is not chatbot V2. If you are building AI assistant or copilots, that is, you have to think them like, they are human-like assistant. So if it were human, would they respond in the same way as the AI assistant is responding? That's something to think about. Few more insights here. One of the new ones that I've highlighted here is quality of outcomes is more important than response times. If quality of responses is not great, then it doesn't matter it's built with AI or not. You have to make sure that even if it takes a longer time. So let's say instead of taking 10 milliseconds, it takes like 2 or 3 seconds, maybe 5. At the end of the day, if you give a better response to your customers, that is a better success measure than always thinking that it needs to stream, it needs to come in 10 milliseconds, whatever that may be. So lean heavily on quality of outcomes. The other lesson learned here is if you use multi-agent action-based plugging, like web search, API calls. There are so many examples of that. Advanced tree of thought prompting. All of these put together make up a very powerful combination for reliability, accuracy, and real-time information, especially with web search, right? In our case, we don't use web search for our stuff, but we have done experiments with it, right? So that's why I did want to include it. The LLMs are becoming more steerable and sensitive to your words, characters, and structure. So pay attention to your system prompts and consider reinforcements, which is basically repeating yourself in the prompts to ensure that LLM is adhering to your instructions. Let's move on to use case discovery. And this is really important. As you start to build out AI-enabled apps, there will come a time when everybody's going to stop worrying about AI assistants and co-pilots, and then slowly start to ask this question: what else can we do with it, right? And this is natural. We have to think about taking AI and augmenting our existing apps, right? Not like building a new co-pilot app, but an existing app, and how can we make it richer for our customers, more useful, save time, and make it a joy. So in order to do that, we have to ask some of these questions, right? Does it require human-like text generation? Maybe you can use it for code generation purposes, where the JSON schema or the C# code or whatever that is very domain specific. Maybe you can use it there. With structured output capability that was just released, it is starting to become more and more plausible and feasible. You have to ask the question like, does it have defined inputs and outputs, especially for text and images, like putting them together like we saw in that demo? Can the definition of input and output be documented with prompt engineering mindset? So what I mean here is when you decide these inputs and outputs, you have to ask yourself, if I was a BA, right, or a business analyst, and I have to write a spec, how would I write it, right? And you're handing off that spec to, in this case, LLM. So basically think from a business standpoint and thinking from a specification standpoint, and eventually which turns into prompt engineering, like how we provide instructions is very important. And when you do that, new use cases emerge. Just last week, I was part of 3 different use cases where they were right in front of us. We did not know until we started talking through some of these questions. And, someone was like, can we do this? And well, there was a perfect use case. So also ask ourselves, is it a stateless design? If you're using GitHub Copilot, there is a button that can, generate commit messages based on the Git diff. And that's a classic example of it's completely stateless, right? Like in the moment, providing something useful that users can use. Also, a key question to ask ourselves is, can the input and output be fit into the token limit? There's always a context window. So very important to ask that question. And then what is the level of determinism? Is it very, very math oriented or very deterministic, where you have no chance of making any mistakes, right? Like tax engine, for example. So that may not be a good fit, at least right now. So these are some questions to ask to figure out what kind of use cases are applied and how you can take generative AI and apply it to your business scenarios. Now, I do want to highly recommend this talk by Steve Sanderson, which does go into detail and shows you a lot of demos that are not just chatbots, but more than that, right? And how we should discover and execute on this great opportunity that we have got as .NET and Azure developers. Thank you.
All right. It's so cool to see how other folks are using .NET technologies. I always feel a little bit inspired when I see some of the cool things that other folks are building and how I can take a little bit of what they've learned and apply it to my applications. I like that. I like that a lot. This event is being recorded. It's on YouTube. You might be watching us on YouTube. Check it out. There's going to be a playlist that's available at the end of the day today. Head on over to youtube.com/.net if you're not there already, and you'll be able to find the playlist with all the great content when we publish that at the end of the day today, all right? Make sure you like and subscribe and all that stuff over there on YouTube so that you know when there's more live streams and other things going on with the .NET channel. We always have great video content coming. But first, I want to make sure you know about some of the other events and things that we've done. .NET Conf 2024 is coming up in November 12th to the 14th. It's a 3-day event, and it features the .NET 9 launch, all right? You're going to want to be a part of this. We've got some great speakers already lined up from Microsoft, and there's an opportunity for you to speak as well. If you're a prospective community speaker, head on over to .NETconf.net, and there is a call for content link there. Click that, and you'll be able to fill out some forms and potentially join us as a speaker for .NET Conf. Day 3 has more than 30 sessions of community speakers talking about some of the cool things that they've been doing with .NET. It runs for 24 hours. You can join us. You can talk in your own time zone on your own time. You don't have to wake up at 3 in the morning to give a presentation to some folks that are in Seattle. You can join us on your time, present, and have a great time as part of .NET Conf 2024. Like I said, November 12th through the 14th. We also ran an event just a little bit ago, .NET Aspire Dev Day, where we talked about all the cool things you can do with our new tech stack, .NET Aspire. And that leads me into our next 2 sessions that we have coming up. So in addition to that event that we had, we've got a session coming up from Gaurav Seth talking about adding generative AI capabilities into your web applications that you're going to run on Azure App Service. .NET Aspire comes in with our second session from Anthony, who's going to be talking about observing AI applications from dev to production using .NET Aspire. All right, Gaurav, you're up first. Let us know a little bit more about Azure App Service and generative AI.
Hello, everyone. My name is Gaurav Seth, and I'm a product manager on Azure App Service team. And today I'm going to talk about how to add generative AI capabilities to your .NET web apps for Azure App Service. So before we get started, here is a quick view into the agenda for next 30 odd minutes. So I'm going to talk about some of the key app service benefits, AI-assisted migration and modernization. How do we integrate Gen AI capabilities for a classic framework .NET web app? I'm going to talk briefly about intelligent observability and how do I integrate Gen AI capabilities again for a net new .NET web app using .NET 8. So let's start by talking about some of the app service benefits. Now, there are multiple benefits of deploying your web apps on app service, but today I am focusing primarily on the ones that are specifically useful for apps that use generative AI capabilities. Now, first thing is you focus on integrating Gen AI capabilities with your web app and not on the underlying infrastructure. Now, we also know that with the speed of AI innovations, you may need to release newer versions of your app faster and easier, and that's where native CI/CD integrations with popular services like GitHub, Azure DevOps, etc. makes it super easy and fast for you to go ahead and release newer version of your web apps. Now, it is also important to understand that while you may scale your AI backend or any other backend services that your web app is talking to, you would also require to scale your web app to address sudden burst in traffic. And that is where the platform allows you to scale either manually, or you could do an automatic scaling, or you can also do a rule-based scaling wherein you can use stuff like scheduler, or you can use even use a certain metric that you want to scale your web app. Now, remember, App Service supports most of the popular languages and frameworks irrespective of Windows or Linux operating system. So again, you have all the support required to deploy your web app to Azure App Service. Now, we all agree that security is critical for your web apps. You can build where security first posture for your web app using features like virtual networking, managed identity-based authentication, Microsoft Defender integration becomes super important for your web app, and these features are available for you when you deploy your web application to Azure App Service. Now again, if you want to use advanced concepts like vector caching for your Gen AI web apps, or utilize AI-powered monitoring auditing solutions from some of our Microsoft partners, we have recently introduced a sidecar feature for Azure App Service Linux, which again becomes very important. And even remember, this is all about how do you integrate Gen AI capabilities for your web app. Even for Azure App Service as a platform, we have started utilizing the power of Azure Copilot to help you diagnose and troubleshoot your web app. Now, let's briefly talk about some of the demo scenarios that I'm going to talk about. So, you have a .NET web app on-prem that you plan to migrate to App Service and also infuse generative AI capabilities into your web app. Now, I will show you how to use AI-assisted tooling in Visual Studio to analyze your source code, and then use free tooling to migrate your web application to Azure App Service. I will finally showcase how to introduce generative AI capabilities for your existing .NET Framework web app without the need to redesign or redevelop your complete web application. Now, before I get into talking about the first scenario, I again would want to reiterate the other scenario as well. So while I said that I'm going to talk about how to introduce generative AI capabilities for your web application, which is based on ASP.NET Framework, I am also going to talk about how to introduce generative AI capabilities when you are building a net new application, for example, using .NET 8. So these are the two core scenarios that I am pretty much going to focus this entire discussion on. So let's get started with AI-assisted migration and modernization, and then also how to introduce generative AI capabilities for a classic .NET web app. With that, let me switch over to Visual Studio. Okay, so this is a sample web application that I have here, and what I'm going to do is that I am actually going to use the Visual Studio Marketplace extension called as Azure Migrate Code and Assessment Toolkit, which basically does a source code analysis, and also if you have the GitHub Copilot chat integration with your Visual Studio, again, it also makes you suggestions and recommendations of code changes that may be required. So how you do that is you go ahead and download the extension from Visual Studio Marketplace, install it, and once that's done, you basically click on this new option that you start seeing called as Replatform to Azure. Now you're presented with two options. Either you can start on a new report, or you can also open an existing report. So I'm going to start by clicking on a new report. Now it lets you select the target that you would want to deploy your code on. So in my case, I'm going to choose Azure App Service Windows. I'll click Next. Now, because I have two projects, it gives me option either to select both or one. Maybe for the sake of simplicity, I just select first project. I click on Next. Now, in addition to the source code and settings, I can also make a selection about binary dependencies. I'll go ahead and hit Analyze. Now, within a matter of seconds, I'll be given this nice looking dashboard, which gives me a summary of severity, categories, etc. Now, let's go ahead and look at different issues that's been reported. So as you can see that I have first issue being reported, and again, you can see the severity being reported is potential, optional. There's yet another severity called as mandatory. Now, take, for example, if your web application was to use integrated authentication on-prem. Now, when you move your web application over to Azure App Service, you can still use authentication, but that would more be based on Entra ID and not the integrated authentication that you use on-prem. Such kind of issues are reported as mandatory. So let's look at a potential issue. So we have this issue being reported that my web application is probably trying to access some external resources, and I get which DLLs are doing that. And then if you see, I have this option called as Ask Copilot. Once I click on that, what's going to happen is, let me zoom into this window. So what's going to happen is it will pick up this specific warning or error and try and give you helpful context. Now, using this context, it describes the issue and it even provides you the steps to resolve this issue. So it talks about maybe you can update ports, you can migrate internal services if the access is for an internal service, and this is how you would do that. So this is basically your example code adjustment that you may use if you want. Now, what you just saw is how the power of AI can make it simple for you to fix source code so that you have a higher degree of success once you migrate your web application over to Azure App Service. Now, for a moment, let's switch back to our slides. And before I move any further into the actual demo, I also wanted to quickly talk about that, like you saw the source code analysis, which is AI assisted, of course. You also have a bunch of free tools that you can use. So imagine a scenario. Once you have the source code analysis, you have fixed all what's required. Now the idea is to migrate your web application, and App Service team basically provides you a bunch of free application tooling, which could be the whole Azure Migrate integrated experience or simple PowerShell scripts. Now, depending on the use case that you have, which could again be a data center exit or a single IS web server migration, you could make a choice of your tools. Now, broadly, what each of these tools does is it runs a discovery. So if you're talking about the whole integrated Azure Migrate experience, we do a bulk discovery where we go ahead and based on your virtual appliance, that is a one-time configuration, we pick up all the servers which are running IS Web Server and we give you a rich inventory of all the .NET web applications. Once the discovery is done, you go ahead and run assessments. Now, what assessments does is based on attributes like what region you plan to migrate, are there any discounts or pricing tiers that you wish to use, or are you going to migrate to an app service environment if your requirement is around an isolated deployment. We would basically go ahead and run a bunch of configuration checks and come back and give you a report in terms of what's ready to move with conditions and what's not ready to move. Now, when I say what's ready to move with condition, the idea is that your web application will move fine. It will migrate just fine. But the challenge is that once your web application is migrated, you may need to make some configurational adjustments or changes. For the best example I can give you is your web application is hosted on a non-default port on-prem like 9000. But once you move it to Azure App Service, the only traffic is available over port 80 and 443. So that's the kind of changes that I'm talking about. Now, once you're done with the discovery and the assessment, the whole Azure Migrate experience also allows you to do a bulk migration of the selected web applications over to Azure App Service. So what we do is we move the whole zipped content and the configurations for a web application, and for every individual web application that's on a IS server, we create a net new Azure web app and then deploy your code and config over. Similarly, if your requirement is not an entire data center exit, if you just want to move a bunch of web applications out of a single IaaS web server, you can use PowerShell scripts. Technically, behind the scene, PowerShell scripts also do exactly the same thing. We discover, we let you assess, and then we migrate a web application. But I just want to give you a quick shout out to two more scenarios where PowerShell scripts become super helpful. One, if you are trying to move your cloud service. So if you still have like a web role on a cloud service, you can actually use PowerShell scripts to migrate them over to Azure App Service. Or if you have a hybrid or like an offline online scenario where you could run discovery and assessment on a server which has no internet access, and then move the zip over to a virtual machine which has internet access, and then finally migrate your web application. With that, let me quickly move over to the sample app topology or the demo app topology that I'm going to showcase next. So now this is a sample topology for a first demo app. Now we use, as I already showcased, we used Visual Studio Application Code Assessment Toolkit to analyze an existing ASP.NET web app on-prem, and then we made required code changes if they were needed. Then, as I spoke about the number of tools that are available, I migrated this web application using PowerShell scripts. Now, here is the interesting point. You can either decide to introduce Gen AI capabilities before you migrate your web application over to Azure App Service, or you can redeploy your code once you made the changes after deployment. So that's completely up to you. And just a quick call out that we for the demo, we are using GPT 3.5 Turbo. Now, the other important point to understand is that the demo web app and all the required resources are deployed to a landing zone. Now, a landing zone is basically a sort of a templated deployment for you, which is based on architectural best practices and, of course, adheres to all of the goodness that comes with Azure around security, scaling, isolation. Now, also, it is important to note that all communications between app and other Azure web services or other Azure services, for that matter, are secured using virtual network and managed identity authentication. With that, let me move back and showcase. So this is basically the web application that I was talking about. So in the interest of time, I've already migrated this web application from an on-prem IaaS web server over to Azure App Service. And as you can see, now once you've migrated a web application, remember, as a platform, we provide you a bunch of features that you can use. It could be around, you want to do scaling, or you want to look at your environment variables, change them. If you want to set up authentication, set up application insights for basically observability, scale up, scale out a web application. So yeah, there are a lot of things that you can do from the platform itself. Now, this is the demo web application that I was talking about that I migrated. This is like a hypothetical dev shop where we are selling a bunch of products. Now, if I go ahead and basically get into one of these, let me go ahead and get into any of these products. What I've done is, here is the example scenario. This was a ASP.NET, or this still is a ASP.NET framework web application that I migrated. And what I've done is, to this existing web application, I've introduced this new capability called a Chat with AI Assistant. Now, what's happening behind the scene is I have done an integration using the Azure OpenAI.NET Client SDK. And using that integration, basically now I can go ahead and let my customers use the power of Azure OpenAI to ask questions and get relevant answers. So maybe, I can get answers. And just to quickly point out, In this specific demo, I am not using the concepts like RAG, or I'm not using the database context for my search. I'm just going to make a search directly against the Azure OpenAI endpoint. So maybe I can just ask any question. Suggest a travel bag $100 maybe for students. And that's how I get the response back. Now remember, what I am trying to showcase is a very simple but yet super powerful scenario where you have an existing web application, you have modernized it using the Visual Studio extension, you have gone ahead and then migrated the web application, and now what you have done is you have infused Gen AI capabilities for an existing web application. I have not redesigned or redeveloped the entire web application. What I've simply done is I've gone ahead and introduced this additional capability. So that's the scenario that I was talking about, where you can introduce intelligent capabilities for an existing .NET or .NET Framework web application. Now, if I go ahead and show you the code changes that I made, so that's basically my web application. So what you saw where I was like having the chat experience was the chatbot.aspx page. I'm using a very simple jQuery call to my chat controller, and that's my chat controller that I was talking about. As you can see here, what I did is I've developed a new chat controller, and what I'm doing here is I'm using the NuGet packages for Azure OpenAI Client SDK for .NET and the Azure.Identity SDK. Now what I'm doing here is I have defined all the configurations as parameters so that I can define them as settings in my app service. I create the OpenAI client. And the most important point that I want to highlight here is, as you can see, that the entire communication between my web application and the Azure OpenAI backend is authenticated using managed identity credentials, and that's exactly what I'm doing here. Now, once I've established the connectivity, I use the getResponse message, and in this method, what I'm doing is I'm using the chat completions API. Now, in this API, I pass the model, and then I use a prompt template. And what I've done for my prompt template is I'm saying that you are an employee of a store that provides product recommendations based on user query. And again, I want the recommendation to be upbeat and friendly and just a single recommendation. So once I've done that, I pass the message and I pass the user query, I get the response back and send it over to the page. So if you see, it's just a few lines of code, but now what's happening is my existing web application has generative AI capabilities. With that, I'm going to move back to my slides. Now let's move on to the next piece. So I just spoke about existing web applications. Now let's talk about what if I want to create a net new .NET 8 web application. How do I introduce generative AI capabilities? So again, there are a number of ways that you can do it. You can either do a simplest of approaches using REST APIs. You can use Azure OpenAI SDKs. Recently, we have also announced OpenAI SDK, which is currently in beta for .NET, and it works with GPT-4o. Or if you have requirements, you can even use higher level LLM frameworks, something like LangChain or Semantic Kernel. Remember, and if you want to look at some of the samples, you can go on the link on your screen. But that's some of the ways that you could introduce generative AI capabilities into a new .NET 8 web application. And again, here is a quick summary of how do you go about adding these capabilities to a .NET web application. I already spoke about how to add generative AI capabilities using SDK for an existing web application. You can also do the same way for a new web application. You can use semantic kernel. And now the reason behind using a semantic kernel is if you have a scenario where you want to orchestrate across multiple different models. I mean, that's a demo that I'm going to show in a while. Or if you're trying to look at using a sidecar pattern on Azure App Service for Linux, especially if you are looking at options like vector caching to improve performance and even lower cost. I mean, these are different scenarios or ways that you could be introducing generative AI capability for a new .NET 8 web application. Again, here is a quick view into the topology before I go ahead and showcase the code and the web application. Now, this is a .NET web app. I'm introducing Gen AI features using the .NET SDK for OpenAI. Now, this web application also uses the sidecar feature for App Service Linux because I wanted to use vector caching so that I can reduce round trips to Azure OpenAI endpoint. Now, we are also going to make use of semantic kernel for overall orchestration of app, DB, and OpenAI communications, and also use text embedding model and GPT 3.5 Turbo. Now, again, remember, it's the same concept for deployment. All the required resources get deployed to a landing zone for security and best practices perspective. And also all communications are again secured using virtual network and managed identity based authentication. And before I switch to code and demo, I also want to quickly talk about intelligent observability. If you remember, I did say that one, if you have a requirement where you want to use a sidecar feature for bringing in some of our partner offerings, which could again be AI assisted for logging and auditing. So you could use the sidecar feature for that. Also, I'm going to, in my next demo, I'm also going to talk about Azure Copilot. So yeah, that's where the whole concept of intelligent observability comes into the picture. So I'll showcase how you can use Azure Copilot to simplify your whole diagnose and solve app performance or app errors. With that, again, I'm going to switch back to Visual Studio. And before that, here is the .NET 8 app web application that I was talking about. Remember, this is exactly the same web application that we just saw for framework. Now, maybe I can just get into jewelry or accessories. Maybe I'll just go ahead and navigate to jewelry. And if you see exactly the same concept, I can say chat with AI assistant. Now, the quick difference here is that every time I am going to post a query, what I'm also going to do is I am behind the scene, I am also using the whole Azure OpenAI search with my Azure SQL database. So I'm basically going to use the capability of AI search on my database, get the context, and then use Azure OpenAI to summarize and give the response back to you. So if I say, suggest gold-plated chains, if you see the first time, the response is going to be a bit slow. The reason is this response wasn't there in my cache. Now, next time, if I go ahead and ask a similar question, or if I go ahead and ask a question which is again similar in context, I would basically get a much faster response from the cache that I'm using. You can see how fast we get the response back. And let me go back to the code now. So this is basically the same controller that I created, but this time it is for .NET 8. Now over here, what I've done is, one, remember, I am using session history over here. And secondly, after I'm done with all of this, and yes, just a quick call out before I move on, I am using the quadrant for my vector caching. I'm using quadrant database for my vector caching. And this is where basically the whole get response method comes into the picture, which is used for getting the query from the user, doing all the basically communication back and forth with the OpenAI endpoint, and then sending the response over. So you can see here that I actually have a quadrant endpoint, in which is localhost. Now, the interesting thing here is, from my web application perspective, I am using sidecar pattern. And once I do a sidecar pattern for my web application, the whole quadrant database is available as a localhost endpoint. And that's why, if you see, I'm actually using a localhost endpoint. Once I have defined the endpoint, I go ahead and create a cache using the quadrant database, and then this is where I am getting into using the semantic kernel. You can see here that I create the deployment name, and remember, as I said, the entire conversation or the entire communication between this web application and the OpenAI endpoint is secured using managed identity credentials. Now, for generating this text embedding to use with my OpenAI search for on my SQL database, I'm actually using the text embedding model. Once I do that, once I generate basically these tokens, what I do is, similarly, like I showed in my previous demo, I create a prompt template just to instruct what kind of personality I'm looking for in terms of my responses. And I also add this context to my session key. Once I'm done with these things, I go ahead and serialize the history. And finally, you can see here, that's where I start the actual chat functionality. So what I do here is, I'm using the chat format for semantic kernel. I pass in, and as you saw that we also keep we also maintain the chat history. So that's how we do it. And once I get the tokenized form for the user query, I send that to be summarized using Azure OpenAI endpoint, and that's basically the model that I'm using. And then I go ahead and stream the response back to my end user. So again, what you have seen is I can either do a simple integration with an existing web application, or we also support, or we also let you deploy your web applications if you're looking at more advanced concepts around vector caching for your web applications once you start using the sidecar pattern. With that, I'm going to switch back to my okay, and let me also quickly talk about the whole Azure Copilot experience. Now, once you click on Azure Copilot, now imagine I am experiencing some kind of slowness on my web application, and I want to use the Copilot capabilities to help me diagnose and troubleshoot the whole snowless. So what I'm going to do here is I'm going to say web app slow. Once I type this, now Copilot would automatically get the context of this specific web application, as you can see here, and then it is actually going to suggest you so behind the scene what's happening is this is actually using the inbuilt intelligence to go ahead and diagnose using some of the detectors that we have, and it's going to come back with a bunch of solutions that you can use. So you can see here some of the potential root causes why your web application could be slow. So it could be like, if your CPU consumption is beyond 70%. And then once you know some of these root causes, what are the solutions? So you can collect a profiling trace. Now, I can go ahead and keep conversing with Copilot. I can say, okay, now tell me how do I collect the profiler trace? So I can do that. But the idea here is that, again, we are using the power of Azure Copilot to help you diagnose and troubleshoot your web application. So what are the key takeaways from this session today? So we talked about how do I modernize and migrate my existing .NET web application over to Azure App Service and infuse generative AI capabilities, and also how do I introduce generative AI capability for a .NET for a net new .NET 8 web application. So we saw both the scenarios where I have an existing web application or I am trying to add generative AI capabilities for a new web application. Now, if you want to get started with Azure App Service, here is a list of useful links that you can use. Now, we are on Twitter. We also have a lot of blog articles that you can go through. So with that, I conclude this session. Thank you for joining in and have a great rest of your .NET Conf focus on AI.
Hi, everybody. I'm Anthony Shaw, and I'm going to be talking about observing AI applications from dev to production with .NET Aspire. And in this talk, I want to cover off a few things. So I said observing applications. So what is observability? We're going to talk about OpenTelemetry as the standard for our observability strategy. Considerations for observability in production. So I'm going to show you two demos. One is a production application and one is a dev environment and a dev application. It's the same code base, but we've just got different ways of monitoring the application. I'm going to talk specifically about observing AI applications and what makes them a bit different and what ways you can use to observe AI applications. And then I've also got a list of resources and additional links and stuff for you to check out. So before we get cracked into that, my name's Anthony Shaw. I work in the cloud advocacy team at Microsoft. I'm actually focused on Python. So whilst I'm speaking at the .NET conference, my expertise is in Python, but I do a lot of work with .NET as well. And I've been using the .NET Aspire dashboard in particular for observability in a series of Python applications and just love using it. So I've basically applied that same approach from Python to the .NET stack. And I've used the same techniques in .NET and Python. So we're kind of building applications in both environments, but just love the Aspire dashboard and what it kind of brings to telemetry. So first things first, what is observability? You've probably heard terms like logging and monitoring before, but observability is kind of a bit of a convoluted way of saying that you're trying to understand an application better by looking at its outputs and trying to instrument its inner workings. So with there's different ways of doing it. So why would you have observable applications in the first place? If you just have logging, the reliability of logging depends a lot on what you're logging. And when things go wrong in an application, it's difficult to know beforehand what you should have been logging or what you should have been capturing. So the idea with observability is that you instrument an application by trying to capture as much information as possible so that when things do go wrong in whatever form, you can kind of wind back the clock and look to see what was happening at that time. So for example, if you got reports from a user that, oh, last Tuesday, the application was running really slowly and we got this error. And then you ask them, okay, what was the error? And they go, I don't know, I didn't capture it. Like, how would you kind of wind back the clock to understand if there was a crash or an unhandled exception, or even just it running slowly or differently? What kind of factors contributed towards that application having that behavior? So this is kind of the benefit of hindsight. Each time you have an issue with an application, you might add more logs, more information to it. But the idea with observability is that you use instrumentation to capture metrics, logs, and traces in your application, kind of to see everything that's going on. So that's kind of one thing. Another is that you try and simplify the complexity of the app. So I'll talk about traces in this talk, but if you just log absolutely everything, you've got reams and reams of data, of text, of information. And when things do go wrong, you've got to sift through that. And I've definitely been in scenarios in the past where, we've had a fault with an application or a bug that we're trying to track down, and you're just looking at thousands and thousands of log records, trying to figure out which one contributed to the crash, or which one contributed to the specific issue that we're trying to track down. So with observability, the idea is that you kind of capture a session or a trace from when the user initiated it to the back end. And I'll show you some ways of visualizing that as well. This is not just about having lots of data captured in the database. It's actually about using tools and UIs to visualize what's happening in the application. And then we can use that to capture trends as well. It's not always as clean cut as a user reporting a problem. You might actually see performance degradation over time. So for example, you may not have noticed, but your application started running 20% slower when you made a new change or a new deployment. So observability is a good way of capturing trends and data because you're instrumenting the application in the back end and all the different components. And you're capturing that information. You can see historically how things have worked. And I'll show you what that looks like in the UI. So OpenTelemetry is the standard I want to talk about today when we talk about observability. It's not the only option. There are other tools. There are other standards. OpenTelemetry actually replaced a number of other standards. So there were things like OpenCensus was probably the main one. It was a combination of that and some other projects. It's backed by the CNCF now as well. So OpenTelemetry is a modern standard. It's for observability of any application. So C++, C#, Go, Java, JavaScript, Python, Rust, as well as things which are baked in. You can trace end-to-end from the front end to the back end. So this is super important. So the app that I'll show you has like a JavaScript front end. It's some JavaScript components. And then it has like an ASP.NET backend. It's got a serverless component to it. It's got like a lot of different services working together. But because you've got a standard that's actually built to be agnostic of the technology, then you can trace things from start to finish. OpenTelemetry has also got a massive ecosystem of libraries for instrumenting other tools and third-party packages across all those languages I spoke about. You can also kind of plug and play where you want to put the data. So I'll show you the Aspire dashboard and also application insights, but you can export to other platforms as well. Like I mentioned, it's governed by the CNCF, the Cloud Native Computing Foundation. It's an open source platform, and it's an open standard. And it also comes with a protocol, an open protocol called OTLP, which is an open spec for communicating between where the data is collected and the software. So it's basically one massive big open spec that looks at your application. And then the first thing you would do with OpenTelemetry is you'd start putting instrumentation on the app. There's different ways of doing that. If you're using frameworks in your application, like ASP.NET, for example, you would use the ASP.NET instrumentation library. That is a package that you would download and configure in your application. And it would automatically set up instrumentation for things like incoming web requests, set a trace on the users. It would look at the logs by default. So often with OpenTelemetry, you can just download a package from NuGet, add it to your application, and the instrumentation will come out of the box. You can write your own custom instrumentation as well. So if you want to capture attributes for the app or anything specific, you can use the OpenTelemetry SDK for C# to build that in. You then have basically three categories: traces, metrics, and logs. And I'll show you all three of these and how they kind of work together. But your application runs, you put instrumentation on top of that, and that emits traces, which are like detailed events, basically capturing what's happening in the application, which are formed in like a tree structure. So if you imagine a user clicks a button on the website, that then starts a trace or a span, and that might then kick off lots of different things. Like it might send an API request. That API request might run a database query, for example. So like that trace goes end to end from the user initiated action all the way down to like the backend queries or reading and writing files. So that's the traces. Metrics are more sort of data that you can collect about the system at runtime that's not specific to a particular user, like how fast things are running, how many API queries you have left, for example. And then logs is kind of what you would expect, which is an iLogger interface, where you can use traditional logging, and that then gets captured and exported. So the collector takes all of that data and then puts it into somewhere where you can store it long term and then search over it. So this is how OpenTelemetry works. You've got instrumentation capturing all this rich data about your application. You've got a collector, which is a service that runs locally that stores that and caches it. And then you would plug in an exporter, which exports that data to a monitoring system. Then on top of that, you would typically have a user interface where you can explore the data and understand what's been going on. So the concepts I've mentioned, first one is traces. The trace has a unit of work called a span. So when you're doing anything with OpenTelemetry, you'll start to be familiar with a span. I kind of see it as being very similar to a using statement. So you've got I guess a context, and everything runs within that context. A span is very similar. So you would you would initialize a span, and you can have spans within that. Spans can have attributes, so you can store data, any metadata you want inside the span, and it all gets captured in the system. They're typically created by instrumentation libraries, or you can manually make your own. So if you want to create a span based on some custom code or logic in your app, you can do that. Or if you're using one of the instrumentation libraries, it would create the spans for you. Spans are nested. So like I mentioned, if a user clicks a button, then that makes an API call, for example. The API call itself would be a span, but it belongs to the original call. And spans have kinds. So you can separate like user-initiated requests or queries versus things like automated system commands in the back end. We've then got metrics. Metrics are measurements captured at runtime. They're created by meters. And they're typically defined, again, in instrumentation libraries, or you can define them manually via the SDK. So a meter might be CPU usage, for example, as a meter, or amount of RAM available. So those are kind of meters that you could poll or run periodically, or they might be more specific. So you might want to capture the number of users you've got in the system. And that's something you might want to poll and just capture. So for example, if you're looking at a trace, you might want to look at traces and metrics at the same time. So for example, if a user reported an issue with slowness or there was a particular crash, then you'd see the span, you'd see the attributes and the exceptions and the errors that happened when the user made that request. But you might also want to see at that time, what were the system data, what were the system metrics. Meters can be aggregate or live as well. And I'll show you both of those types of metrics. You've also got logs, which are essentially an extension of the logging format. They're timestamp text records. You can put structured data in them as well, or you can make them unstructured. The log exporters can plug into existing log infrastructure. And for .NET, that would basically be an iLogger interface. And the app that I've got in our demo shows you what that looks like. So far I've talked about instrumentation libraries. Now with AI applications in particular, I guess there are typically a lot of services that you would be calling, or you would be using libraries to kind of orchestrate those services. So whether that's LLMs, vector stores, different types of search capabilities, like local models, for example, there are lots of different components and services that you have to plug together to build an AI application. So the first one I wanted to call out was probably the simplest one, which is the Azure OpenAI SDK client for .NET. So that has instrumentation for traces. So it would capture your chat completions, for example. If you're using GPT Vision, like it captures that as a span. So it does tracing out of the box. It does some metrics out of the box, but you can really need to kind of configure those yourself. And it has logging out of the box. So it's essentially you can install that SDK, and if you've got OpenTelemetry configured, it will automatically capture the spans for your Azure OpenAI calls. If you're using any other component in Azure, so using the Azure SDK, so in the app I'll show you, we're using document intelligence. So whether it's like a PaaS service or any of the management interfaces for Azure as well, traces and logs are captured automatically. So that comes out of the box with the Azure SDK. The Azure SDK is automatically configured for OpenTelemetry. You can extend it as well if you want to capture any additional data, but it just works out of the box. And then the other one I wanted to call out was Semantic Kernel for .NET in particular, because they've gone really big on OpenTelemetry and the design for Semantic Kernel. So it does traces for anything. If you're using Semantic Kernel as like your orchestration tool for calling and chaining together different AI components. It also comes with metrics, which is super handy for AI in particular. So when you're looking at things like token usage for LLMs, it measures those by default and it exports those as OpenTelemetry metrics, and it also supports logging. So far I've talked about enabling telemetry in your application. But then when it gets to exporters and actually trying to export the data, the one I want to show you for the production environment is Azure Monitor. So Azure Monitor will basically show you an OpenTelemetry span in the UI. You can navigate to see specific attributes. And I'm going to show you a live demo of that in a second. So the UI is built in. It supports OpenTelemetry out of the box. Traces, metrics, and logs are all supported. And if you're using that with log analytics, then you've got long-term storage of data. It's delivered as a service, and you basically just pay for the amount of storage that you're using. It's ideal for production workloads. especially if you're producing large volumes of data, and you can use a single Azure Monitor instance to capture telemetry data from any of the components, libraries, and tools that I've talked about so far. So I'm going to show you a demo from my other machine. It is a RAG application running in Azure Container Apps. It is written in ASP.NET. And this application, you upload documents, like corporate documents about, in this case, we've done things like we've got a fictional company, but we've got like market analysis, we've got our HR documents and policies and stuff like that. And we've uploaded them. It's indexed those documents and put them into AI search. So we can do essentially like a private GPT of those documents, and you can ask it questions and interact with it. So if you wanted to understand what's in our fictional health insurance fund, what things are covered and what things are not covered, you can interact with that like a RAG application. So this is a production app that I've got deployed. It's got a number of components. So I mentioned the container app that's running this ASP.NET service. We've also got things like Azure Functions, which does some of the archiving. We've got the search service component. We've got Azure OpenAI deployed there, which has got our models. So we're using GPT-4 to do the actual like text analysis and generation. This demo is fully open source. There's a link I'll put in the end of the talk. And important thing is that I've plugged this in with OpenTelemetry and captured all the data about what's happening in the application. So I've got application insights running on this app, and when I'm interacting with it, I can look at performance. I can look at the particular traces I've got. Let me just go back to where I was. Excuse me. I can interact with my app. And then in the UI, I can drill into the samples to see everything that happened when I clicked on the button. So for a RAG app, there's the retrieval, which is the search, which goes into AI search. So I can see here I've got my search client call, my call to AI search in the backend with a specific query. I've got the 2 chat completions for the LLM. So I can see those combined as the specific trace. And then anything else that's kind of captured in the backend that I can see here in the trace. So that's my sort of production app, and I can use this to understand, okay, what's happening end to end in my request. And then I can also look at particular types of calls. So for example, like this is my LLM call, and I can go back and look in the application to understand all the times I've called the LLM, what the typical response time is, and what's happening with that application. So that's production, but we talked about .NET Aspire. So I'm going to go back to the slides and talk a bit more about what happens in Aspire. So this is a RAG application that I demoed. The idea is that you have a user question. You would look up your specific documents. That's the retrieval component. The results of that using some kind of vector search would be augmented into a chat completion query, and then you'd use an LLM to generate a response back to the user. So I guess what makes this unique when it comes to observability is that you've got one user request, and as far as the user sees it, they've typed in a question, they get an answer. But in the back end, you're basically stringing together all these different services and different components. And you want to see that as a single span, like I showed you in that demo just there. So as an example, there's a whole bunch of different technologies you could be using to combine together to make a RAG app. This particular one is using Blazor, Azure AI Search, GPT-4, and Semantic Kernel. But you could be using any number of combinations of different technologies in the front end, the retrieval mechanism, and the LLM. You could also be using a small language model if you're running things within a private environment, or you kind of what I've categorized just like the glue kind of libraries, so for specific metrics. When it comes to observability, the things that I think are really important to measure is on the front end, there would be things that you would typically want to observe anyway, which is who is the user. So if a particular person told you there was a problem, like how do you capture who that was and when it happened? When it comes to retrieval, then you're really looking at performance is one major thing. So especially with AI and LLMs, like the retrieval time and the reliability of the response are things that you want to measure and capture. So I would suggest doing those as metrics and capturing the API parameters as span attributes, which you would get out of the box. If you're using an orchestration library, then capturing the chain or the flow and then trying to emit that as a span, again, is really important. So as an example, when it comes to traces, metrics, and logs with AI applications, the traces, I'd say you'd want to capture retrieval calls, so the actual search queries, the API calls to other components, document and search lookups, and also authentication. So those are traces you want to capture. In terms of metrics, tokens is a massive aspect of this because with GPT, or your measurements basically for how you use GPT is the number of tokens that you're consuming. You also have rate limits on the number of tokens per minute that you have, and the amount that you've got allocated in the system. So you want to capture those as metrics. And then with logs, I think in particular user query, but also looking at safety violations, the response from the LLM, and anything else you might need for auditing as well. So those are kind of key things that I think is important to capture. Okay, so now I'm going to switch back to my demo environment, and I'm going to show you a couple of other things. So in my application, the first demo I did was using application insights. And the way I did that was to, in my service builder, this is my ASP.NET application. I'd install the application insights package, which is the Azure Monitor Open Telemetry Exporter from NuGet. And if I've got an application insights connection string in my environment variables, then I'm going to configure application insights telemetry. That out of the box sets up traces and logging. And the only thing that was missing, I think, in that configuration was metrics. And I mentioned earlier that Semantic Kernel emits a whole bunch of really helpful metrics as well. So I wanted to enable those and just measure in particular like token usage and things like that for OpenAI. That's my production configuration. So if I'm running a dev environment, you could emit to application insights. You get all the capabilities and stuff like that. But if you've got multiple developers working on the same project at the same time, it's going to get a bit confusing as to whose environment is which. There's also not really a simple way of just like resetting all the telemetry data. So if you're just kind of mucking around or experimenting with stuff, really you want an environment that's more sort of like temporary, that you can just use to visualize. So what I've done in this application is I've said, okay, in .NET, if this is in development mode, so if you've run .NET Run locally, it would by default be development, or if you set the environment to be the development environment, then I'm going to configure some extra stuff. So I want to enable open telemetry logging, capture all of my logs. I want to capture all of my metrics for Semantic Kernel, anything in Azure. And then also I want to enable all traces, so capture all information from Semantic Kernel, from the Azure SDK, and also from the Microsoft machine learning libraries. I then got ASP.NET core instrumentation, which you get with the OpenTelemetry instrumentation for ASP.NET Core. That's a package that you install. And then I've also installed one for HTTP. So when I've got all of that running, I can run my app locally. And I've also got running the .NET Aspire dashboard. You can run this if you're using it through Visual Studio. My preference is actually to run it directly in Docker. So if you've got Docker installed locally, whether that's on Windows with WSL, on macOS, or any other environment, then you can do Docker run with the Aspire dashboard. There's the link there. There's details on how to do that in the Aspire documentation. But that basically runs the Docker image, the Docker container, and then we've got this Aspire dashboard running locally on our machine. That is like a monitoring environment designed for OpenTelemetry, where everything I've now got in my app that's running, all my traces, my logs, and my metrics are there, and the app running. Hopefully the app's up and running now. So I've got that RAG app I demoed earlier running on my local machine, and I can capture the same information that I was looking at in the production application. But I've set up ASP.NET. Instead of sending it to application insights, it's sending it here. So like if I come into here, I can see what's happening in my app, which calls are being made, what backend calls are happening in my application. And I've then got my end-to-end traces as well. So this one's running at the moment. That's running the OpenAI call. Let's have a look at that. So the same information that I saw earlier in application insights is available on this local Docker image that's running the .NET Aspire dashboard. Locally on my machine, I can see all my backend calls. I can see the OpenAI calls, the chat completions, all the attributes, the configurations, everything like that is available just locally on my machine. And I can capture and play around with my application. I can try and crash it because I'm a developer. And I can also flip to the specific metrics I have available, which I mentioned earlier. Semantic Kernel has this really helpful automated metrics for completions and token usage. So it will capture OpenAI tokens used, tokens remaining, and give you that as a graph as well. So I'm just going to go back to my slides. Okay, so to recap, OpenTelemetry is a plugin solution. It's designed so that you pick and choose which instrumentation libraries you want to use and which ones apply to the specific technologies that you've got in your back end and your front end, and you string those together. I think typically when people talk about OpenTelemetry, they talk about monitoring in big production environments. But what I really like about the .NET Aspire dashboard is that you can use the same technology to instrument an application when you're doing development. And often when you're doing development, especially in AI applications, not everything is running on your local machine. So like the LLM itself is a service that I'm consuming. The AI search component is a service that I'm consuming. But I still want to do that debugging of my local web app. And I can use something like this to kind of capture that whole end-to-end environment and that whole end-to-end trace. There's some extra resources that I wanted to highlight. So this RAG application is a project on GitHub that you can look at. And if you want to, that one comes with application insights out of the box. And using that link, you'll also see how you can use it with local telemetry as well with the Aspire dashboard. There's a great session on observability .NET 8 and OpenTelemetry. And there's a blog post from the Semantic Kernel team about what they do with telemetry, which again is using and heavily invested in open telemetry, how they capture spans, metrics, and stuff like that in Semantic Kernel. Yeah, and then lastly, there's a collection available for everything that's in the sessions today. Thank you for coming to .NET Conf, and yeah, good luck with your observability adventures. Thank you very much.
Oh, that was great. I love seeing how the new .NET Aspire stack helps out with other technologies like artificial intelligence. Thanks so much, Anthony. It was great to see that session. Now, coming up, we've got some more great content. We've got 2 more sessions to end the day. But before we get there, I need to make sure you know a little bit about our sponsors. Check out the 10 companies that are helping us out today. Big thanks to them for getting the word out about .NET Conf, Focus on AI. Make sure you check out some of their websites. They've done a fantastic job helping us out. And they've even put together a swag bag for you, okay? There is almost $5,000 worth of gift cards and licenses and a whole bunch more in 15 swag bags that you can enter to win if you go to aka.ms/.NET-FOCUS-AI/evaluation. All right, check that out. There's an evaluation form for you to fill out to tell us what you think about the event, to tell us what you think about using artificial intelligence with .NET, and click the link in there. You must click that link. It's going to take you to another area where you can enter the swag bag raffle. All right. Now, of course, there's been a ton of links that we've had for you throughout the day today. So many things. You want to just get that one Uber link, the one place to go. We've got a full collection for you at this address, aka.ms/.NET-FOCUS-AI/collection. You don't want to type that all in on your phone. You're typing quickly. You can put your thumbs at rest. Just take a picture of that QR code, and it will take you right to the collection with all of the resources, the Learn modules, links to videos, information about the survey, information about our AI challenge that's going to be going on for the next month on YouTube that you can tune into and watch live streams, and also participate in a couple of challenges, some tasks for you to complete that'll help you learn a little bit more about .NET and AI. All right, next up, I've got 2 more sessions for you. The first one, we're going to learn about building Windows apps and infusing a little bit of AI in there so we can do some stuff for Windows, so we can do some stuff with Copilot. Nicola is going to join us to teach us a little bit about how we can take our .NET skills and build on to Copilot in Windows. After that, we're going to learn about how we can use .NET with Microsoft Teams to build some Copilot capabilities in there. That's going to be with our friends Aicha and John. So let's get started diving in and learning about Windows with Copilot and the .NET runtime. Nicola, take it away.
Hello, beautiful people. I hope you're enjoying .NET Conf so far. In this session, we'll focus a lot on AI and how to add AI inside of your Windows applications with the Windows Copilot runtime. Now, if you're not familiar with the Windows Copilot runtime, it's a runtime we introduced at Build this year to help developers infuse their applications Windows with AI and take full advantage of the scale of hardware that's available out there, whether it's any of the Intel devices, AMD devices, or the latest Copilot Plus PCs with devices that have NPUs on them. It allows developers to access any point of the stack, all the way from just the experiences and just easy-to-use apps that use AI, and all the way down to the level that's closest to the silicon to access, to use the tools and the frameworks to bring their own models and to run on top of those devices. Now, I'd like to show you how to do this through demos. So I'm going to switch away from slides. And for the rest of the sessions, we'll mostly be in demos. And I'll start with an experience that I think is fun. I want to show you what some apps on Windows are already doing with AI, starting with Paint, the app that I think people enjoy and love. And if you're using a Copilot Plus PC like I am using right now, you'll notice there's new features that use AI to generate content as the user is using the application. In this case, Co-Creator allows me to generate images based on what I've drawn on here. And I've been feeling a bit stressed, so I'm gonna draw a peaceful meadow just to kind of be more peaceful. Meadow. And I need to start drawing. So I'm going to start with just a little green area down here. So let's try that. Maybe fill it up with a little grass. Let me try that one more time. Like that. There you go. Maybe do a little blue on top. And then I'll do a bit of clouds. And you'll notice that as I'm doing this, the co-creator is generating content on the side. There on the right. So let's go ahead and add a bit of clouds here. Maybe a cloud here. Maybe a bit of a cloud here. And then you'll notice that it's generating exactly what I wanted. And this looks kind of familiar. But what I really want to show you here is if you actually open the task manager, one thing you'll notice on these new devices now is that there's an additional graph to show you the NPU, the neural processing unit on these devices. And the features that are being used inside of Paint are actually fully leveraging the NPU to do the whole AI, the machine learning models on this device. So for example, if I put this on the side here, and let's say I do another generation, let's say I want to put a little line here again, maybe something like that. Let's see what that happens. But if we look at here, we can see a spike on the NPU right there. Right, you can see that spike right there. And what you'll notice even is that the CPU didn't do anything. Same time, the GPU didn't have a spike in there, just the NPU did. Which means that we're leveraging the NPU here to offload a lot of that heavy processing of the AI functionality and clear up the GPU and the CPU to do whatever they need to do best and to process the data the way they need to. This is a little fun example, but there's also other examples of things that you're probably using every single day. For example, snipping tool is a great example of a way that we've added AI to the Windows experiences in here. Let's see, I think I need to click it there. Through a feature that allows you to just do text recognition, right? So you can take a screenshot, you can copy image. And this is a really easy way that we've added AI throughout different aspects of Windows that just makes the experience, it makes it better and makes you more productive to use the application. And at the same time, we're also making these experiences available to developers to use within their own applications. There's other things that we're doing in here, such as Studio Effects, which is adding different effects on top of an app, on top of the camera to offload them off to the NPU, so that way you as developers don't have to do these type of things. And you can use this directly inside of your applications as you're building them. Now, to show you how to do this, I have an app for you. So it's an app I built to demonstrate the usage of these different APIs and how to actually add models to your applications. It's a very simple note-taking application. It's using a lot of the common patterns that I think most developers are building and using today to build their applications. And we'll see how we can actually add AI throughout this applications in a way that will definitely relate to your users and will relate to yourself when you're adding these to your applications. First things first is this application is built on top of WinUI 3. It's a WinApp SDK application. It's fully .NET. The first thing I want to add in here is the ability for users to add images and to add audio files alongside their notes. You can see here we have videos, and we've also have the ability to add images. And one of the things we can do here is I can drag an image directly to my application. And as I've added it into my app, you can see here that same OCR experience I've added to this application, where I can also select the text, I can recognize the text. It even works with handwritten text, which is incredible here. It's a great model that runs on device that ships with Windows that developers can easily use as an API. The way we're adding this is by using the new text recognition API that's part of it's going to be part of one of the future WinApp SDK releases. And to use it, it's very simple. First thing you do, and this is the pattern that we use for all the APIs, is you request for the API to be available. And what this does is actually request the model to be available on the device. If the model is not downloaded on the device, it will prompt Windows to download that model to make it available to the application and to all the applications on the device. And once that's done, then you can create that model, load that model into memory, and then use the API to pass in an image to get back the location of where the sentences are, where the words are, as well as the orientation. You saw in the application that this was at an angle, and I was still able to recognize it, and was still able to render all the UX I needed on top of this to be able to select the text, because I was able to get that information from the API. Additional things we can do here is beyond audio, is we can also, beyond using the APIs, we can also use models. We can use a lot of open source models out there to make our application great. And there's so many out there. One of those models is Whisper, which is a model by OpenAI. Allows you to recognize audio, transcribe audio, as well as translate audio and other things. And we use that with videos, and we use it with audio. For example, here I've attached the video recordings for my classes at school, and I was able to get the text for what the professor was saying. I can get the actual timestamps of when that was taken. And we're doing this by using the open source version of the Whisper model, and we're using it alongside a library called Onyx Runtime. Now, the model, we can actually go and navigate to where we got this model from. We got it from Hugging Face, but we used a tool called Olive, which is a tool by the Onyx Runtime team to allow developers to convert models to target a specific hardware or to optimize models for a specific need, whether they need a model to be very performant or they need a model to be very accurate, and depending on which hardware it needs to run. So we're using one of the examples from the Olive runtime here to take that Whisper model from Hugging Face. In this case, they have an example of Whisper Tiny. There's different variants of Whisper. There's different size, and they run different speeds and different accuracy. So we got this model, we downloaded this model, used Olive to convert it to Onyx so we can actually use it alongside the Onyx runtime. So we have it inside of our application. You can see here we have a few versions of it. We have tiny and we have small. Difference here being is the tiny one is very small, but it's not that accurate, versus the small one is a bit bigger. It might run a bit slower, but it's more accurate than the tiny one. And there's obviously bigger sizes going from there, and you can use them depending how you need to use them. So the first things we do is we use the Onyx Runtime API, which is the inference session here, to pass in that model path, the Onyx file itself, to the inference session. And then when we want to actually transcribe something, we need to get the audio data and then pass it through the model. Now, one way to find out how to do this is to use an app called Neutron. So I'm going to show you how that works right now. So if I open up this model here, you can see here, they're just Onyx files. The app, I'm using the web version of the app here. I can just drag this in here. Allows you to actually inspect the model and look what's inside of it. In this case, you can see here, just like any model, it's a graph with different operations that runs on top of the weights. But we can actually inspect the different inputs that the model has. In this case, you can see here, this is where the audio data is coming through, and then the different options that you can provide to the model. And then the output here is just a string, which is the recognized text. So we're doing the exact same thing inside of our application here. We are using that inference session to run the model. Before we do that, we set up our inputs. This is where we're setting up that audio tensor, which is just a set of floats that represents our audio data. We have properties that we've set up. We're also using, we're setting the logits preprocessor, which is allowing us to get that audio timestamps that's just documented for the model. We're setting up the language. And then simply we're calling run on that inference sessions with those inputs to get that string back. And once we have that string, then we can process it and we can do whatever we need to do inside of our application to run it. So in this case, when I run the application, I have an application here. For example, I have an audio file that my coworker has sent me. I'm just going to copy it here from WhatsApp, paste it in the application, and then it will process for a bit. It's transcribing. And we can see here, it transcribed it immediately, add it to my application, and I'm able to both play it,
I'm gonna miss a class today,
as well as see the transcription, and it's all now part of my notes application directly built in. That's part of that. So I now have my notes, I have videos, I have audio files, I have photos. What really my application misses or needs is a way for me to be able to search all of this content. And AI can absolutely help us to make this a great experience for our users by using a method called semantic search. And semantic search, if you're not familiar, is the ability to search for content not by its content itself, but by its meaning. So that way you can search for a cat by searching for a lion, or you can search for whatever it is just by what it means, not just by what the content it represents. So in this case, I can search for, let's say, number of parameters in a function. I know that's what the professor was talking about this. And I can see that it took me to the lecture 2, where my professor was talking about functions taking as input 0 or more inputs, which is the exact same thing I'm searching for, but in a completely different way and rephrased in a different way. But the meaning is the same thing. I can click there and it takes me directly to where that thing is. We're doing this, again, with an open source model that allows us to get a vector representation of content. And what that means is that I can take a piece of string and I can convert that to a multidimensional space by its meaning. So that way I can map multiple pieces of content and I can get the distance between those pieces based on what they mean. So all the animals like cats, dogs, etc., will live maybe in one piece of the space, where, let's say, different, like my computers and different types of technology might live in a different area in that space. So that way when I'm trying to find something, I can get this vector representation and find where that's located in that space and what's closest to it. The way we're doing this is by using the model called All-Mini-LM-L6v2. It's a great name. I'll give you that. But this is a model that's already readily available on Hugging Face. It's an Onyx model already in the Onyx format. You can simply just download this from the Hugging Face website and then use the Onyx runtime again inside of your application to run the model. The way we're running the models is exactly the same as in Whisper. So I'm not going to show you exactly that code, but what I want to show you is how we're actually doing the search, how we're doing the comparison. So here's that search function that we're running. I'm going to put a little quick breakpoint right there. I'm going to run that search one more time. Let's go ahead and walk over that search. So let's try that one more time. Let's run that search. We just hit our breakpoint. There it is. So the first thing we do is all the content that we have in our application, the notes, the videos, the audio, the pictures, we've already ran them through the model and we've stored them inside of a database based on their vector representation. And that's where the stored vectors are. You can see here we have about 490 of those vectors. And if I open one of them, you can see its vector representation. Here it is. Essentially a big list of numbers. About 384 numbers to be precise. So it's 384 dimensions in that vector space. Now that we have those 490 vectors based on our application, we can get the vector for our search term being number of parameters in a function, which is just another float of 384 numbers in here, same thing. And then to get the distance, we can actually use this function here called cosine similarity that comes as part of .NET inside of the tensor package that allows you to get the distance between two vectors inside of a multidimensional space. And we calculate the distance between our search term and all of the vectors on our space. Now, there's many ways to do this. There's databases out there that handle all this stuff for you. We're doing this in a very simple way here to kind of illustrate how this works. But once we have the distance between our search vector and all of the different vectors that we already stored in our database, we can get the closest matches, which in this case was the lecture 2 with that specific point in time, and we're able to point the user directly to where they need to go. So we can continue here, and it takes us directly to that same experience again, which is really great. Now, one way to actually make this experience even better is to use language models. And language models, I'm sure everybody's already familiar with language models like ChatGPT and GPT models or any of the other models that are very popular today. But what I want to show you is how you can actually run those language models locally on your device, so that way they run completely offline. In fact, I'm on Wi-Fi right now. I'm going to go on airplane mode. Everything I've shown you so far has been offline. But I want to illustrate a point that all of this stuff actually does continue working offline in here as well, which also turned off my mouse. Of course, I'm going to turn my Bluetooth back on so I can use my mouse. There it is. So one of the ways we're using a language model side application is, for example, for summarization. So for example, I can select all this text. I can say summarize, which we're going to send this down to a model, to a language model locally on the device to actually go ahead and summarize for us as part of that. So you can see here, the model picked up the task and is summarizing our notes to make it easier for us. So and this is, again, running completely offline. We even have a little disclaimer here that says everything is running offline on top of your application. We're also doing things like autocomplete inside of our app. So for example, let's say functions take, and let's see what this is going to go to autocomplete with. Inputs, process them, and process outputs, right? It actually did the autocomplete as part using that language model. But we're also doing things that are beyond just showing text and generating text. We're also using them to help us with reasoning on top of text and help us understand what the text means. So in this case, we have a feature to help the user quickly see what their to-dos are for their application. And we're rendering them in a more familiar UX rather than just a chat window. And we can use the language model to take what this content is, reason over that content, and then give it to us in a way that's more structured, so that way we can use it to either act on it or represent it in a more visual way to the user. The way we're doing this is we're using a library called Onyx Runtime Gen AI, which is yet another level above the Onyx Runtime for running language models. And in this case, we're using Phi 3, which is a small language model by Microsoft, but you're able to use many other models with this library. You can use Llama 3, you can use Mistral, Gemma, whatever model out there that's kind of small, that kind of works, you can kind of use this with this library. I can show you here the dependency that we have on this library. It's called Microsoft ML Onyx Runtime Gen AI, and that's the specific library that we're using to run this. And then the model we're using for here is a model that we downloaded from Hugging Face directly. Let me just go back online so I can show you the web page for that. So I can actually just search for that here. Phi 3. There it is, Hugging Face, and this is already Hugging Face as well. And there's many different variants of this model. There is a variant that runs on the CPU and can run across devices. There's a variant that runs on CUDA and NVIDIA GPUs, and there's a version that runs on DirectML. Now, if you're not familiar with DirectML, DirectML is an abstraction API that allows you to run models or run machine learning tasks and abstract away the hardware, the GPUs below it, so that way you can run them across the wide variety of GPUs that run on Windows, whether that's AMD, there's Intel, or NVIDIA as well. So we've downloaded one of these models to our application here, and we've put it inside of our folder. There it is. That's the Phi 3 files that we got from Hugging Face. We've passed them on to our Gen AI API, and then we're simply using their simple API to just generate tokens based on what the user, whatever the prompt is. So whenever we want to send something to the model, we use this prompt that's specific to Phi. Every single model has a different prompt way that they expect the data to be sent. So in this case, Phi expects that in this specific format where it wraps the system prompt into those tokens right there. And then when we want to get things like summarization, we simply just ask the model to say, hey, summarize this text in 3 to 5 bullet points. Or we also have a function to fix spelling, where we say, hey, fix up the spelling in this content. Or in this case here, we also have one to autocomplete, where we say, hey, you're an assistant that helps user autocomplete. Please complete this beginning of the sentence for the user, and you can be more specific as you need to. And then for the to-dos specifically, we're actually being a bit more specific, where we're saying you need to summarize into to-do items, but please use a JSON array format to respond to me, so that way I can take that output as JSON, but either convert it or use regular expression to get the actual information from there and then act on top of it for my experience. Now, the cool things here is that I can actually combine multiple of these models into functions that can actually do much more than that. So for example, you saw me do semantic search, but I can also use semantic search alongside a model to ground the model to the information that's within my application and allow the user to ask the model, to ask Phi about anything that's inside of my application, and then Phi can respond to it. So instead of the user just searching and looking for the information themselves, Phi can actually summarize what the user has found through a pattern called RAG, or retrieval augmented generation. So to do this in action, to see this in action, I can show you here real quick. Is we have a little button. I can ask the model, let's say, when are office hours for CS10? Now, there's no reason why the model should know anything about CS10. This is my class. It's not something that's maybe might be public. It's maybe something in my notes or whatever it is, but it's still able to answer that question and even provide me the source where it actually got that information. And the way we're doing this is whenever the user asks a question, we first run a semantic search on top of that question to get the information about what the user is looking for. And then we feed this question to the model and say, hey, can you answer this question that the user has asked? Here's the contents of where you can find that answer, and go ahead and summarize that answer for the user. So that's exactly what we're doing right here. Instead of instead of ask for content async, where we're running that search first, where we provide it to us as content, we're being provided the question, and we're asking the model to answer that question. So we're saying, hey, you're a helpful assistant answering questions about this content. Your system message, that's your system message. Here's the content, which I'll show you what that looks like in a second. And then here's the question the user passed in. So let's go ahead and ask the same question one more time. Let's see, when are office hours for CS10? You can see here we hit a breakpoint inside of our semantic search function to find the content. And then now we have the content within here, which is essentially just a big piece of text of that content that we found. And in here somewhere it says, hey, okay, yes, Tuesday, tomorrow, 10 to 11 is office hours that are within that video. So we're asking the model with that content to answer the question, and given that context, it's able to do that and provide that answer for the user. All right, there it is. And then go back, and we can go back directly to that point inside of the video. Okay, so now we saw how we can leverage both the APIs that are available to us through the Windows Copilot runtime, such as OCR, and we also saw how we can bring models, open source models, and use them alongside the frameworks and tools that are available through the Windows Copilot runtime, such as the Onyx runtime, such as DirectML, Olive, and other tools in there as well. One of the best ways to actually learn about this, and the project that I showed you here is all open source. If you go to learn.microsoft.com/windows/AI, you'll be able to learn all about the Windows Copilot runtime. In fact, all of the samples are directly there. So you'll be able to find this sample alongside other samples that allow you to show you how to use the Windows Copilot runtime. Now, just to recap, there's already a ton of experiences built with the Windows Copilot runtime, both inside of Windows 11 and part of the applications that come as Windows 11, but at the same time through applications that you might be already using that are already out there. They're using open source models and APIs. And one way to learn how to do that is just by using those applications and learning how they actually accomplish what they are doing. In terms of the APIs are available through a library called the Windows Copilot Library. Now, this is a library that exposes a set of on-device models that ship as part of Windows that will allow you to leverage those models inside of your applications directly through a very simple API, just like I showed you with OCR. Two of those APIs are going to be available in the upcoming experimental releases for the WinApp SDK. One of them is PhiSilica, which is a language model that's specifically optimized for the NPU, allowing you to leverage that without you having to pull in any kind of model within your application and leverage the model that's already on the device or download it through the API. And the API is very simple to use. As you can see here on the screen is you can make the model available and ask Windows to download that model for you to make that available on the device. If a different experience has already done this, the model will probably already be on the device for you to use. And then you can simply load the model in memory with create a sync and then send a prompt to get a response back within your application. And then you can do similar experiences like I showed you in the Notes application with this model that's already built into the platform. And then following the release of these two models, we'll also have additional APIs available, things such as vector embeddings to allow you to do things like semantic search like I showed you, and RAG, text summarization, and many more APIs that we're working on to make available as part of the API and easy to use library. Beyond the library, when we get to the bottom layer of bring your own models, that's when we get to the actual APIs and frameworks. And DirectML is a single hardware abstraction API that allows you to optimize and deploy models across the whole scale of Windows devices, over the 1 billion Windows devices, whether they're running an AMD, an Intel, or an NVIDIA GPU. And we're also working to include NPUs under that umbrella as well, so that way you will be able to also target NPUs, as all the NPUs across the different silicons through DirectML. DirectML also supports 4-bit quantization, so that way you can make your models as small as possible while still maintaining accuracy, be able to run them across multiple devices. And then you can use it today. It's been available for many years now, and it fully supports the GPUs, and you can download it as a NuGet package inside of your applications. The Onyx runtime and Onyx and all its suite of tools allow you to use models cross-platform. Now, Onyx is a cross-platform and open source model format to represent model graphs, and the Onyx runtime runs across all the different platforms, allows you to run those models on top of any execution provider, such as DirectML. The Generate API I showed you is specifically for language models and generative AI. And it's available for you to use today with many of the different models, and it also supports different languages as well. And then Olive is the tool that I showed you for optimizing and making models optimized for the different hardware, or helping quantize them, or even fine-tuning models for whatever you need them to do. And then finally, one of the tools that you should probably take a look at is the AI Toolkit for Visual Studio Code. It's a great way for you to get started with language models and to experiment with language models. It allows you to download them and to try them out directly within Visual Studio Code. It allows you to also fine-tune and optimize those models using Olive. It wraps Olive into a really nice user experience where you can provide your own data and then fine-tune them for whatever you need. And then you can deploy this application either on the cloud or on your device. So hopefully this session was educational. There's plenty of more for you to learn and to try out. So I really encourage you to go check out aka.ms/WCR to learn more about the Windows Copilot runtime and to kind of stay tuned for everything else that we have coming up in the upcoming months. So thank you, and I hope you have a great rest of your day.
Hello, everyone. Welcome to our session. My name is Aicha Bash. I'm a cloud developer advocate at Microsoft, and John Miller is joining me today for this session. Hi, John.
Hi, Aicha.
And John is a product manager in Teams Toolkit in Developer Division. So today we're going to talk about how you can build custom engine copilots using .NET, Teams AI Library, and Teams Toolkit. So we have a full-packed agenda with live demo. We will start with Copilot stack, and we will dive in more into the custom Copilot area. And after that, we will introduce you what is Teams AI Library, and then how we can use Teams Toolkit, and we can leverage the library together. And we will actually build a live demo. We will build custom engine Copilot together today using Teams Toolkit and Teams AI Library using Visual Studio. So before we jump into the demo, we actually have a brief intro of all these. So John, why don't you take away and then get started?
Sure. Thanks, Aicha. So to get us started, let's back up one step and talk about the pillars on building copilots, all the way from low code using Copilot Studio, and you also have options like coding environments in Visual Studio and Visual Studio Code. So first, you have the choice to extend Microsoft's Copilot, and I think about these options as bringing your app to Microsoft's AI, and that's connectors and plugins fit into that category. But you'll also have the option of building your own Copilot, which is on the right side of this slide. And that is what we're going to focus on here. And I think about this as bringing AI into your app. So today we're going to show you how to do that with Teams Toolkit and Visual Studio. So let's start breaking down what a custom Copilot is in case you're unfamiliar. And at its base, a Copilot uses an orchestrator that sits on top of a foundational model. So this is the AI brain of your Copilot. And coming up, we're going to show, oh, let me go back one. So coming up, we're going to show you a few tools for developing these models and adding them with your data to suit your needs, like Azure OpenAI Studio. But it's important to note you can use any language model that you want. Models and data are just one level of the stack, though. So to start building a conversational interface, you'll need to add prompt instructions, actions for your business logic, event handlers, triggers, intent detection. There's a lot you need to add. So late last year, we launched a new set of tools that modernize Teams bots, and we call this the Teams AI library. And it was built on Microsoft's bot framework. And this is the foundational groundwork for a custom Copilot. The AI library is generally available now in .NET, JavaScript, and also supports Python. So finally, your models, data, and conversational interface will have to run in Microsoft 365. And we've totally modernized that. The chatbots look and feel to be just like the Copilots that you see in Teams. And so this means you have features like streaming, citations, feedback loops, AI-generated labels, and more. And Aicha is going to demo some of that for you coming up in a minute. So taking a look back, before we had the Teams AI library, the chatbot support was always in Teams, but building bots that felt natural to interact with was a challenge. Most bots relied on a limited set of declared commands, so like / commands or @ commands that you had to predefine, and it felt a little primitive and restrictive, and then the users had to understand what those were and how to interact with the app's skills. So, and natural language processing was pretty complex to build, and it was very expensive. So what it looks like now is you can use Teams AI library to address those challenges, and you can start to build your own Copilots or M365. So with the AI library, your Copilots can use language models to facilitate more natural conversational interactions with your users, and that can help guide the conversation into your app skills. So this means that you can focus on writing your business logic and not so much about how to set up all the language processing, and allow teams to handle all the complexities of the conversational piece and still get the benefits of using a bot like you did before. And overall, the Teams AI library helps you create more intelligent, personalized experiences for your users. So the AI library is a Microsoft 365 interface to a language model, and it uses techniques like prompt engineering, where you can add Copilot-like conversational experiences with built-in safety features like moderation, so you can make sure that your Copilot responds in an appropriate manner. And the library includes a planning engine that lets the model identify user intent. So this is how you can map your business logic to the conversation. So in the library, we talk about actions. So you can map those intents to actions that you implement, which are some code that you can write. So this is similar to tool calling or function calling that you might have heard of in other language models. There's also built-in support for all the OpenAI models, both in OpenAI and Azure OpenAI, but you can also add your own support for whatever model that you want to use. There's 4 steps to get started with the AI library. I'm just going to show you how to do it. But let me walk you through what they are right now. You'll start by scaffolding out the necessary AI components for your Copilot, and that includes importing the library, which is available on NuGet, and you can add to your project, and you can scaffold a new project with Teams Toolkit as well to get started. Next, you create the application object, and this represents your Copilot within M365. So that object will be used to handle incoming messages, process user input, handle AI-triggered actions, and then you can start to get creating your prompt, define the AI's personality, its behavior, inform it of any actions that you have in your code, and then you can implement Copilot actions. So that's your business logic. These are basically your function calling. And actions are the primary way your code interacts with the AI components inside the model. So actions can call external APIs, process data, or they can generate responses. They can do whatever you want. To make it simpler for you to get started with all this and basically streamline most of these steps, you can use Teams Toolkit for Visual Studio. It's an optional component that you can install as part of the ASP.NET workload. So if you already have ASP.NET workload installed, you can just go in and add the Microsoft Teams developer tools, which will install Teams Toolkit for you. It's a set of templates and tools to help you build custom copilots and apps for teams across M365. It supports automating a lot of the setup and debugging and provisioning that you need to run these experiences. And there's a bunch of project templates that we have for that, depending on what you want to build. So now I think we can hand it over to Aicha, and she can show you how to do all of this inside of Visual Studio.
Awesome. Thank you, John. I'm excited for this demo. So this demo basically covers what John explained us in the slides. We will actually do all of these steps, build all of these steps hands-on by just creating a new project. So I'm in Visual Studio, and I will create a Teams app. And you can basically give any name to your project. Today, we are going to create actually a career expert called Career Genie, and we can call it specialist. Okay. So we have a bunch of templates available, as John mentioned. These templates help us create scaffold projects from scratch, and some of them actually comes with Teams AI library from the first moment. So today we are going to use AI chatbot, but I also mentioned there are other templates available for us to use together with Teams AI library. One of them is the AI assistant bot. If you work with OpenAI Assistance API before, this template would be a suitable start point for you. So you can bring your existing OpenAI Assistance API and you can use it together with the Teams AI library. Today, our base is going to be AI chatbot. So we'll start using Teams AI library right away using this template. I'll create my project, and when it scaffolds, we will have a project from scratch. And this is actually regular AI chatbot, but it comes with Teams AI library from start. So our AI library already installed in our project, and we can start using the AI components and all of the steps that John mentioned previously. So before I run the project, I actually realized one thing I want to bring John in and ask. So I realized that there's a change in the project template, John. So now there is a Teams app where we have the files, and there's also the project itself where we have the code steps. Can you quickly explain what was the reason why you made this change in the project?
So the solution is now broken up into two projects. You start out with a Teams app project, and that is going to encapsulate like all of the files that are needed for Teams Toolkit. So this is the automation files, which you'll see in a minute with the YAML files, the environment files. And it's really a way to keep things separate. So if you want to implement your Teams bot or website or any of the capabilities that Teams supports over multiple projects, then you can do that. And it's a little easier to work with. And then all the Teams Toolkit related commands to help you provision and create things, you can interact with directly on the Teams app project. So it just helps keep things a little tidier for you in the solution.
Okay, sounds good. So in this case, all of the Teams app related files we have, like YAML files and environment variables, are under Teams app, and all of the source code we have about the project is under the program CS. So to start this project, we actually need Azure OpenAI keys, and for the Azure, to run this project locally, we actually need to bring Azure OpenAI keys and endpoint here. I already created those, so I'll quickly go to Azure and go bring my endpoint and keys here. So first I'll get the key, and then we can quickly get the endpoint from here too. Okay, once we're done with the environment variable, it's actually only a few steps to run the app. First, we will need to create a dev tunnel, and it's quite easy to create a dev tunnel. Actually, you can call it anything demo dev tunnel, and then I'll keep the tunnel temporary, and then access level you can put organizational, public, or private. For this demo, I'll just use public. And then the last step for us is preparing Teams app dependencies. This step actually does a bunch of stuff behind the scenes where it registers AD and also complete some of the required steps. So we will actually have all of the setup ready in our environment variables. You can check that you actually get Teams app ID, M365 username, bot domain, endpoint over here, and Teams Toolkit does all of that for you behind the scene. So while we're running the app dependencies, I also want to quickly run through what is available in our project. So first things first, to run this project, meaning to run AI chatbot together with Teams AI library, we actually need Teams AI library installed. And if you want to check how Teams AI library works and understand a bit better about the code, you can go to NuGet packages, and here you'll see that Teams, Microsoft.teams.ai package is already installed in this template. I'll quickly go ahead and update this. And quickly, I also want to go to Program CS and walk you through a quick code so that you will understand better how Teams library components work. So the first things, as John mentioned, is AI components. AI library brings us AI components where we can run models, planners, and a whole bunch of other stuff. So here, the first thing we see is Azure OpenAI model, which actually we use. It helps for us to call Azure OpenAI, or same with Azure, same with OpenAI model, actually, if you want to use OpenAI model. And after that, we have the prompt manager. Prompt manager manages prompt creation using the files under the prompts folder. As you can see here, we have the prompts folder available here. And if you extend it, we have a chat folder. And here we have config.json, which has all the settings for our prompt. And we also have the skprompt.txt. This is the place we actually define the characteristics and the behavior of our bot. So if I change this text and if I want to give more personality, this is the place I'm going to add all of my system prompt. So going back to the code really quickly, we finally have the action planner, and action planner actually uses LLM, large language model, to generate plans and call Azure OpenAI. This is basically the step that defines everything for our planner. And finally, we create the application, and application basically replaces the activity handler class in a typical bot framework bot, so that when we run the app, we return the app and we get all those LLM functionalities. Okay, so now I will run the app and we will test the plain vanilla version of this app. And then after that, we will add characteristics for Career Genie. So we'll have the career specialist support. And then we will also bring some data so that we can also search through our data too. All right, so our app is loading. I'll add, and then I can start chatting with my app. I don't expect a lot of information. This is just going to be a basic AI bot where I can ask generic questions, but more I add into the prompt and more I add data, our bot will be more specialized in the area of the expertise I want to add. So, while we're waiting, John, do you want to add anything in the code side where we add the AI components?
One thing I'll mention is, since this almost is finished, is that Teams Toolkit helps launch this for you. So you clicked Start Debug, and basically you can look in the properties section. There's a launch URL. So we use a special launch URL to open up Teams for you, and we plug in all the right values for your app and make sure that the right app is launched in your tenant. So that's all, logging into Teams Toolkit. So that was a step that you took before, is when you do the prepare team apps dependencies, you choose an account. That's your M365 account. Aisha chose her developer account, and that's how we know which teams to launch. So I think you're ready to start debugging.
Yes, awesome. So first things first, I'll just say hi, and then we will probably receive a generic hi. And then I can ask some specific questions like, can you suggest me any .NET developers? Assume that I'm a human resources in a company. I'm looking for .NET developers for a position to fill. But because Career Genie currently doesn't have any data set behind the scene, it only shares that, you can go to LinkedIn, Upwork, Freelancer, to find more people related to this role. But what I want to actually do is I want to add a bunch of CVs behind the scene of Career Genie and also add some prompts so we can define behavior and we can actually get more value out of Career Genie. Okay, so quickly, I'll go to Azure and I will define everything here and I'll show you how our data set work in the chat playground, and then we're gonna bring the same experience into Teams. Okay, so first, I already defined my index in Azure AI Search. I actually predefined the index, so it's a vector index data set already available in AI Search sample. And I'm going to choose the right index in a second. I have a lot of indexes, but resumes is the right one for this demo. So because my data set is defined as vector embeddings, I need to choose vector search for my search experience. So I will also choose text embeddings model so I can actually search over my embeddings data set. Search type, you can actually choose vector, hybrid, whichever is more convenient for you. For this demo, I'll just go for vector, API key, and then I will be connected to my data set in a second. Because it's predefined, I don't need to do anything. And before I actually chat with my data, I want to quickly show you how my data looks like. Here is a bunch of CVs. It's more than 30 CVs available in this data set, and all of the CVs are in native language of the people. So you will see CVs here in English, Chinese, Spanish, Turkish, so all the diverse CVs you can find. But because we're using vector search, so I'll switch on this content vector, we are actually doing all the search experience through embeddings so that we can get all the related data and we can basically have a pretty good search experience. I'll go back to my playground. I'll ask, can you search for .NET developers? All right, so now we see a bunch of .NET developers recommended for us, and we are also able to see their CVs coming through. And we should be able to work with this data. What we want to do as next is we actually want to bring this data set into our Teams app. I'll quickly switch back to my app. I'll actually stop this and then stop my app too. And I will update my prompts, prompt settings, config.json, and I'll also update skprompt.txt so that I will give some behavior personality to my bot, and we can actually chat with our data through Teams. All right, so let's start with config.json. And the difference between our app and chat playground is that quickly I want to show you here, if you actually open the JSON, now you see here that we have data sources. We're actually going to do exactly the same thing in our config. We will add data sources so that we can connect with our data source from our Teams app too. Okay, so I'm going to update this completion section. I already prepared this section for you, but I'll quickly walk you through what it does. So we will update the properties in this completion section. And I'll quickly section them in. Okay, so some of the properties were already here, these 5 of them, but what I included is include input, include history. These are defined as true. And also we added data sources, which is the key property where we define that we are using Azure Search, and we have the endpoint, we have the index name, resumes, exactly the same with our chat playground. In the authentication, we have the Azure AI Search key. And finally, we define the query type, and we also bring our deployment name for our ADA model as well, which is text embedding. So once I save this, that means that we actually have our data set ready for our app. And finally, to just bring a little bit of behavior and characteristics in Career Genie, I will update the prompt as well. And let me copy that piece for you too, and we can quickly have a look. So here we define that you're a Career Genie specialist named Career Genie. So you are friendly and always greet users. You like using emojis, and we also use data coming from the Azure AI search as well. So let's rerun the app and see how the behavior differs and if we will be able to get any responses, any CV recommendations from Career Genie too. Okay, I will add this, and then now I should be able to see Career Genie using emojis, being more friendly, as well as when I ask about .NET developers or ask about people who have 5-year experience, then I should be able to get some CVs other than recommending me to go to LinkedIn or Upwork, basically. So I think I should be able to close this and directly chat with Career Genie because we already debugged. What I will actually do is I'll say hi again just to see how Career Genie responses to me. So I'm expecting some excitement. Yes, so I have emoji, I have the introduction as Career Genie, and now I can ask more about, can you search for .NET developers? Okay, so I think I'm going to be more specific, and I'll say, can you suggest .NET developers who are experienced 5+ years? Okay, so when I'm more specific, I think there's more data to work. So we have more information. We already have 3 different CVs coming through, and we also have citation thanks to Teams AI library. This is built in actually. And here you can see a bunch of different profiles and people with 5+ year experiences who are expert in .NET coming through. So this is what I wanted to show today, and if you want to learn more, you can also check out our documentation, and I'm handing back to John, John can walk you through a little bit more about what you can do with Teams AI library.
Awesome. Thank you, Aicha. Really good job. Awesome demo. Love the Career Genie. As Aicha mentioned, we have some more cool things coming in the AI library. So we call this the Powered by AI Kit. So there's a ton of new UX improvements for custom copilots in Teams. And that's things like I mentioned earlier, the streaming UX will be coming soon. There's AI labels. There's automatic support for citations when you're using Azure OpenAI Studio and the Azure On Your Data support like Aicha demoed here. There's APIs in the library for doing feedback loops. So this is the thumbs up and thumbs down on the responses that you can add. And there's handoff support if you want to interrupt between your custom Copilot and Microsoft's Copilot and being able to present in the stage. So just to recap, we broke apart the components of the Copilot tech stack from the foundational models to the Teams AI library, and there's all of the UX features that we have in Teams. And then all of that put together is a best-in-class solution for building and deploying your own Copilot in Microsoft 365. And I just showed you how you can get started quickly using Teams Toolkit and Visual Studio and be able to build with .NET. If you want to try it for yourself, you can check out this link, aka.ms/try Teams Toolkit. That will take you to our page on building custom Copilots for M365 and give you all the information on what we have available and all the tools that you can use to do that, including Teams Toolkit. And here's some more references for you. The Teams Toolkit, most of the project is open source, so you can check out the repo. There's lots of other resources there to learn more about what's available in the toolkit. The AI library is on GitHub as well and is open source, so you can check that out. There's lots of cool samples in there too that are not part of the project templates that you can learn more from. And the Powered by AI UX toolkit is part of that, so there's a link there to get there. And something we didn't cover today, but you may want to check out, is the Adaptive Card Starter Pack. So this is a way, as you start to build out your custom Copilots and you want to improve the responses with some beautiful ways to display information, you can use adaptive cards in Teams, and there's some cool new starter packs out for that. And here is a link for you to give some feedback and get started with .NET and AI. You can go ahead and scan that and take a look at that. And that'll take you to the .NET for AI page, where there's tons of other resources, not just for teams and what we showed, but lots of other cool stuff that's going on at the session at the .NET Conf. So thank you, and thanks for listening.
Thank you. Bye.
All right. Thank you so much, Nicola, Aicha, John. Now I know how I can get Copilot into my applications, whether it's on Windows, even get some stuff into Teams. That sounds interesting to me. All right. We've had a full day of content here. My gosh, I hope you've enjoyed it. All of these sessions, they're recorded. Maybe you're joining us late. They're recorded. We're going to have them on YouTube for you in just a few minutes. We've been building a playlist behind the scenes. The team, our amazing team of editors and production staff, they're going to put that together, and we're going to have it published and available for you in just a little bit. All right. Big thanks to our friends Cam and Matt, who have been working behind the scenes diligently, putting all of the video content together for you. Now, there's all kinds of great things about artificial intelligence in .NET that I want to make sure that you have at your fingertips so that you can do more. All right. Check out some of the slides that I have for you here. Of course, we've got Learn modules and content available for you. Check them out at aka.ms/.net Focus AI/learn. If you don't want to key those in, go ahead and take a picture of that QR code. It'll take you to the same place. Now, I've got a survey for you. Make sure you fill out the survey. Let us know what you think of this event. Let us know what you think about your .NET experience working with AI. aka.ms/.net Focus AI/evaluation. Once again, that QR code will take you to the same place. And over the next month, we've got a full set of live streams and challenges, some tasks, a little bit of homework and puzzles for you to check out as part of our AI challenge and live streams. You can join us and follow along at aka.ms/.net Focus AI/credential challenge live. It's going to run right through September 20th. Make sure you join us at that website. You can click the QR code and follow and learn more about our AI challenge. Now, this doesn't just stop today or at the end of that challenge. Coming up in November, .NET Conf 2024, featuring the launch of .NET 9. This is a big event for us. It's 3 days long. We've got more than 70 sessions as part of this event. A bunch of content from our .NET teams. We're looking forward to hearing from them. Some of the folks you've heard from today will be speaking at that event, but you can be a part of it, not just watching, but you can be a part as a community speaker. Our third day is wall-to-wall community speakers, folks from all over the world. We're broadcasting for 24 hours straight. You can join us at .NETconf.net. There's a call for content link there. You can submit some sessions and let us know how you're using .NET to build something cool. Maybe it's an open source library or a framework, or maybe even a game. Check it out at .NETconf.net and join us in November for this amazing 3-day online event that you can watch with us. We wouldn't be here. We wouldn't have gotten this far if it wasn't for some of our great sponsors. Big thanks to these companies: Growth Acceleration Partners, Iron Software, Code Magazine, Meshius, Progress Telerik, Octopus Deploy, Sync Fusion, ABP, Avalara, and Nostis have done a great job promoting and telling all the world about the great things that we have as part of our .NET Conf Focus on AI event. I want to make sure that you know that not only has there been all this great content we've shared, we've got our sponsors, we've got all the things going on, we've got a complete collection of all the resources you need. Your one link that does it all, aka.ms/.net Focus AI/collection. Click that QR code and you can learn more about all the things that we've presented, all the videos, the Learn modules, the AI challenge. Check it out at that address and at that QR code. All right. I think that's everything. I think we're just about out of here. Our survey and our evaluation for the swag bags is done. Big thanks to everybody who participated and entered there. We'll send out with our wrap-up blog post a list of those folks who have won the swag bag. You'll be contacted via email. And I want to put out a big thanks to the folks that helped make this event go. We got to thank our friends Jamie Singleton, who helped plan and coordinate this event. John Galloway, who helped coordinate a bit of the content and items that have been going on behind the scenes. Mehul Hari, who's helped us promote and get the word out about the event. Huge thanks to everybody on the team, all of our folks in the studio, Cam and Matt and our editors back there. Thank you very much for helping out with .NET Conf Focus on AI. My name is Jeff Fritz. Make sure you stick around, .NETconf.net, our website, so you learn more about our next event coming up in November, .NET Conf 2024. I'll see you.